Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.
Please take your seats. I will do a little bit of the talking. It will be the most boring part of the entire event. So if you survive that, you will be fine. So my name is Maciej Rys. I will be, for better or worse, the host for the next 2 days. This is the third edition of Rtc.On conference, the conference that we as a software mentioned. Yeah, let's give it a hand. Rtc.On is the conference that we as a software mention strive to organize in order to connect the multimedia community, all of the practitioners and builders to get together, have this more in-person experience. As I said, this is the third edition, second time in our software mention office here in Krakow. And I am very excited for this next 2 days because I believe that this year we managed to get an extraordinary agenda with brilliant speakers. Each year, as a conference, we strive to grow, get better, maybe except for the host, because I was here last year and here I am again. Anyways, you know, I will be the weakest link for the entire event, so if you know what are the expectations for the next 2 days. I'm just wondering how many of you were here last year? If you raise your hand. Okay, cool. There are a couple of people. Welcome back. So you might have heard the story I'm going to tell you, and I'm going to tell the story because this is the longest time slot allocated for me over the next 2 days, so I'm going to make use of it. And there will be a little bit of an origin of software mention. I did speak about the origin of the conference, but to give you a little bit more of context, Software Mention is a software agency. We've been around for, I believe, 13 years. Maybe in November we will enter our teens years, so it's going to be exciting times. And as I said, we are a software agency, but a different kind of software agency. We can build virtually any software product for you, especially in the mobile world, the multimedia world. We have 350 very smart engineers working predominantly from this magnificent office space. But also, what I believe that sets us apart and builds the unique culture of the organization is that we strive to provide some value to the community, mostly from open source contributions. So for the multimedia world, it all started 8 years ago with something that is still going strong called Membrane Framework. It's an Elixir-based tool that you can virtually build any multimedia processing pipeline. Across the years, we've added to the mix our own pure Elixir-based implementation of WebRTC, because we are big into real-time processing. Also, we launched 2 commercial products, and then a little bit of a spoiler alert. During the breaks tomorrow, there will be a little bit of a fun that demonstrates those technologies. And open source community means people means connection obviously is the best to foster them having the face-to-face interaction. So we've been building that for mobile, hosting App.js conference, which is like 500 people each year, and we strive to make the same impact in the multimedia world. So this is the origin story of the Rtc.On. So thank you for Software Mention for doing that. Obviously, I would like to thank our great sponsors, Stream and WebRTC Ventures. And I think that I bored you enough, but before we head to the first talk that I deeply believe is going to be fire, a few housekeeping things. So the agenda will be displayed here. All of the coffee breaks will be also displayed on this screen. There is also one screen over there. After the talks, there will be a Q&A session. For the organizational purposes, if you have a great question, I guess all of the questions will be great. Please raise your hand. Someone will approach you with the microphone. So the people who are watching us online on the stream, they will be able to hear what the question was. There will be coffee breaks. When they are about to happen, I will tell you. Don't worry. We're gonna take good care of you to keep you caffeinated. And yeah, there is also an office map. So you can find a way where are the restrooms, where to get coffee, and all of that stuff. So without further ado, I think that we can move to something that everyone has been waiting for. Daniil Popov will be our first speaker. Daniil, please welcome to stage. And when Daniil is going to be setting up his laptop, and I will do maybe a quick intro of him. So I met him yesterday for the first time, and I already had in mind the introduction because he's a head of technology at CyanView, and they streamed the Super Bowl, which is a great event, and they did it with Elixir. Elixir is close to my heart, so I wish it was me. It wasn't, so I was a little bit jealous, but he's a fascinating character, not only because of the things that he achieved in the professional space. It turned out that he managed to become a CTO within 9 days, promoting from the regular software engineers to CTO in 9 days is quite an achievement. Also, he flew 150 times during the COVID period, just in 1 year. So he's a very capable man. Welcome to the stage. The floor is yours.
Yeah, so before we start, thank you very much, Software Mention, for inviting and hosting all of us. So that's been a great pleasure. So yeah, and today I'm gonna talk about CyanView and what we do. So I think we are a bit of a unique company because we build the hardware and software for the super niche market. So today we're gonna talk about from Super Bowl to Olympics and yeah, how CyanView does that. So a couple of words about me. So I've been doing the Elixir development for the past, I don't know, maybe around 5 years. So I'm working with CyanView primarily. So I still have some open source projects. Maybe you know me as a Phoenix Analytics, if anyone saw it on GitHub. And yeah, sometimes I do as well some help with the staffing and consulting for the Elixir. So what we're gonna cover today, so essentially how the small startup like us, I mean the small company, powering like the largest broadcast events. So what are the challenges? And of course, we're gonna talk about Elixir. And I try to highlight the most interesting parts, probably not very common ones. Yeah, we will go a bit in a deep dive. I'll show how we organize the code and as well, actually this year we started using LiveView straight on the devices. And yeah, we're gonna talk about a bit our future plans. So yeah, CyanView. It's a Belgium-based company founded by 3 people and 9 employees in 9 years, and that's it. So we have the linear growth of 1 employee per year, and we're trying to keep that. So we produce hardware and software. So there is a lot of terms which are probably not known to you, but I will try to make sense during the talk. So RCP is our, let's say, flagmanship. It's a remote control panel, and I'll show the photos later. We have as well the VP4 for the video processing, custom REMI relay server, and now we started building a lot of software on top of our devices to become even more flexible. So our solution is used on Super Bowl, Olympics, NBA, football matches, Amazon Prime, fashion shows, almost everywhere where you have the broadcast events. So one of the largest capability, it's 200 cameras controlled from a single device simultaneously, and it was during the Le Mans race. So we have 0 marketing. And when I put 0 marketing on a slide, our CEO, David, he came to me, he's like, no, please don't put 0 marketing. Some people claim that we have a website and it costs us money. So yeah, we do have a website. And originally the company started because back in the day, cameras were not designed for the internet use. So especially when you need to control the camera, it was not possible back in the day. So that's how the idea of the remote camera control and shading actually started. So this is our devices. So RCP, it's our flagman. So with it, you can control more than 190 cameras, which we support at the moment. So some of the cameras, as I mentioned in previous slide, were, let's say, old and do not support IP-first approach. You have CIO, which can convert the serial into IP. We have Rio, which helps to do the remote production and control cameras using 4G, 5G, IP to IP mesh, and I mean, the flexibility of setup just limited by your imagination. So we have as well the VP4, which is the color corrector for the cameras, which do not support the color shading on its own. And a few other ones, which we're not going to cover today. So yeah, that's us. It was the last picnic. That's the entire team. We have, I think, now around 10 full-time employees and 2 part-time. So before we jump into our famous Olympics Beijing case study, raise a hand if you ever watch a football match. All right, so almost everyone knows what I'm talking about. Have you saw that there is multiple angles which are filmed from different cameras, different models, different brands? And you're not gonna believe me, but most of them display the green color differently. And so once you see the picture on your screen, our job to make sure that you see the same green from all the cameras. It's called color shading. And during the Olympic Games in Beijing, so there was a challenge. So you have the production, the studio, which is filming, located in Beijing. And you have Panasonic PTZ cameras. PTZ cameras, the ones which you can control the angle. And the control team was sitting in Paris. So, and Panasonic not really designed to do the, control over the network. So it's only for the local use. So the solution was simple. So you plug the CyanView devices next to each camera. Through our custom REMI relay protocol, we're able to formate the cluster of MQTT and seamlessly connect it with the team in Paris. So we as well have a custom proprietary protocol which helps us to reduce latency. So as a result, we got the 0 broadcast failures during the Olympics. And this is crucial because you don't have not even a chance, but there is no way that you can fail. And yeah, so sub-second response rate and millions of MQTT events were processed. And why it's famous? Because I think the first time when it was published, we went #1 on Hacker News. That's how we ended up being a bit known in the Elixir community. So yeah, now let's move to the Elixir part. Yeah, here I try to outline some of the setups which we have. So if you would like, you can scan the QR code and you will have more expanded version. But yeah, so for the small specialty cameras, you can connect them via CIO and then connect it to our RCP unit and you will be able to control and shade them. Then you're able to get the cinematic cameras, connect the Vivo, and as well connect to our RCP and control it like you want. And of course, the diagrams don't really make sense. So, and by nice chance, last week we were on IBC where we had all of those setups actually up and running and working at our stand. And I just discovered yesterday that I can do this. So, yeah, here, for example, people are controlling from our RCP through the CIO, the small PTZ cams, small specialty cams. Here, for example, the red camera, which is connected to our Rio device and can be controlled from anywhere where the network is reachable. So here was one of our, let's say, latest integrations. So now you can control the lenses using the Seagate. So it's quite flexible. And that's our flagman. So this is the RCP with the Iris joystick. So essentially, yeah, the biggest toy we have. So why Elixir? So we have 190 plus models integrated and supported. We have multiple video routers, switchers, and video processors. One of that we develop on our own. So there is a lot of different protocols, starting from the TCP, UDP, and ending up with exotic like Ember Plus, and absolutely custom binary protocols. So that's our challenge, and we have to deal with it. So essentially, Elixir was the perfect choice for us because obviously, we don't have a chance to fail. So Elixir is known for the fault tolerance. And besides that, we're keeping all the processes alive and have a retry mechanisms. For us, it's critical as well to hold the C code in the process and as well bring this reliability to C code. So as you know as well, Elixir and Erlang has the great ability to coordinate million devices. So that's essentially what we need. So on a big event, it can be, I don't know, more than 200 cameras connected to multiple RCP units, and we need to control them flawlessly without any errors or mistakes. So with the help of MQTT, which is the lightweight message broker, we actually achieve that. I will talk as well a bit, so what's custom we added to the MQTT. Obviously, supervision trees, we use it everywhere, and a lot of recovery mechanisms. So sometimes camera can go offline, sometimes it can go back, and what's gonna happen if you send the command, so should we retry it, or it's already there. So there is a lot of unknown state, let's say, and we are dealing with this and recovering from that. So IP-first approach in the Erlang and OTP itself, you have a lot of tooling which comes to the internet and IP. So this is like really greatest library probably to use. And another thing which is critical to us is the binary pattern matching. So I will stop on the next slide and explain why for us it's critical. So yeah, essentially, David was saying that the broadcast is a business where you only get one chance to prove that your tool is working. So the reliability is the king, 0 failures. And actually, we started with Elixir, I think, around 7 years ago, so by main developer, who was the first, Gillen. And he thought it's going to be a great idea because it's so versatile and covers all our use cases. And we started using the Elixir. So yeah, why binary pattern matching? Obviously, since we run it on a tiny devices, they have, I don't know, Ethernet power line, and that's it. So it's usually 2 or 4 ARM cores, and it's not gigabytes of data, like gigabytes of RAM like you have on your laptop. It's very small. So binary protocols used to communicate with a lot of hardware, and for us, what is critical, it's zero copy parsing, so that we don't have a lot of memory spikes and we don't copy paste anything into memory. So we just parse it directly, and in the Beam machine, actually pattern matching is compiled to much more efficient code, and it does it very fast. So in our code base, you will see a lot of things like that. So just a bit on the code organization, because when I joined, I mean, I knew that monoliths exist, but we have a next version of monolith, as I think. So we have a lot of internal apps, more than 40, and based on the device, we create the specific build where we put the different capabilities together, and then we compile it and put it on the device. So essentially, once you need to update your device, we create the new binary, upload it on our website, and anyone who wants to update, they pick the latest version, upload it on their device, and in 5 minutes they have latest firmware. So another, let's say, use case in our industry, if something stopped working, because, I don't know, camera changed the protocol or anything, you're always able to put the previous version back and proceed as it was before. So yeah, custom MQTT. We had to design in a way how we're going to communicate between all our devices and components. So one of the features which we have, so the last value set for the camera or the video processing board, so once client subscribes, you get all this data back so that you can get the latest state, which is now held on the device. So this is how we solve the issue of like some maybe race conditions and dirty reads and dirty writes. So yeah, this year we started using Phoenix LiveView on our embedded devices. So one of the first thing which we had to do, we have a color corrector box. If someone is interested, yeah, put some QR codes with the video, how it works. So essentially, from MQTT, it goes to Elixir, and then in Phoenix, I had to implement a batching mechanism so that we do not re-render everything at once, and then it goes to the LiveView, and this is raw SVG plus JS hooks. 0 libraries used, nothing. So on the device, it was running quite well. It was much more responsive than our previous app. So, and here on 2 ARM cores, you can process, I think, approximately 300 events per second, LiveView events. So as well, what we use on that device, it's a 3D LAT computation. So we gather all the parameters from the LiveView, which goes into embedded Ecto schema, and then 3D LAT is computed via C code. So that's one of the use cases which we have on the devices right now. So currently as well, we were presenting at IBC the dashboard. So we bring even more flexibility to our setup. It's as well LiveView, and as you can see, Daisy UI. You will be able to control absolutely any device which we currently have from the embedded device. So which means that you might plug just the Rio device next to the cameras and have a laptop in your production, and that's it. So you we bring that flexibility as well. So I was able to optimize the LiveView rendering to 2,000 events per second. So you can get all the data, all the details from your cameras, colors, gains, white balance, absolutely everything in the real time. And I was actually surprised how it was easy to make the side panel, which is an iframe, but I as well use it on the mobile view. So the great reuse of the resources. So yeah, a bit about our future developments. So we go more and more towards the remote production, which Elixir allows us to convert from devices and go more into the cloud. So we're preparing as well now the cloud dashboard, so you can control all your cameras from the cloud solution. We work on the new OpenGear 4K FPGA, so the small color box I was showing you before. Now we are working on the new device, which will be bigger, greater, faster, and of course we will use the Elixir and Elixir LiveView to build a color correcting app on top of that. So one of the things which I was actually working this summer to build a prototype of using Membrane on the device to have the small vignette preview of the stream. So once you have a picture from the camera, and if you need just to do the color correction, you don't need 60 frames per second. It can be 5, 10 frames. And yeah, that's still work in progress. So maybe one day we will have a Membrane running on our devices as well. So I think that's it from me. I hope you learned something new. And yeah, it was CyanView.
Question times. Does anyone have any questions? Please raise your hand. There is one question over there.
Yes, I was a bit interested about the color shading. Do you have presets for different cameras, or do you go by camera?
You go camera by camera, but now in the dashboard application, you will have some presets which are allowing you to, let's say, apply this, and it's gonna spawn all the events on the MQTT, and camera will be, controlled from the template.
And do you have like some color grading table that you use for that, or just go by, let's say, just grass?
It only depends on the cameras. So essentially, for example, the famous thing which is called ISO, right? And on cameras you have ISO. But on one camera, ISO 5000 can mean absolutely different that 5000 ISO on another camera. So it's quite a lot of manual work for the directors and operators.
Thank you.
I do believe that there were questions over here.
Thank you for the presentation. I was wondering if you use nerves to build the firmware.
Actually, no, we're using Yocto. I don't know why the decision was not to use nerves. I think they were missing something back in the day because, I mean, we started 7 years ago and Yocto was the way to go for us.
Okay, and I have a second question, if I may. I was wondering which protocol do you use to transfer the video and audio from this, like your embedded device to the internet? For example, when you had the Beijing games, and then you said you were sending data to Paris.
Yeah, that's the thing. We do not deal with the video or audio streams. That we leave to you. And what we do the camera control and shading specifically. So we do not touch the video signal, only in our VP4 boxes, where we apply the 3D LUT for the SDI conversion.
Okay, thanks.
I think that we might have time for one more question. The gentleman over there.
How do you do rolling updates and auto updates on your devices?
We don't.
Okay.
It's a manual update because usually in the industry, so the life cycle of the setup, so it's like 5 or 6 years. So you purchase amount of cameras, lenses, controls, and etc. You set up it once and you try not to touch it or upgrade it.
And what happens if your customer finds a bug?
Usually we quite prompt on the support, so we have a support email and the whole team usually receives it, and yeah, we're trying to be as fast as possible.
Okay, thank you.
All right, unless there are any more questions, there is one more. Very nice.
Hey, thank you for the presentation. I was just curious, how can you produce hardware with such a small team? Do you just like prototype it in the office and then you use third-party companies to actually make it?
Yeah, that's exact approach. So once you come to our office, it's how to say, it's an organized chaos of all possible tools, PCB boards, etc. So we do the PCB design in-house, and then obviously we have a lot of testing in-house, how to wire it together, and then we have the third-party production, which is actually producing the end product.
And how many people deal with the electronics versus how many deal with software? Just more or less, like.
I would say 1.5 is doing the hardware part, same half, and another 2 doing the software part.
Perfect, thanks.
All right. Thank you again, Daniil.
Thank you very much.
So it's time for our second speaker. It's gonna be Simon de Haan, the co-founder and CTO of Turn.io. Simon, welcome to the stage. And I got to know Simon a couple of months back. We've been working on a project together, and the interesting thing about him, he's like a very driven, straight-to-the-point person. He has a sense of urgency. Maybe it's because of the fact that he can make 7 different, he has 7 different ways of making coffee at home, but I do believe that the driver is the work that he's doing, which is pretty impactful, and we're gonna learn now during his talk how one can use WebRTC to bring some good to the world. The talk is worth waiting, don't worry. It wouldn't be a real conference if there was no, technical issues. Okay. Simon, the floor is yours.
And the audio. Yes. Pull up. Sure, let me just find my cursor again. All right. Hi, everyone. Thanks for having me. As I was already introduced, my name is Simon de Haan. I'm the CTO and co-founder of a company called Turn. I have far too many ways of making coffee at home. I was very pleased and impressed. You guys set a high bar with your coffee gear here. This is quite something. I'm inspired. But yeah, so thanks for having me here. As I said, I'm the co-founder of a company called Turn. Now, I know Turn has a very specific meaning within the WebRTC world. I'm sorry to disappoint. Turn has nothing to do with Turn, as in the WebRTC specific technology. We're a for-profit social enterprise, and we develop and run a SaaS platform that helps organizations power life-improving conversations. And this is likely going to be one of the least technical, pretty much my bet's on it, this is the least technical talk at this conference. But I'm hoping to shed some light on how the technologies that you all are working on are actually improving people's lives in dramatic ways in the Global South countries. And so as engineers, it's easy for us to focus on the details, as we should. I saw latency as a social contract somewhere posted. And these are really important things, but ultimately what matters is the experience that we're delivering to the people that use our services. And so I'd like to talk about the opportunities in making healthcare accessible in the Global South using the technologies that you all know. So we fundamentally believe that a message or a conversation held at the right time can really dramatically change someone's life. It can be directional and a positive force for change. We work with social entrepreneurs, as I said. This is governments, nonprofits, for-profits, and we focus on Global South countries, specifically in health, and that's in Latin America, Africa, and Asia Pacific. We have a really strong focus on healthcare because we believe that that's the biggest impact that we can have in people's lives in the coming years in that specific vertical. In 2024, we helped 200 organizations have 60 million conversations to improve the lives of 12 million people. 2025, we're working hard to double that. So if we're talking about healthcare, I pulled up some stats and focused a little bit on Africa alone. Now, sub-Saharan Africa has a 45.5 higher maternal death rate than Europe. So that means, if you're looking at the hard numbers, sub-Saharan Africa experiences 546 maternal deaths per 100,000 births, whereas Europe, or higher income countries, have it at 12. These are massive, stark differences between these regions and health outcomes, and many of these are entirely preventable. There's a projected shortage of 10 million healthcare workers by 2030 in sub-Saharan Africa. So right now, sub-Saharan Africa operates with only 1.8 physicians per 10,000 people, compared to Europe, which has 43 per 10,000 people. This directly translates to entirely preventable deaths and incredible suffering. On top of all that, the region carries 25% of the global disease burden with only 3% of the world's healthcare workers. Again, stark differences. Now, to make matters worse, free healthcare is still too expensive for most people. And I hear you thinking, how can free be too expensive? Turns out, if you have no money to spend, everything becomes more expensive. So we did some research on this into the cost of free healthcare. And so for many, a single visit to a healthcare facility can consume up to 30% of their monthly income. And this is just stuff like transport, getting there. 43% of the global population cannot walk to a health facility in 60 minutes. They're just too far from a health facility. Time spent in queues, waiting for healthcare at a public health facility there's a cost associated to that. People cannot work, and the lost wages often ends up being costing more than the actual health intervention or the medical costs. And then there's indirect costs: childcare, food, sometimes accommodation. All of this adds up. So while healthcare facilities are free, and these are great, and governments run them, and they should, there's still a massive cost for people in emerging markets to access this healthcare. So, see you all looking at me. We're at a tech conference. Why are you bumming me out with all these stats? I think it's important to be aware of these things, but at the same time, it inspires me. I think there's so much good that we can do as engineers to change this scenario, to change this and improve people's lives for the better. And so a helpful lens for me to look at it is what is going to be inevitable by 2030. If we do absolutely nothing, how are things going to change anyway, regardless of what we do? And then how can we use that as a force multiplier for the work that we want to do and the positive change we want to be bringing? And so one of these things that I think is inevitable by 2030 is that AI compute will be a commodity. Costs of AI compute have dropped tenfold every year for the last couple of years, and I'm expecting that to continue. And so that means any service launched will have some level of AI compute available to them to improve that service in some kind of meaningful way. Phone and data connectivity will be available and affordable by 2030. I would argue that this is already the case in most countries. Everyone has a phone, certainly in the markets that we work in. Data coverage is available. I think India is leading ahead with pretty much data almost being free, certainly for low-end data services and chat services. And so not only does it mean that phone and data connectivity will be available, it also means that it will be the primary means within which people consume services or access services that relate to them, their work, their health, will be their phone. In the way that for us, the primary service may have been radio or computers, desktop early on, or laptops. For them, it's just their phone. That's it. That's the way they communicate with the world. The other thing that's inevitable, I think, is that WhatsApp is going to be the default telco. On the left here, we see a graph from an organization called Gapminder. And they break up the world in income distribution. And so the first column there is $0 to $2, people who live on $0 to $2 a day. The yellow dot at the bottom, at the top, so the yellow doll at the top represents 1 billion people. And their main means of accessing the world and the internet is still an old phone, possibly the ones that I'm showing my age, but the ones that we use to play Snake on, for example. The way they get water is from a well. The way their transport is walking, and the way they prepare their food is on an open fire. Now, there's not much that we can do in terms of like digital data things for that for that segment, but thankfully that segment is actually shrinking. The really interesting ones are the level 2s and 3s, and those are 3 billion and 2 billion. So that's from $2 to $8 a day, or $8 to $32 a day. And we added the pictures on top. The original image of this only has from here down. And we added the images on top for the types of phones that people have in those areas. And so from here on, $2 a day, you have a data-capable phone, you have a low-end Android that's able to run tools like WhatsApp, and most likely, every phone that's shipped into the market that fits this category in many of these markets will have WhatsApp pre-installed anyway. And so WhatsApp is the default telco. And so whether we do something about this or not, no matter what we like about the parent organization of WhatsApp, this is going to be the case. And so all this together, I think, brings us to the conclusion that it's inevitable that all essential services will have a conversational interface to them. And what I mean by that is that people interact with the wider world through their phones. And so the services that they need to be exposed in a way that works on phones. And we believe that we'll be talking, voice services, chat services, that kind of stuff for the majority of the people. And so the opportunity here is that you can offer ultra-low-cost, expert personalized healthcare at scale. AI compute is available. Phone coverage is largely solved. WhatsApp is pre-installed on these systems, and the services that people will rely on to live their lives, to access their health, will have a conversational interface to them. And so delivering health via this medium, in our opinion, is inevitable. And so we're seeing signs of that actually happening with some of our customers. So Penda Health is a primary healthcare provider in Kenya. They serve over 600,000 patients a year with bookings and follow-ups and telehealth services via WhatsApp. That's right now 50,000 monthly users for a consult of $2. So if you're able to offer that at the location where they are or via WhatsApp, $2 ends up being a very interesting business model for these organizations while still being better and more affordable than the free option in the public health sector. Pinky Promise offers an instant and affordable AI-powered digital clinic for women's sexual and reproductive health in India. This is a completely digital clinic, telehealth services, chat services, and it's from 15 minutes from symptoms to script at 99 rupees a consult, which is also about $1. Mom Connect is the South African Department of Health's National Maternal Health Service, registered 5 million mothers at the moment, provides age and stage-based information for mothers during their pregnancy up until the child is 4 years old at the cost of $20 per person per year. Extremely low-cost health services that build on these channels that we all know and work with. Kilkari launched about a year ago. No, sorry, launched about 2 months ago. They're now at 170,000 mothers. They're growing to 70 million in the next 5 years across 3 states in India. Again, these are services that provide essential information, and they're looking at adding calling services on top of this as well. Now, a lot of this, getting a little bit more into the technical bits, a lot of these systems are largely on our platform. They're powered by a DSL that we've written. It looks a lot like Elixir. It's not Elixir, but we use Elixir in the background. And so these are state machines. So you can see at the top, if a message is received, if it has any of those messages, then proceed, and then ask the first name, welcome to the Healthy Clinic, what's your first name? Great, what's your surname? And what is your date of birth? And then basically it just steps through. It's a state machine for these kinds of things. And so for chat-based services, the visual counterpart of this, the document that we were looking at earlier is generated by this tool, is that essentially you have a state machine. State machines are great, they're highly predictable, but when you expose humans to state machines, strange things happen because the state machine expects the other side to act like a reliable system. Humans are highly irrational and unreliable and do not act well as state machines. And so you end up in things where someone says, well, what's your name? And I'm going to say Simon de Haan, and then it's going to ask me, what's your surname? I was like, I just told you it's de Haan. But these systems are incapable of actually dealing with that in a really good way. So that brings us to more fluid voice conversations powered by AI. How do we go about that? And so our stack, I already mentioned it earlier, is Elixir-based. We've been working with Software Mansion on using Elixir WebRTC to expose WhatsApp calling. We've been working with WhatsApp since January on their calling offering. We've been working with OpenAI on their real-time LLMs. Both have WebRTC connections to them, and we're able to connect the WhatsApp calling to OpenAI services or to human services that are answered in the desktop tool, and power just life-improving conversations around people's health with that. We prefer, as much as possible, just off-the-shelf things. So we use Kubernetes clusters on AWS and GCP. And the thing that we had to add for this deployment was stun servers provided by Cloudflare. Again, these are just off-the-shelf things. Everything else for the calling functionality that we added is powered by Elixir WebRTC, and we have a pretty stock standard Phoenix application that does this. The WhatsApp API itself for calling, it just builds on the Meta Graph API. So if someone calls, we get a webhook that has the SDP in there. We answer it, we process it. There's some tricks that Meta has introduced to pre-accept the call so that the call answers quicker and that you avoid trimming of audio at the start of the call. And it works incredibly well. Meta has designed a very strict calling consent into it, so a business cannot just call anyone. So there's no robo-calling, robo-dialing with WhatsApp Business API. The end user has to give explicit consent that the organization is allowed to call them, and that's a time-limited consent. And within that window, the organization can call them. So the organization needs to send them a message and say, hey, can we call you? User needs to say yes. Organization has limited time to answer, and then the call can take place. Architecturally, Danny in the previous call already talked a little bit about supervision trees. We have, again, Elixir, for those who know Elixir. This is familiar stuff. The supervision trees here provide resilience. If a call comes in, we have a dynamic supervisor. It spawns a call router. It's a stateful process that's running for that call in our distributed environment. And those things spawn peer connections, one of them to WhatsApp for the WebRTC connection there, and the other one to OpenAI. Or if the human is answering it, it's a peer connection straight to the browser. So this is, on a high level, how the whole thing ties together. I added the screenshot again of that markdown document that we were looking at earlier, because for these fluid conversations, what we're actually doing, where previously this was compiled down to a state machine, We're now providing this as markdown DSL straight to the LLM as context. And so the LLM actually knows what it's supposed to do without being very prescriptive about it. It's more like a guideline for a health operator or a phone operator would answer things in a call center. So what does this look like? Let's see if the video loads. So the interesting thing, while this sound is coming up, is the sound going? Yes. So look on the right as the data comes in.
To get started with your registration, may I please have your full name and surname?
Sure. My name is Simon and my surname is Haan. That's spelled D-E space capital H-A-A-N.
Thank you, Simon Haan. Next, could you please provide your South African national ID number?
Sure. That is 800-730-5289-180.
Thank you for providing your ID number. From this, I gather that your date of birth is July 30th, 1980, and your gender is male. Legislation has been successfully updated.
Okay, so on the right you see that it says, oh, that went away. On the right you'll see that my information is automatically captured and populated into my profile. And what this means, and this may feel like such a trivial example, in reality, in these systems that we work in, these health clinics and government clinics, 80% of registrations are considered new because the registration process is paper-based. All of that information is lost. So if someone registers with a chronic condition and they need to come back again in a month's time, the current systems allow for zero follow-up on any of that, leading to terrible health outcomes. The fact that we can do registrations now, capture that all information with a 30-second voice call, register them in the system, in the national health system, prevents a whole bunch of just preventable health conditions for those people going forward. Is there anything? Yeah, so this particular one, in the production version that we have now, also has the live transcriptions in there, which is really important for audits. This one just didn't really show it. So how are we doing this? Now here's an example where the LLM is taking the markdown that we've provided and using it as context for the real-time conversation. And so you'll see it's a far more fluid experience because it'll read the markdown description of what it should do, but not follow it to the letter. Here we go.
That's Simon.
Thanks, Simon. And your surname?
Haan.
Oh.
Got it. Simon Haan. And what is your date of birth?
1st of January, 1985.
Thanks. And what is the reason for your appointment? Briefly describe your symptoms or request.
I have a persistent cough.
Thanks, Simon. I have your details. Name, Simon Haan. Date of birth, 1st of January, 1985. Reason, persistent cough. We will contact you soon to confirm the appointment.
Great, thank you.
So the fact that we can do this is mind-blowing. The impact this has on the health system is incredible. Just the fact that we can just say, well, design a registration journey, serve it over WhatsApp, and make it available to pretty much everyone who is in the level 1 or level 2 or 3 that we were looking at. It's an ability to scale healthcare worldwide in a way that was previously completely unimaginable, and it builds on the technologies that we're all discussing here, WebRTC. And so the idea of ultra-low, offering ultra-low healthcare is actually becoming a reality with the technologies that we have available to it. WhatsApp has 4 billion users. The majority of them are in the global south. Costs of AI are dropping. Again, as I said before, WebRTC provides a really fantastic means to connect these people to healthcare. And frankly, there are more than 4 billion people worldwide in need of health, and the technologies at hand really give us an incredible opportunity to move the needle in significant ways there. And so my goal is, I'm really hoping, I know we have, in the startup world, we have a definition of a unicorn. So a startup that actually got to $1 billion valuation. I think those things are fine. what really motivates me is the idea of improving 1 billion lives towards better health. And I think it's entirely possible with the skills and the technologies that we have available to us today. So this is it. This is my presentation. Thanks all for the hard work that you all are doing. Thanks Software Mansion for hosting and making the software open source and available to us and working with us on getting it deployed. I'm finding this incredibly meaningful work. If you have more questions about this, let me know. I'll be around. Thanks.
Thank you very much, Simon. Question time. Over there.
So thank you for the talk. It was very inspiring. So I'm also working in a field of like voice AI, and I had this very bad experience that everything works very good in English, especially, you know, like speech to text part.
Yeah.
But then when you switch the language, something like, let's say, less rare.
Yeah.
Even my language, which is Hungarian.
Yeah.
And I imagine it's the same thing in the global south where there are local languages, local dialects. Isn't that a very hard problem to solve?
Yeah, yeah. It's an incredibly hard problem. We are not LLM model builders, but I expect this to be a solved problem in the next 5 years. And I'm expecting, if it's not completely solved, languages are going to converge, right? At some point we had SMS speak. It wasn't perfect, but it worked, right? And so people are able to converge on a language that works in both directions. We're probably going to see, like the first time I heard these LLMs talk in Dutch, which is another language I speak, they spoke with a really thick American accent, but I could understand them, right? And so the access element is more important than it being perfect. Many countries that we work in, there's actually code switching. English is one of the main used languages in Kenya and Tanzania, for example. So it's not perfect, but it's better than the healthcare that's available to them today. So the question is, are these good enough to start being deployed? There are many, many concerns around using LLMs around health, and we should completely look at those problems and tackle them head on. At the same time, I feel like these LLMs are so important, it'd be irresponsible for us not to use them for these kinds of applications either, or at least not explore using them. Does that answer your question? Okay.
Rob has a question over there, I see.
Thanks again, fantastic tool, probably the best use of LLM voice I've seen. I have 2 questions, so I'll go with the first one and then seed and maybe come back to the second one. So first question, in your demo, you did a couple of bits of information capture.
Yeah.
You did the name and the social security account or whatever.
Yeah,
I
yeah.
presume you're using OpenAI real time, so your only way of extracting that is through tools calls, I guess, is what you're doing there.
Yeah.
How are you finding the accuracy of that kind of information capture? Is it adequate for this kind of application?
We still do validation on those things. So the tool call will say, hey, this is great or this isn't great. So for example, that national ID is a bogus one, but it is valid. There is validation and what's the validation that you can use on like strings of numbers with the last digit? Something like that, yeah. And so we do those checks on the back end when the function is called and report back, say, hey, this was wrong. And then the LLM will say, actually, try again, that was wrong. So there is some amount of validation that we can do. We do not trust whatever the LLM gives us blindly. LLMs are surprisingly bad at reciting numbers for some reason.
Yeah, I mean, it's not just that, it's also things like the name. I noticed you took trouble to spell out your name, but often the accuracy, even when you go to those lengths, is quite hard.
So many people will have trouble spelling their own name when having to use English. So there's that already. And then there's other things that come in. So if we know a fair amount about the person who's calling, potentially, right? So we can see what their phone number is, and so we can deduce maybe what their preferred language is, and we can seed the model with that information, and then it's able to navigate to spelling, right? A couple of months ago, it kept spelling my colleague, Ricardo, his last name, Gonçalves, he's Portuguese, kept spelling that wrong. The other day, he tried it again. It was perfect, and he said he pronounced his name better than his own parents did. So these things are constantly improving.
Fantastic, thanks. I've got another question, but are there other questions? I don't want to...
So Will had a question.
Well, just finish there.
Oh. You sure? Okay. So the economic environment you're operating in, you're talking about $1 an hour for conversation time. Are you getting any subsidy from partners like OpenAI for this? Because surely getting your token cost down to that level doesn't work, right?
Not yet. But it has to work. And we're working closely with OpenAI on these things. We run health accelerator programs with various organizations. Right now we're running one with 10 organizations in partnership with OpenAI to see what are the use cases, what are the cost models that work for this scenario. And so OpenAI is very heavily involved in that. Ultimately, these things should be self-sustaining. The whole international development health sector funding is dead, pretty much, in the last 6 months because of all sorts of political shifts. And so it is incredibly important that these systems are at least revenue neutral, not running a loss.
Fantastic, thank you.
Simon.
Yes.
Lekker talk, thank you.
Lekker.
A question about the authentication, right? You gave an SA number and it updated your medical records purely based on something you said into the phone. So how do you address the question at scale of authentication that you know this is the person you're talking to? Are voice fingerprints used? And if so, how do you set them? Where do you get the trust in the first place to generate the fingerprint and then attach it to that user?
Yeah. We don't at the moment, right? We use the phone number and we connect with medical records where possible to verify the information that we're getting. And then there's a bunch of vetting processes that need to happen there. Right now, the industry is not there yet for that, at least to my knowledge, of building that trust well enough. I think that's something we're going to need to learn how to do well. And I think the harder part really is helping people understand on like the receiving side. If someone's in a village with a WhatsApp on their phone and they're calling and how do we build a process that actually meets them where they are, and helps them understand the importance of that trust. So like the human social element of that, I think is probably going to be one of the more difficult ones to introduce over the technical one. If anyone here has any great ideas on how to go about that, come find me.
Thank you.
All right, let's thank Simon again for the talk and the work he's doing.
Thank you.
I have 3 organizational remarks. First of all, please do scan the QR code and rate the talk. The QR code appears on the screen after each talk. Then I do hope that in case Simon's ID number wasn't fake, no one is gonna use it in a malicious ways. And the third remark, it's coffee time. So I would like to invite you for a coffee break. We're gonna be back around 11:05. Thank you.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
it's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.
All right, everyone. I guess that we'll be starting the next segment in a minute or two. So finish your coffees and slowly, please take your seats. All right, I think that we are about to start in a minute. So please take your seats. All right, I think that we are back from the coffee break, and our next speaker, I don't think that he needs a long introduction, but our next speaker is Will Law. He's a chief architect at Akamai. I unleashed my little agents, AI agents, to do some research about Will to make a proper introduction, and it turns out that he studied aero science engineering or something like that, and I thought, oh, maybe it wasn't, the rocket science wasn't enough of a rocket science for him, not hard enough, so he dedicated his life to multimedia. He is a co-chair of the WebTransport committee at W3C, and today he's going to give a quick update on mock and WebTransport. Will, welcome to the stage.
So, thank you very much. It's a pleasure to be here. I love being at conferences that are not like mainstream America, and there's so much interest here in Europe. I am a recovering aerospace engineer for 20 years. I decided aircraft, I was never going to get wealthy. I thought I'd make more money in the internet. And then I shifted into video, and for 20 years I've been fascinated with all the different sides of video. I'm also from Zimbabwe, if you're wondering where the accent's from. So I'm very sympathetic to Simon's talk. I grew up in that world, but I was lucky enough to be in column 4, and I'm very cognizant of that. And I think many of us, we think, oh, we got here, we work for tech companies because we worked harder than some person next to us. And it's true, everyone here worked hard, but at the end of the day, I think we're lucky. Other people work just as hard and they don't have what we have. So I'm giving a talk about 3 subjects that I'm actually quite passionate about now: QUIC, mock, and WebTransport, and we'll get into what they are. So firstly, WebTransport. WebTransport, as its name suggests, is a new transport for the web. It's essentially a protocol developed by the IETF. But the cool part about it is, while it can go to any operating system, we're developing an API in the browser so that you can access it from the browser today. I chair the working group that is implementing this in the browser. It gives you parallel streams of reliable and ordered data, right? So think of a WebSocket as reliable and ordered. WebSocket includes framing, though, which we don't include. We are just a pipe, a highly efficient pipe between a client and a server. It also gives you JavaScript access to datagrams. You can write individual datagrams with this API, and then you can do cool things with them, layer in your own FEC. So it's quite flexible for those in that world. A lot of people ask me, what are some benefits or differences with WebSockets? I am not here to say don't use WebSockets or don't use data channel in WebRTC. WebTransport is like another tool in your toolbox, right? You're building beautiful things. Here's another tool that maybe you can continue building with. So some differences between, you get no head-of-line blocking between your streams in QUIC. You do get head-of-line blocking within a stream. You get very fast connection handshakes due to QUIC if you care about session establishment. There's connection migration on the fly. Flexible congestion control, that's a plus and a negative, depending which side of that argument you're on. You bring your own framing, right? There's no such notion as a message for WebTransport. You've got to write your own framing and direct datagram access. So we're hoping really to get the spec to go to the next step, candidate recommendation, by December of this year and have it released. But it is available, well, let me just show you the tech stack. These are the tech stacks that we all work with today. WebTransport is essentially built on top of QUIC, which is built on top of UDP and an abstract layer called HTTP transport. There's also a parallel H2. This is for networks that for some reason block QUIC. Some do today. I don't think many will over the next few years, but if you want to make this robust, you need a failover. And WebTransport is this upper container. For deployment, right now it's fully supported by Chrome for the last 2 years, Mozilla Firefox for the last year, and as of 2 months ago, Safari behind a flag. So we expect it to go to mainstream Safari. So we have all 3 major code bases deploying it today. Now, why do we care? So if you work in the world of highly scalable media, we have something called adaptive HTTP streaming, which is HLS and Dash, right? It's non-real-time delivery. We have an encoder producing a bit stream. Our packager cuts it into little objects, which we basically give names and we stick in a flat file system. So we lose the order. And then we create a text file, a manifest or a playlist, that describes the order. So when I want to play this content on the other side of my virtual wall, I have to send my text file to the player, and the player reads it, and then it knows how to request these segments in the right order, and it can basically feed it into the decoder. But wouldn't it be cooler if we could not do that and just send our media straight through? So if you're in a broadcast world, or if you're using WebRTC, this is essentially what you do. But we're talking about upgrading very highly scalable distribution, millions of concurrent users, to use a solution more like this. This is basically a pub-sub network. Instead of asking for a little object every half a second or a second and doing that, I just want to ask for my video, and for the next hour, I want you to send it to me. So clearly, it's nice, but why hasn't it worked at scale? And there's a number of reasons for this. One is that it was never designed for distribution via CDNs. Like, I work for a global CDN. We have 4,000 POPs around the world. That's our differentiation. We don't have WebRTC on those POPs. It's live edge only, so typically, the systems today, you couldn't rewind, or more importantly, you couldn't consume it at a slight distance behind live to be able to trade off latency for quality. They were either focused on contribution, like SRT on the one side, but we don't use it on the distribution side. There's not this uniform transport we can use across contribution and distribution. And also a lot of proprietary solutions. There's never been a global standard that we can rely upon, as there is for HTTP, and also tight binding of codecs and media formats. So pub-sub systems are very nice for the internet, but they have to solve these problems here if we want them to work at scale. So a number of things are then coming along. I mentioned we've got WebTransport, we've got QUIC now, it's the basis for HTTP3. We're interested in going back, essentially, and recovering pub-sub for live. We want tunable latency, and we've got some things we can do with congestion controllers. So these are all ingredients, and we're baking a cake, is the analogy, and that cake we're baking is called mock. Now, I say the name mock, it started off meaning media over QUIC, right? But there's many applications which are not media-based. And in fact, mock all the demos I'm going to show you are not running over raw QUIC, they're mostly running over WebTransport. So the name's a little confining. So people say, well, let's call it many things over QUIC to preserve the acronym. They're like, no, we're not going to do that. So at the last IETF meeting, we're trying to make it, I'm one of the people who agree with this, that it's just a name. So if you read the QUIC spec, QUIC doesn't stand for anything. It's just a name. I want mock to also not stand for anything. So think of it as an umbrella term for a family of related specifications. And one of them, the core one, is this one, MOQT, which is mock transport. This is built by the IETF. We're working on it right now. There's a big meeting next week. I'll tell you about it. And it's the underpinning. It is how we move data in a pub-sub network over QUIC or WebTransport. But there's a bunch of other specs that make this one useful, right? Low overhead container, how do I package video and move it over here? Warp, a streaming format. Basically, how do I stream in a commercial sense? CAT for mock, how do I add token access and authentication and control to this system? So all of these are currently being worked on at the same time, and I put them under this umbrella of mock or MOQ, depending how you prefer to announce it. So what is mock transport? It's a transport for moving binary objects, not only video. You can move database objects, you can move camera controls, you can move drone controls. It doesn't care what's the payload of the object you're moving. It's pub-sub, meaning I publish data and I subscribe data into a network of interconnected nodes. It's cache-friendly, meaning we cache whatever's moving through it, and you can go back and ask for it later. It also has tunable latency. So we're designing it for real-time communications. This is the world of WebRTC, sub, say, 200 to 400 milliseconds target latency. Also interactive live, which is a very interesting area for live sports, betting, gaming, gambling. And then what I call conservative live, which is considered low latency for most of the streaming at scale industry today. It can also do VOD. VOD just means my cache is big enough to hold stuff that was previously live a long time ago. So I can use the same distribution network across all these latency regimes. What's the status? Work, the repo began 2023, and since then we've had a number of draft updates, and there's been a lot of them. So the last one was released just earlier this month. We're on draft 14. The chairs put out a goal of basically completing mock transport midway through 2026, which is next year. So this is not a product you can buy or sell today, but there's an awful lot of development going on in parallel to the spec. So the oscillations in the spec, the changes, the wireline changes, are being reduced with each draft that comes out. It's a very active group, it's very open, anyone can participate in this, assuming you have time to kill and an interest. So the mock ecosystem. Mock is built on raw QUIC. When I say raw, it's just a quick connection between a client and a server. WebTransport is a thin layer of HTTP that sits on top of QUIC. That's all it is. And it's not the full HTTP stack either. It's just essentially the initial connection. But it's very useful because it looks like you're connecting to an HTTP3 resource from the outside, and then it upgrades itself to WebTransport, and then it essentially gives you the quick connection, and then HTTP is gone, and now I just have my QUIC streams and my QUIC datagrams. Mock transport then is the protocol sitting on top of this. On top of mock transport, we have what we call streaming formats. So if you think of an analogy on the internet, this would be HTTP running on top of either QUIC or TCP. And then I have streaming formats like HLS or Dash, and there's many of them, right? There's no limit to the number of streaming formats that can use transport. And Warp is one of these. Low overhead container is another one. But we could have a chat system if I just want to send messages, also operating. And the decoupling here is that we want CDNs to deploy this at scale and globally as a service, right? And then I can bring my applications, and many of them, and I can plug it in and just use it. Much like we use HTTP CDNs today, and I plug in all sorts of applications on top of them. So the object model is very simple. We have a concept of an item called a track. It's hard to read the red here, sorry. It says a track is a sequence of groups.
Groups are abstract. They're not physical differentiation. Each group is comprised of a sequence of objects, right? And these objects should not be dependent on objects in other groups. So when I'm mapping media, a group is essentially a GOP, and my objects are frames within that GOP. Because as long as I have that group, I can decode all the objects within it. And the object then is the lowest level. It's the addressable unit inside mock. As you might think, it's got some headers and it's got a payload, and that's it. And we don't care what the payload is. And this is very agnostic, right? This object model doesn't indicate that you must use audio video here. The messages in mock, so mock is moving messages. These messages are objects. So the objects can be either the payload that you're moving or control objects. They are set up in a special bidirectional stream, and there's a message type and a message payload. And here's a list. I'm not going to go into all of these. You can read the spec today. But if you're familiar with pub subsystems, you subscribe, you publish, you announce, you do setup handshakes. It's not that complex. Subgroups are interesting. And again, there's too much text on this slide, but normally if I have a quick stream, my challenge always becomes how do I map mock objects to my actual transport layer? And I've got these individual streams. Do I put everything in the same stream or not? So if I have a quick stream, I can put my group, which will be a keyframe and then some groups of video, and this might be my GOP. And I put that in one quick stream and I put it in another. That's one way to map it, right? But what I might want to do is set up two quick streams in parallel. And I would want to do this because I can shard my objects. I can put my first frame here, my second frame here, my third and my fourth. For example, if I have 30 frame per second video, I can put a 15 frame per second layer here and another 15 frame per second additive layer here. The advantage is, and I keep doing that, the advantage is if I get packet loss here, I can discard this and my decoder can just do 15 frames per second for a short period of time and then recover later on and go back to 30. So if I'm doing real-time media, it's much preferable to be able to drop some data than to go back and retransmit it. So when you hear about subgroups in mock, they're really just everything in the same subgroup should be in the same quick stream. That's all it is. And if you don't want to use subgroups, you don't have to. We address content via a combination of namespace plus name. So I might want to call my track video, right? But clearly it's going to conflict with other people also calling their track video. So a namespace is literally the namespace in which my name is unique across the distribution network. And the combination of namespace, name, group ID, and object ID uniquely identifies every object in a mock distribution. And we can use text for this. The domain here is not a DNS mapping name. It's just saying I own this domain and I'm going to start my prefix with it. But the names themselves, namespace and name, are binary. Namespace is a 32 field tuple. So we have 32 fields. I can allocate what I want. I can just use one. And I'm very flexible. Most of us, in the examples, I'll use strings, but we're just converting those strings to binary when it actually gets on the network. So how do you get new objects? It's very simple. Imagine I have a flow of video. So here's my GOP. I got a keyframe at the dark colored ones. It's going forward. And we're observing it at this point in time, right here. Those are in the future. These are in the past. So I can subscribe to it as what's called next group start, where the relay will then send me the next group boundary that it sees, which would be the green ones, 3.0. I can describe it the latest object. And since I'm midway through this object, it doesn't count. The next object would be 2.3, and then I get everything else in the future. I can do an absolute start, say I want to wait when 4.0 arrives, send it to me. Same thing, the relay can do that. And I can do an absolute range from 3 to 4. So those subscribing is for fetching objects in the future. And it's an interesting separation. So how do I get objects from the past with mock? I have a different verb or action called fetch. This is not the fetch we use in JavaScript, although its name is very similar. There's an API for it, but basically you can anticipate that, hey, I want the namespace, I want the name, I want my start group and my end group, and I can go back and fetch it from the relay. The relay will pull it from its cache. If it doesn't have it in the cache, it goes back to the origin publisher and pulls it from there. We have a thing called a joining fetch, which is a little more complex. It's where I want to stitch together stuff in the future with stuff in the past. And you might say, why do I want to do that? But that's actually the normal joining case for segmented media. I want to join a stream at the last keyframe that was sent out. So I want to go back a little bit in time to the last keyframe. So what I do is I subscribe to the future, and then I say, by the way, make me a fetch that starts at the last keyframe and attaches itself to the front of that subscription, and do that for me. So I get seamless video, and I don't get competition on the wire between my fetch and my subscribe response. Now you might say, I just care about live video. What are the use cases for fetching anything, right? So one of them is DVR windows. In sports, when we want to go back. So I have a hypothetical sports game. We have this rolling window that follows the live playhead where you're allowed to scrub back in time. So in this concept, the user might want to start at this point, and then they would just issue these fetches of these groups forward. The playhead is up on the right there. I might want to retrieve subclips, for example. So here's a game. It's so hard to read. It says goal. There was a goal scored there. There's a penalty scored here. And I might want to come and just fetch my content for this range. This use case is going to be demonstrated on tomorrow's session in the afternoon by Ali, who's sitting in the front. They have a working version doing exactly this, which is be quite nice to see. And you can still have your DVR window at the same time. You can even play a VOD asset. We can play Big Buck Bunny, right? And all we're doing there is just fetching content from the beginning. It's content that actually was never live to begin with. And if we want to seek forward, all we do is fetch a different range. So it's quite simple to apply that to VOD delivery. And we can also fetch backwards and set a filter on the keyframes. And you might say, why do I want to do that? But that's your scrubbing mechanism. So when you have a long 2-hour movie and you want to go backwards or forwards, we can just tell the relay, just send me the keyframes in either ascending or descending order, and it'll do it. And we get our keyframe generation for free, essentially, for our scrubbing interface. The other one, if you just say, I just care about live, but I want to monetize it. The other way, if I have a live stream and I want to insert interstitial advertising content, then those ads are essentially VOD. They were prepared but encoded before, and I want to inject them into my live stream. So even if you're just doing live, you still want to look at fetching to get your advertising support into your live streams. And we can do ads into extremely low latency live streams, as long as the ad is signaled ahead of time and the content is fetched ahead of time. So this just simple diagram, I mentioned we had a joining fetch. One of the reasons for that is I remove one RTT. So we have a race, we have a standalone fetch here. So that one is already started because it was able to do the subscribe and the fetch together, which is essentially a joining fetch. This one took longer because I had to get the answer back here before it could do a clean fetch. So we're able to start decoding and playing content within one RTT from request time. This is actually a very interesting feature of Mock. It's called subscribe but don't forward. So let me explain what that means. I've got an origin, that's my original publisher, and I got 2 relays here and a client. This is a typical distribution system. And I'm playing multi-bitrate content. So I got tracks at different quality levels. And one problem with this in HLS or Dash is I might ask my relay for a quality level, but it's not available at the edge, right? The edge has to go all the way back to the origin, which might be in another continent, and fetch it. So now what we do, the client subscribes to the relay then makes a subscription to this relay, which makes one back to the origin, and the data flows back. And it says, I set a flag called forward. So I want you to actually forward me this data. At the same time, it does a subscribe, but it says don't forward for 2 other bit rates. And it's basically just warming them at the cache. These are being pulled, and they're active here, but they're not being delivered. So now when I want to do multi-bitrate switching, I can do it very quickly. I just turn off the forward flag and turn it on for another bitrate. And same for that if I want to switch down. So I don't need to make that trip to the origin. So I think this is a very interesting feature of Mock that will certainly lower the level at which we can do multi-bitrate switching. Auth tokens are necessary. The internet is a lovely place to commit crime. And this is going to be a very accessible network. So we want to protect many things. We want to protect access to the network, but we also want to protect what you can do on it when you connect. So maybe you're allowed to connect and you can only subscribe but not publish, right? So we have a lot of, these are all the actions you can take. And we've created a generic token system that can supply encrypted tokens that constrain this behavior. This is the core transport. It doesn't tell you how to make these tokens. So there's another spec I'm actually one of the authors of called CAT for mock. CAT stands for Common Access Token. And it takes all the actions here, and for each one of these, we can constrain it by claims against all of these fields. So you can say, if you're in Krakow and it's between 8 p.m. at night, and you've got a token from your issuer, and you've got Depop, then you can subscribe. So very fine-grained control over the actions you can take on a mock transport network. This just got accepted by the work group, so this will also be published as a working solution. I think someone else is doing a JWT-based solution for this. This is a binary one, uses CBOR. Warp is the streaming format. So it's a lot like HLS or Dash. It says, how do I take content and package it? We have a thing called a catalog. So you ask the publisher for a catalog, and just like a playlist or manifest, the catalog says, oh, I've got 5 streams available, 3 video streams. These are the codecs, the bitrate, the frame rate, and some audio streams, and this is the channel configuration. And then the player subscribes to what it wants. We're publishing this right now. This supports a container format called low overhead container. It's a very lightweight container for moving audio and video. We have another draft called Carp. It's a terrible name, it's a fish, but it's just a CMAF version of Warp. And that's the one, there's a lot of CMAF-based content in the industry today, and I can take content from HLS or Dash and just repackage it for mock transport. A reminder, and I said it at the beginning, mock is not just for media. So we have use cases, autonomous driving, smart cities, industrial IoT. This is Huawei, China Unicom, there's open letters saying, hey, we really want to use mock for collecting and moving data. So there's a lot of focus on the video side, but I really do believe there's applications outside of that that make it useful. So I want to start just ending with a whole bunch of pre-recorded demos, right? Just to give you a taste of what people are working on at the time. There's an open source project called mocktail.dev. Ali Begin is one of the maintainers of this. It's got publisher, subscriber, relay components. And this is myself testing it. So like all things WebRTC, you wave at the camera an awful lot of your life. You put up time code, but it's working nicely. There's another one called Mock Live Mock. So when we're testing things, it's very hard to keep a real live encoder running reliably for months on end, right? So this is a publisher that actually has VOD content, and when you ask it for a live stream, it synthesizes a live stream for you, makes it look like live, but it's actually based on VOD, which is a very useful tool as we build it out. He's written a player. This player is running inside Chrome. So he's going to basically connect what looks like a HTTP3 URL, right? That's going to establish his web transport connection. He connected, he got the catalog, and the catalog says, oh, you've got 3 video bit rates. He chooses one of them. He's manually selecting this. A player would automate the selection, right? This is a debug and dev tool. You can go and set the buffer you want and the latency you want, target latency 300 milliseconds, and then your video starts playing. And it's a special video where it's got the time code baked in, so you can do a bunch of testing. This is built by Torben out of Ivin in Sweden. Next, this was a player I built to test multi-relay routing, right? So we're going to have networks of relays, and we want to test how we can forward content. So I was in Denver when I recorded this. I'm sending my request to a relay server hosted on Akamai in Los Angeles. We're then reflecting it to another relay server in Madrid, and then I'm subscribing back from it. So these are the actual RTTs measured. That's my total RTT. Obviously, half of that is my one-way packet transmission. And this is, I wouldn't obviously go in a circle like this in the real world, but if I want to go from Australia to Europe, yes, I would be running through multiple relays. Again, running in Chrome, simple test player. So I'm just publishing, there's time code there. This is tracing out the latency that we have. And it's equivalent to what you would get with WebRTC. But the nice thing is it's highly predictable. So I have my 173 millisecond, half of my round trip time for distribution delay. I've got 33 millisecond, 1 frame encode, 1 frame decode delay, and then I've got my 40 millisecond jitter buffer. And we see that the sum of those nicely predicts my actual latency that I'm seeing on the network. So we're able to remove any delay. The relays are doing a good job in getting something and handing it out as quickly as possible. Vindrel, another Nordic company, they offer a live streaming solution. They basically use WebSockets and then custom encoding to distribute their content. They're now building an ingress to take all these different formats, RTP, SDI, MPEG, TS, RTSP, convert them all to mock and bring them down to their live engine. They also have that's on the contribution side, right? Now they are building a client that can also continue that mock out for distribution. This is another web page they built. It's a demo. It's a much more sophisticated demo than mine. So they're using WebTransport to connect. Basically here it's a multi-bitrate player. They can go in and choose 4K. The great thing with mock is your codecs are completely decoupled from your transport. You can put whatever codec you want in there. They can adjust the latency, 600 milliseconds, and they're just confirming that they're using mock for distribution. So they're a company now. They own the encoder, the relays, and the client. So they just pick one of those draft versions I mentioned and deployed it. And that's why they can deploy ahead of time. But if we're working on the IETF standard, we still got to wait for it to be complete. Live sports test. So I'm in Zurich. I'm publishing 1080p, 30 FPS, 5 megabits per second. I'm going to publish to Los Angeles, which I wouldn't normally do, but it's a good test. And then subscribe back again for the round trip. So this is just using OBS with some time code as my actual media source on the machine. And then I'm going to publish to a web page. This is using a library, open source library from Meta called Moxygen. And it's the client written by Jordi in Barcelona. So I'm just taking this feed and encoding it using web codecs in the browser and then publishing it with WebTransport and mock transport to the relay. And then I'm going to have another page where I subscribe back to that, right? And my poor laptop is trying to do all of this and encode it as screen capture, so there was that blip. But there's my latencies. You can't really see them, so I took a screenshot. We have our 1 frame delay between OBS and web codecs doing the encoding. And here we had 636 milliseconds from the codec, go to Los Angeles, come back. But there's a player buffer of 400 milliseconds that's intentionally introduced there. So overall, around about 700 milliseconds source to subscriber. I wouldn't run a live service at that latency. You don't need to. I'd rather add, say, go to a second or a second and a half, add a little bit more buffer protection on the client, and some ability, some time in which to do multi-bitrate switching. This is another implementation, one of the first ones I've seen of that fetch behavior. I'm not going to show it to you working. It's the session tomorrow here, and they will be demoing that player and its capabilities. So I think it's exciting to see. Cisco, if you know them, with the WebEx conferencing client, they're very interested in mock. They're building out their next generation conference client to use mock. So we did a test. We mounted it on an Akamai server in New Jersey. And then we tested from Europe, Seattle, and Santa Clara. So this looks completely uninspiring because we all sit in front of this all day, but this is 1080p video, and we're chatting, and we're actually doing tests to see how quickly the audio comes in. We don't want to clip the start of somebody speaking. So it's a test of how quickly you can initiate a subscription to a new stream. But that's not what's interesting to me, because this is what we have today. We then just switched the codec and the bitrate that we're using in that same tool. And this was my 32-inch monitor, 34-inch monitor that I'm now getting full screen 4K video conferencing on. And this, I think, is exciting because the quality here is a big step up from what we typically deliver it today. So you can imagine a corporate network where you've got the bandwidth to chat like this. We can now have the option to really increase the quality. I want to give a recognition of Cloudflare. They're a competitor of my company, but they just rolled out the first mock deployment on 300 servers around the world. It's compliant with draft 7, though, which is one of the drafts from last year. But they've got it working. I'm doing hand-waving latency tests. It was 368 milliseconds. And I think that's not bad for a proof of concept that's rolled out. What are we doing on the Akamai side? Just last week, I launched an initiative called OpenMock. So OpenMock is a software development consortium that wants to create highly performant open source mock software for both contribution side, for the relay, and for the players. And these companies have expressed interest in being the founding members. We haven't signed the agreements yet, but they're going to. This is a competitor of ours, so we're actually collaborating in order to build common software. Cisco for WebEx, Oracle, very big company, Cinemedia here in Europe, and also YouTube. YouTube care about the contribution side of this. So if you're interested in this project, there's a URL and there's a QR code. Or just come talk to me. I'd be very happy to get you on board. The ITF is very open. Next week in Toronto, there's a hybrid interim. You can join online. You can watch the sausage being made in all its glory, but there's a number of key issues, and you can see everyone discussing them and making this a good format. And there's another QR code for some participation there. So I'm a big enthusiast of mock. It's not the answer to everything. It has issues, but it also has a large community of engineers who are trying to make it better. And for that, I thank you. Cheers.
Thank you very much, Will, for this insight that you brought to us. We are slightly over time, but I guess that one question we can take. Who is the brave person to ask this one? Balazs.
Yeah, well, if there is no other question that might be interesting for me. You mentioned about the flexible congestion control, and I am curious about if we could change it, for example, on the fly. So we build up a stream, and the congestion control we choose or configure seems to be not aggressive enough to compete with other traffic. Can we change it, for example?
So the congestion control will depend upon the QUIC stack that you're using. There's Pico QUIC, what Cisco using. I think Meta use MoveFast. So I don't know if you can change on the fly within a session, but as an engineer, I don't see why you couldn't, right? You're collecting information, and it's an interesting idea that as a session's progressing and you start reacting to alternative traffic, that you might want to adapt the congestion control. So you might only have to be able to switch it at a stream boundary, perhaps, or when you're writing in, which I think is acceptable because your application could make sure that there's ample opportunity at the stream boundaries in order to do that. So I don't know, but I think it sounds feasible.
Yeah. Thank you very much.
All right. Thank you very much, Will, for a wonderful talk. And the reality played out better than I thought, because the person who will be talking next is Balazs. So, me again, doing quick introduction. Balazs Kreith, ladies and gentlemen. If you work on WebRTC, he might be your hero, because he's the person who builds the tool that could help you to figure out what really went wrong, and if you work in this technology, things go wrong. So Balazs dedicated his life to pursue observability in WebRTC. Also, because of the WebRTC, he learned Finnish language, so lots of things happening in his life because of that. Let's see what he has to tell us. Balazs, the floor is yours.
Okay, thank you very much. It's a little bit too much to take. So first of all, I am not going to solve anybody's issues. I am hardly capable of solving ours, but I'm trying to keep up. Yeah, so as you might figure it out, my name is Balazs Kreith. I am a senior software engineer at Riverside, where I'm responsible for maintaining and developing the WebRTC infrastructure and powers the company remote recording and podcasting platform. My journey for WebRTC started 10 years ago, where as a PhD student, surprise, researching and developing congestion control algorithm for real-time media in a multipass environment. And I joined Karlstad, one of the first WebRTC company, and that's the reason why I moved to Finland. Yeah. Later in 2021, I joined Whereby as a full-stack WebRTC developer, and this time not just evaluating the quality, but also actively maintaining and developing components for WebRTC calls. Since 2023, I joined Riverside, where I'm continuing this work at scale. Today, I'm going to talk about some tips and tricks I learned on the way, how to evaluate the WebRTC stats, how to make might be meaningful data, and how to use it for your own benefits. I hope you will find it useful. So let's dive in. Let's start with what WebRTC stats actually are. In the browser, RTC peer connection getstats method gives you metrics about RTP streams, RTC behaviors, codec performance, etc. These stats can form the basis of quality of service, and how you are evaluating it is depending on whose expectations you want to meet. Let's take a simple example. Alice is on the call with Bob, and all she sees is a black screen. Never happened with anyone. For Alice's perspective, it is unacceptable. All she cares about that it gets fixed. From a manager perspective, it should be known if it is a one-time glitch or a systematic failure. And from the developer point of view, the issue needs to be solved, so the root cause needs to be found. And here we have quality of service metrics, which might be helping in order to analyze and then satisfying some requirements, and 3 different expectations. Users cares about experience, managers cares about impact, and developers cares about finding the root cause. And by having quality of service metrics, one of the main goals is to approximate the quality of experience. The quality of experience reflects the user perception during a call. When we are turning out to have WebRTC stats in practice, we are polling it, and then we are calculating and transforming it into the insights. Let's say the basic insights we are transforming is bitrate, because you need to poll 2 consecutive stats. And from bitrate, you can identify if the media, for example, flows, first of all. But the interesting thing is that here is the first key takeaway, is to use the application context. Because if you just have WebRTC stats without application context, and then let's take the previous example, where the black screens for Alice, you're seeing that the outbound streams are flowing, but the inbound streams never receives anything. And then you are saying, okay, so the issue is in between the two. But if you just attach an application context that the virtual background has been applied, you wouldn't go to the SFU code to figure out what could go wrong, because it's an outbound RTP streams transformation issue, and not a networking issue, nor an SFU issue. And using application context goes beyond the single case. For example, you can detect CPU spikes as an application context or tasks which the users interact. And then you can correlate it with discarded buckets or dropped frames. So you can identify devices which cannot keep up with your application. So the key takeaway, and also it's like, interestingly, when you have it, you can immediately calculating the KPIs, how many calls were affected with your bug. You can immediately pinpoint the issues for the developers, and the users can get, better experience a bit sooner. So the key takeaway is that the challenge is to provide meaningful insights from WebRTC stats, the base of the quality of service metrics, but it often requires for the application context to correlate it with the stats. That's the first key takeaway. And scores. because this is one of my favorite questions. Whenever we are talking about evaluating WebRTC stats, talking about designing a component or any services, the question was that how was the quality in meeting X always comes up. It's one of the first questions I'm getting when we are talking about it. But for me as an engineer, when somebody is asking this question, it's like asking a blind person whether the sky was cloudy yesterday, because it's a little bit hard to say because I didn't actually see it. In order to having meaningful scores, calculating, we need to consider 3 components for WebRTC or for any real-time communication system. One is the audio-video content which is produced and delivered. The second is the network reliability, and the third is the system context. The audio-video content are the tracks which is producing the video and the audio. The network reliability is ICE connections, renegotiations, ICE failures, and congestions. And the system and the environment stability or the system context is the application, the device, and all of the context which we can gather from the client. When we are talking about calculating the scores, we always start with the audio-video content. That's, of course, the central components of any kind of score calculation. But if you are investigating what kind of available score calculation is, that you will find traditional like MSSIM, SSIM, or PSNR. And those are not feasible for WebRTC. They are comparing the structural similarity between the produced and the received frames, but it's not simply not feasible and not adaptable, especially in real time. Other approaches like LEAPS and VMEF, which is considering the bitrate in their score calculation, are more practical, but they still need to be adapted on the stats which is available for WebRTC. A network part, as I said, the second component, plays a huge role in any score calculation. When congestion happens, all media are affected. So you need to come up with some kind of aggregation for the peer connection that compound the network reliability and the video content and the video and audio content score calculation. And here is the second problem comes when we are talking about score calculation, is the aggregation. Every aggregation is smoothing out information. And then we are talking about several levels. So even if you find something which is nicely calculating a score for a peer connection, I have a bad news for you because one client may have many peer connections, so you need to aggregate across those. And then everybody cares about that, what was the score, and then give me a score, give me one number. So you need to aggregate over a time series of data, which is an aggregation of an aggregation of an aggregation. And then the original question we finally came, how was the meeting in quality X, which is an aggregation of client. I think you see the problem. So, sum up, the question of how was the meeting in quality, and how was the quality in meeting X, was turning out to be one of the most challenging. But it's also one of the most essential one, because when you are able to calculating somewhat an approximation of quality of experience with some kind of score mechanism, you can have some meaningful insights. And why it is very useful? Because of adaptive media systems. If you define controllers of your systems, which is affecting the quality of services, and you have valuable insights, when you're connecting those two, you are closing the loop and enabling active adoption. An essence of adaptive multimedia systems. And that is basically what we might want to head on. When WebRTC first emerged, the priority was to build a system which worked, rather than a system which is able to self-tuning or self-adaptation. The artificial intelligence was not yet widely available or easily integratable, and that has been changed over the last years. The AI component is easily integratable, WebRTC has stabilized, And more platforms are exploring the closed-loop self-adoption, where they are using artificial intelligence to balance between quality of service and quality of experience. When I was initially developed an open source, I didn't mention, but I founded in 2022 an open source project, ObservRTC, which is maintaining and I'm developing tools for evaluating WebRTC calls from the WebRTC stats. And when I initially started developing it, I thought that it is providing a reliable score metric for quality of experience should be an out-of-the-box service for any WebRTC systems. I believe that providing an objective score is good because we can actually compare different systems with each other. I assume that the system context is not so relevant in order to provide such relevant score, such objective scores, and I underestimated the importance of expectations of usability. Users cannot care less about comparable scores. Managers are missing key KPIs in order to, if the scores are disconnected from the application context, and developers will not be able to pinpoint the root cause. So today I can say you in confidence that monitoring shouldn't be outsourced. It should be fully integrated in order for you to do key KPIs, finding the root cause, have better user experience, and basically close the loops so available to, enables you to make an adaptive multimedia system. And it's not working. Sorry. So let's break observability into two main parts, client side and server side. They both play critical roles, but their responsibilities and strengths are different. The client is the source of the truth. It is where the user interacts, raw stats are pulled, environment has been detected, client issues are happening. The server side is the view shifts. It is where all of the client's data are seen, that you can connect the dots. For example, if you have some kind of server observability, you can detect if one client is not receiving some media from another, and then you can notify the right side of the client, avoiding the ghost conversation that can you hear or see me, which is usually often happens. Another key role for a server is the saving data. When a user complains, you might want to pull out the stats, replay the calls, and then identifying when the quality degradation happened and what might cause the potential issues. As I said earlier, it should actually save it in application context in order to have better view what happened. So let's talk about building an integrated monitoring system for WebRTC in your WebRTC systems. The client is the source of the truth, but you also need to save data and correlates with the client-provided data. If you are looking at the full stack, the functionalities you need to cover when you are building a integrated monitoring system is to collect, transport, analyze, react, save, and scale. And the questions like how do we transport the stats, how do we analyze it, what kind of queries we are running, where do we save it, is that although there are not simple answers for these questions, what I have learned from experience, I will try to share it with you in a couple of minutes. One of the things is that, for example, let's start with collecting and saving. When WebRTC stats are pulled, they look like a batch of relational database rows. Because, for example, the outbound RTP streams contains the media stream ID, and media stream ID is referring to the media source stats. And the natural belief, or the common belief, is that it should be just saved in the corresponding relational tables. Although it sounds a bit nice, but often it's not the best choice. And why? because you are not aggregating in columns, because you are hardly going to be query using the relational table advantages. So keeping it up, it comes with a cost, and you might want to avoid it because if it is not necessary. That brings us to the other question: is that analysis, because what you want to analyze with the data you are saved or your data you are on the fly analyzing with on the server side. There are two kinds of analysis really, which is you are doing. Either on-the-fly analysis, where you are able to detecting on-the-fly issues between the clients, or post-analysis. Most of the time, the analysis is basically generating a summary view when you are highlighting possible issues which happened with the client. And that brings to the scaling, because the intensity of the analysis is going to defining what kind of scalability you need for your service, which is detecting, monitoring your infrastructure. So for a long time, I believe that Observer service should be some kind of separated and with their own CI/CD pipeline. But nowadays, I am leaning forward to having a sidecar service next to the signaling or media server. If you are putting an observability service next to, for example, into the media server, you are immediately accessing to critical system context, which is otherwise should be collected some other way. But the downside is that because of the nature of the cascaded media, you will not access to all clients at the same time. If you are put it into as a sidecar to the signaling service, you might be accessing to all the clients at the same time, but there is little system context which you can grab from it. But what is the nice side when you are integrating each of the service into each of the service? You are reusing the CI/CD pipeline, and then it scales with the original, and the scales is ties back to the original servers. So it integrates naturally. Finally, let's talk about transport. Because the funny things with the transport, that you want to transport your stats to the server, is that when more and more participants are joining to the call and then more and more stats are available, it can go up to several kilobytes or even tens of kilobytes. And then transporting it actually frequently, you might causing incipient congestion, which is a bit ironic because you're setting up a monitoring system in order to improve the quality, but the monitoring transport will be the one which is degrading the quality. So this is why, although transports are essential in order to on-the-fly analysis, but it's very important to compress it as much as possible. When you are sending the raw JSON, it's not a good idea. Sending data JSON, which is the differences between consecutive polling, is a better idea. It's even better if you, for example, using some kind of predefined schema and then just use, for example, protobuf, and then sending the data in each time. That's massively compressing the data you are sending. And building your own monitoring system. So I would like to recommend, highlight some recommend some tools. There are many other there, but since I am the presenter, forgive me if I'm showcasing my own. So the client monitor GS from WebRTC is help you to polling and calculating. It's calculating many metrics for you. Also, it's having ready samples, a sample object which is ready to ship to the server. There are predefined schema. There are predefined schema which enables you for different language bindings, samples encoder and decoder for efficient transport on the server and the client side, and an observer GS which is enabling you on the server to analyze it, the clients on the fly, wherever you are putting your service. The descriptions are available in observability.org. Yeah. And yeah, for today demos, I made something interesting, which is started last year here in Rtc.On. Okay, Okay, I think I ran out of time, sorry. Okay, just quickly. So last year with the L7MP guys, we had an interesting conversation when they introduced the Stunner as a native Kubernetes gateway for their turn. And I had this kind of conversation that, what if we do a native Kubernetes SFU, where there is only one IP and one port used, and then the full horizontal scalability of the SFU is behind the gateway. And we made a proof of concept, and I wasn't able to resist to integrate observability to that project. It is called Cloud SFU. You can read about Cloud SFU, how we made the turn service and the Stunner gateway as the full gateway, and then exposing one IP, one port for the whole Kubernetes, and then making the SFU horizontally scalable. And I was made some demo for showing the monitoring capability and how you can use it. Wait a sec. If I can be able to. So if you wondering how to monitor your WebRTC or what to do with, for example, what you can do with the client monitor, there is this nice thing, monitor cloud SFU.dev, and you can just working around and then see what kind of metrics are available if you are using or what to do, and how to, for example, attach system application context. So later you can able to use it for your own. Here is that the compression rate, I hope. Yeah, then for the samples, please explore. I don't want to waste so much time about it. Because of the Cloud SFU, that how to integrate the observability. If I, yeah, you can also explore that. Why is the context is very important and the integration is crucial? Is that because if you have really the context, you can really connect the dots. So, for example, it's not just the client that what kind of application and CPU is or device is used, but also it's like naturally you can navigate the router or the SFU, the regional SFU, the RTT, or everything what your system was used at the time of the call, which is really helping you to either pinpointing the issues or making key performance indicators and making basically the user experience better. And yeah, basically that was my presentation. To wrap it up, please remember, in order, if I can help you, please remember to add application context and save it with your stats, correlate it. That will massively help you to pinpointing any kind of issues. Please also make careful when you are making score mechanism calculation, but it's also an essential one. And I am encouraging you to integrating your monitoring system in order to take full control of your service. Thank you very much for your time, and yeah.
Thank you very much, Balazs. I think that we have time for one question, at least. Anyone? There's a gentleman over there.
What's the like under the hood the implementation of the attaching of the context? You're basically inserting it into the transport as a pack, like some like service packets, or doing some other mechanism?
No, you are using the client monitor GS's library, so you are integrating into your application and then adding any kind of context you wish, injecting.
Okay, so it's like it's the task for the developer, right?
Yes, naturally, because you know the better your application. The monitor is collecting all of the stats, the derived metrics which can be meaningful, but you can attach any kind of context or attachments to different objects for tracks, for applications, for peer connections, and it's naturally shipped with the samples.
Okay, cool.
All right, let's finish up with another round of applause for Balazs. And our next speaker. It's a difficult spot because it's the last talk before the lunch break, but it's going to be interesting because we are welcoming on the stage Antonio Bevilacqua, who is a software engineer at Miteco. Lorenzo, if you are watching us online, I do believe you are,
all the best to you. And with Antonio, the fun fact is that he's been doing AI stuff for multimedia way before it was cool as it is right now. So he has a great insight, and the floor is yours.
Super. Yep. Wait just a sec. I think I need. Yeah, I think it was working yesterday anyway. Yeah. Okay, so hello everyone. This is my first time at the Rtc.On conference series, so I'm really excited to be here. Thank you for your time, and thanks to the organizers. So I am Antonio. I am a machine learning engineer. I currently work at Miteco. And I apologize in advance, but I'm going to use, at times, the P word in this talk, but I am a Python programmer for both work and leisure. Yeah, so for those of you who don't know Miteco or Mitico, there is still not an agreement on that. We are a Naples-based technology company, and we are specialized in real-time communication technologies. So among other things, we are the guys behind the Janus WebRTC server. I guess some of you might have heard of that. Okay, before we get into the nitty-gritty details of the presentation, I just want to give you like a little, context. So I joined the guys a couple years ago, and the first thing we wanted to do was to transition, our transcription service from like a third-party thing to something more controllable. So we wanted like an in-house thing that we could, interact better with. And of course, everything looked nice and fun and easy. I was like, yeah, no problem, absolutely. Just give me 20 minutes and some duct tape, and you will have your transcriber. Of course, it wasn't that straightforward. So yes, there was something of a learning curve to it. Eventually, we brought it home. But alongside that, we also brought home some lessons. So there was like something we learned from that. First of all, of course, like Python and machine learning, at times like those things are really hard to mix with real-time systems. And then, of course, we started from with a transcriber, but then soon enough we realized, oh, but there is like hundreds of things we could do with that. It's like endless possibilities. So we took all these that we learned, and we decided to stick it into a library that we ended up calling Juturna. There's a funny thing. Juturna is actually, in the Greek mythology, is the wife of Janus, which is the name of the, this is just for you to know. And she's the goddess of fountains, so we associated that with streams. I don't know if, that kind of works, but we're also open for suggestions on the name part. Anyway, long story short, so we have this library, which is a Python library that allows users to design, implement, and manipulate multimedia real-time pipelines. So there is, I think, a little need for explanation here, but essentially you can create these entities that are asynchronous and run in parallel. They can consume input streaming data that can be like multimedia data, but you can actually span them to anything you want, even like tabular, whatever. And then you can transform these data, and you can just send them to any destination you like. So of course there are like many tools, for this sort of trade, but there are like so many ways to skin a cat. And sometimes you might have a hard time if you do that with a spoon. So we wanted something that could actually fit our own needs. We wanted something for fast prototyping. So the idea is that, yes, you have a pipeline for like your service, but maybe you want to change model, you want to use something that works completely different, or you want to use like a different source. You want to use, to send your data to a different thing. So, we needed these, and we also needed something that was somehow self-contained. So like a single Python instance, like a single interpreter that would do like all the things that we needed. So we collected all these thoughts, and we had like some, we kept an eye on some design aspects that we wanted to respect in the library. First of all, it's all Python, of course. This kind of, makes it easier for people that come from that area to kind of like jump in and have like a platform that they can use to just, get in like some data and implement like new algorithms. Then, of course, we wanted something that we could also use like to measure. For example, like you receive like an audio stream, and of course, you want for each package you want to measure like the traversal time of your pipeline, so you can do that. And we also kept an eye on deployment. So with Juturna, you can easily like deploy as many pipelines as you want with like a single Docker container. So that comes pretty straightforward. So this is an example of what a pipeline might look like. So in this particular example, we have like a remote source. It can be a Janus WebRTC server that is forwarding an audio stream or a video stream, but it can be anything else actually, anything that provides RTP in this case. So it can be an FFmpeg process, or it can be GStreamer, it doesn't really matter. And then we have a pipeline that branches out into like two different branches. There is like an audio one and a video one. So for the audio part, we of course read in like the audio stream, and then we pass it on to a voice detector, which essentially will flag the audio content and will signal a transcriber whenever there is a voice activity within that waveform. Then there is a transcriber that transcribes it, and a translator that translates the text that is being transcribed. And both of them, signal the output to HTTP endpoints. For the video part, we have like a video RTP source that sends the frames it receives to a motion detector system that eventually will annotate those frames with a pose estimator model. In this case, might be like a YOLO model, and then everything gets sent using FFmpeg to an output video stream to a destination point. So under the hood, like a pipeline is just like your, regular JSON file. So in this case, there is like a bunch of, meta info, and then there is a collection of nodes and a collection of links. So each node will, of course, it will be decorated with like its own configuration. This is an example of what like the audio RTP configuration might look like. So you want to specify the receiving host and port. You want to specify the audio rate of the source, like how do you want to buffer like the audio you receive. Same goes for the video. I mean, I guess you get the idea. So any node will have these. In this case, for example, we are specifying like the model we are using for the pose estimator. We are using like a YOLO model, and the same goes for the destinations. So once you have these, you specify your links, which is just a connection from like a source node to a destination node. And once you have your hands on these, the only thing you need to do is to load them and create your pipeline. So in order to do so, you need to install the library. So at the moment, Juturna is not published on the Python registry. So we are considering that, but you can just install it as easily from the GitHub repository. And there's like two main components to the Juturna repository. The first one is the core library. So the core library just contains all the basics you need. So like all the basic elements, such as nodes and pipelines. And then there is like a small hub, like integrated utilities for CLI and node downloading. We're going to see that in a second. And then there is a small collection of built-in nodes. So these might be source nodes for audio streams and video streams, or even multimedia files if you want to test your pipelines. And then there is a plugin folder. So this folder essentially, it does not get pulled, when you install the library, but this contains a collection of community nodes. So the idea is that if you work on a node that does something, what you can do is like you run a pull request that will be integrated there, and then other people can use that very node. Or you can just go there and browse it and see, oh, this guy did something that I need to do. I will just pull their nodes. So, okay, to have like an high-level overview of like what happens, within a Juturna process. So you have like your Python interpreter. This can be executed again, like in your local machine or your Docker container, doesn't matter. And this brings in what I just said, so built-in nodes and maybe your local nodes. So these are nodes you are developing, you are designing on your machine, you're working on them. Then you load the configuration file, and maybe you want to access to some of those community nodes. So these are like nodes on the repository. You just can download them, all the nodes that you need. Then maybe you have like some private nodes. So these are like nodes that you're working on with your company or just like by yourself, but you don't want to share them with other people. So you just download them the same way, authenticating the request. Then you assemble them and you create your pipeline. Once the pipeline is created, only thing you need to do is you manage its life cycle. So you warm it up, like you assemble all the resources it needs, you start and you stop it. So there are like a couple of points here in this slide. So the first thing is that, like, as you can see, like nodes, they are able like to get their own resources, and those are like local resources. So in the example that we saw above, like if I am running, I don't know, like a Whisper model for transcription or like any other translation model, it doesn't really matter. Those can be local to your machine, but it's just as easy like if you're using like a third-party service to do so. So you just implement a node that where like respects, like uses like the APIs or whatever third service you have. So this is really up to you. Maybe you have an LLM model that you want to call, and instead of using like an Ollama instance locally, you want to use a remote one because your machine is too old for that, or like you don't have enough VRAM or whatnot. All right, so I want to quickly show you also like some code snippets. I will go fast on these, also because like we're getting close to the lunch break, and I don't want to be in the way. But anyway, yeah, there is really no need like to fully understand. It's just like to give an overview of like the logic of like how you can use this library. And thankfully, Python is like pretty close to pseudocode. It's like dumb enough to be easily understandable by anyone. So, all right. So the first thing you do again is like you can download you can download nodes from the repository. And you can do the same if you have your own node repositories. So those will be privates. Once you have them, you just create the pipeline, you warm it up, then you can start and stop it. So like the start is non-blocking, which is not for granted in Python, but like these pipelines, they will run asynchronously. And yeah, the same things, you can do it using like a CLI. So you can download individual nodes, or you can download full pipelines. So like in this case, Juturna will just scan like a pipeline file, like a configuration file, and go through all the nodes and make them available. So when it comes to designing nodes, again, that should be like, we try to keep that like as easy as possible, because this is intended for fast prototyping. So you should be able like to design your own node in minutes. So the first thing you can do is like you can design like a stub node, and or like you do it manually, it doesn't really matter, but like this is what a node looks like. There is just like a collection of like 4 files by default. Like you have like a configuration file, and then the node class, and then you have like a README file and the requirements file, which might be seen by someone as a courtesy files, but it's a courtesy to whoever is going to use these nodes. So in the class file, which is the .py file, you can see the stub of a node. So again, like a node is just a class that extends base node. In here, you can specify the type the node expects as input, and the type the node is going to provide as output. So this gives more control over like the node interfaces. But essentially here in the constructor of the node, you have access to the configuration elements for that node. These are the ones specified in the big JSON file. So you have like some default values, but you can override them when you create your pipeline. Of course, you can manage resources for that node, so you can require system resources or allocate other static resources, it doesn't matter. You can hot swap some of these values while the pipeline is running. So maybe you are using like a particular model and then you want to change model for any reason, maybe like for load balancing, then you can do it at runtime. Then, of course, like the most important piece of coding here is the update the update method. So this is the method that gets called whenever there is a message available for the node, and the node itself needs to produce a message that will be transmitted downstream in the pipe. So this is what an update might look like. So I take the data from the message I receive, I generate new data, processing them in any way, and then I transmit them. So now, when I implement the update messages, just need to make sure that like the signature of the message respects whatever the node defined here. So if you look at like the class signature, I have two types of payloads that I expect: the input and the output. So in the update signature, I expect that message to contain a payload of the input type, and I expect the update method to transmit a message with a payload of the output type. So we created this mechanism to have like a more standardized way to use nodes. So whenever you want to use like a node, a node implemented by someone else, you wouldn't just get crazy and have to go through their code to understand what the node is returning. Of course, there is also the flexibility to implement your own payload types. All right. So okay, I also wanted to show like a demo, but of course there were like some technical challenges. And for those of you that were like at the last JanusCon, I already presented like a small demo about like a transcription. So I wasn't able like to fully do it here. So the only thing that I managed to concoct is the audio part of like this pipeline that I showed you. So if you can see here on the bottom right of the screen, there is the live transcription of what I'm saying that is followed by the translation. Of course, there are many problems, and even the JanusCon, like it didn't work as we expected, just because we are using the ambient microphone that is picking up my own voice and then the voice recorded from the room, so it's a bit messy. And also because like this is running locally on my machine, the models are distilled, quantized, tiny, so ultimately maybe not the best. This one is the distill, large of Whisper. Here is the configuration that I'm using. And these are the models for the translation. So this is a model from Facebook called No Language Left Behind. It's really not optimized for Italian. So in this case, it's translating Italian. But yeah, this is the idea. And here I am simulating an RTP stream, picking up from my microphone, going into the pipeline, and the pipeline is sending the results to HTTP endpoints, which are still local, but I guess you get the idea. All right, so this is where we stand at the moment. We are supporting a number of like data sources. So we're supporting RTP audio, RTP video. We're supporting multimedia files that came super handy when we needed like to test some of our pipelines. And of course, like at the moment, we are like super easy to integrate with any Janus-based application. And similarly, we support like destination nodes, like sync nodes. We support HTTP, UDP, or WebSockets. Anyway, we are still, this is still a work in progress, like the package is available, so you can download it and use it and break it and put it back together. This is like highly encouraged. Like we would really love to see how Juturna does outside of our own like use cases, so and see whether like it generalizes and can be of any use for you. So that was me. Thank you very much for the attention. And if you have questions or comments, I'm here.
Thank you very much, Antonio. I think that now is the moment of truth who values more curiosity than food, and I think that we already know.
I will have one question. That's
Sure.
a great presentation, by the way.
Thank you.
Love the progress.
Cheers.
You mentioned that you can ingest RTP video. I was wondering if you already have some plugins that deal with video. What are you doing with it at the moment?
So at the moment, so these the pipeline that I showed is actually a two-part. Like we are using both of them. We participated in a project where we are ingesting RTP video and we are annotating it using some custom YOLO models to detect, let's say, dangerous situations in workplaces. So, for example, the one we have in place now is one where like you can look at the frame and you can understand whether there are people without safety helmet. And if you detect one, then you just send an alert. Anyway, for other like demos and things like this, you can just hit me up and.
Sounds awesome.
Thank you,
man.
Cheers.
Any other questions?
Quick one. What about concurrency? Is there, like thread-wise, is there a way to, let's say, parallelize the pipelines? You mentioned like nothing about concurrency. Just curious. It's up to Python to decide, or you have a control over it?
So these are concurrent pipelines. Like this thing is a bit tricky because like by default in threading in Python is kind of a joke. In the sense that
that's what I'm asking. Like, is there any control over, let's say, like Unix environment? You have like POSIX threads, right? Is there a way to distribute between threads at least, or stuff like that, or it's like Python distributes it between threads? You have no idea what's going on there.
No, like by default, like for a pipeline, you ideally have like one thread per node. Okay. Now the thing is that like starting Python 3.13 or something, they give you the option to disable the GIL, so you actually have like real multi-threading. In our experience, though, this works still fine, even if you have like the default GIL multi-threading. This is just because some of these nodes, they perform heavy I/O operations or like GPU or network, which is fine. Like if you go on CPU, though, like you will, this is pretty much running them serially. So yeah.
Cool. Thanks.
No problem.
Transcription for video calls in Janus. Oh, I guess it wasn't heard, so I repeat. Is it how you handle transcription of video calls in Janus?
Yeah, so at the moment we have like a companion app working in Juturna that takes a forwarded Janus audio stream and we annotate it with the transcriptions. We currently use it in production for the IETF meetings. So yeah.
And how it performs, because as far as I know, Janus is highly performant software, and then you throw these streams onto a single-threaded Python instance, and it's able to.
Yeah. Well, I mean, the pipeline can also reside like on a different place, right? So you can have like a different instance. Like the important thing is that you get access to the Janus forwarded stream, so you can actually have like a separate machine where you run your Juturna application. So that's what we are doing. Also because at the IETF we have like 8 parallel tracks. So we can do it with like a couple of instances, but still we need like a separate architecture for that.
Great, thanks.
Cheers.
Any other question? So I'm gonna have a question because the part of the models that you guys are using in this project, I'm just curious, are you taking something off the shelf? Are you doing some tweaking in-house to them? How does it look like?
So at the moment, for everything that we use in production, we are taking off-the-shelf solutions, especially like Whisper. The main problem there is that Whisper is not designed to work on live data. So you would still need to have like some buffering on the data, and then you might have issues, especially when like you cut a word in between like 2 buffers. But at the moment we are fixing that with a kind of like moving buffer. So we are using off-the-shelf solutions in terms of models. But this library, Juturna, can also be used for like training purposes. So if you want to specialize the Whisper instance using, let's say, the IETF dictionary, that's easily done.
Okay. All right. Let's give another round of applause to Antonio.
and we reached the point where I am going to encourage you to scan the QR code and rate this magnificent talk. And it's a lunch break. Lunch is going to take place at the 2nd floor. You need to take the elevator down. It will be served in our canteen, and we'll be back around 2 p.m. Thank you very much.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in the conference with this kind of schedule is absolutely great.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in the conference with this kind of schedule is absolutely great.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in the conference with this kind of schedule is absolutely great.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in the conference with this kind of schedule is absolutely great.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.
that in 5 minutes we will kick it off again after the lunch break. So if anyone needs more coffee to stay sharp and ready to get some hopefully interesting knowledge, please do so now, and we'll be back, I guess now 4 minutes.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.
All right, I think that we are ready to kick it off after the lunch break. I hope that everyone had a wonderful meal and got some time to decompress a little bit and get ready for the second half of the day. We're gonna start this segment with the talk by Jerzy Wilczek. Jerzy, he's a software engineer here at Software Mention, and he's going to tell you the story about his life, actually what he's been doing for the past 18 months or so at work. When Jerzy is not working, he's doing also some nerdy stuff like writing compilers and software to monitor the usage of the CPU by his own. So yeah, let's give a hand to Jerzy.
Thank you. Yeah, I want to talk to you about processing videos using your graphics cards. First, a little bit about me. I guess Maciek already said everything, but hi, I'm Jerzy Wilczek, or you can call me George if that's easier for you to pronounce. I work here at Software Mention, and now we can get into the talk. First of all, why were we here interested in processing videos using the GPU in the first place? I work on a project called Smelter. Smelter is basically a video processing server that can take videos or live streams as inputs, then process them in some way, and then produce some output video or an output stream. And real-time processing is a very important goal for us in Smelter. We want it to work real-time. So you can see how it seems beneficial to use the GPU because it can make stuff faster, more efficient, stuff like that. And for the last 1.5 years, I've been working on using Vulkan Video in Smelter. So now, what's Vulkan Video? The name is made out of 2 words. I thought we can first take a look at each of the words separately. So first of all, what's video? You probably know what video is if you're here at this conference. It's many images in sequence, and they're heavily compressed because uncompressed video is huge, tens of gigabytes per minute of video, basically. And if you want to process a video, then you have to most likely decode it, then modify it in some way, the decoded video, and then encode it again to make it compressed so you can send it over the network or store it in some way or whatever you want. And decoding and encoding are computationally difficult, especially encoding, and consume a lot of resources and are a big bottleneck. So now what's Vulkan? Vulkan is an API for rendering things using the GPU. So it basically exposes the capabilities of your GPU in a programming language. Some of you may not have heard of Vulkan before, but probably most of you heard of OpenGL. And Vulkan is a successor to OpenGL. And a lot of the things that OpenGL did that didn't turn out to be very future-proof, Vulkan basically improves on. So a good example is that OpenGL has a lot of global state, so it's difficult to parallelize because the different threads end up overriding the global state, and it just doesn't work, and Vulkan is made with parallelization in mind, and that's one of the examples. There's a cost to those improvements, because a lot of the things that OpenGL did automatically in a way that turned out not to be very future-proof. In Vulkan, the responsibility for all of those things is just moved to the API user, so you have to implement a lot of stuff yourself. And a good example of that is synchronization. Because imagine that you schedule 2 operations to execute on the GPU, and one operation produces, let's say, like 3 outputs, and the other one uses one of those outputs as its input. If you run this on OpenGL, then when you run the second operation, you have the guarantee that the first one is already finished and all of the outputs are done. And in Vulkan, you have to manually tell the GPU driver that, hey, actually this next operation, it needs this one of the 3 outputs of the previous one, so this one output has to be finished before the next operation starts to execute. And you can see how that kind of gives the GPU driver a lot more information that it can potentially use for optimizations. So it can, for example, figure out that it can produce the one of the outputs first, and then kind of run the second operation in parallel with producing the other 2 outputs of the previous operation. That makes it a bit faster. So now, what's Vulkan Video? It's basically a set of extensions to the Vulkan API that expose access to the hardware decoders and encoders that your GPU has through Vulkan. And the decoding extensions were finalized 2.5 years ago, and encoding 1.5 years ago, which in the world of GPU drivers, that's a very short time. So the drivers didn't have much time to mature yet. But you can have the reasonable question of why should I use Vulkan Video if we have well-established libraries for hardware video coding? And I have an answer to that, and it's a very complicated drawing that I hope to explain to you. This drawing shows on the bottom, the top rectangle on both of those drawings is the GPU, and it has the different parts. And the bottom one is the CPU, and in the middle sits the PCIe bus, which is the interface that the CPU and the GPU use to communicate. And you can see on the top pipeline, if my laser pointing works, yeah, that first the CPU sends the encoded input video into the hardware decoder, and then once the decoder is done, it grabs the decoded output, puts it in the renderer. Then once the renderer is done, it grabs the result and then puts it in the hardware encoder. And then once it's done, only then we receive the encoded output video on the CPU. And this means that the decoded video travels through the PCIe bus and forces the CPU and GPU to synchronize 4 separate times. And this is tens of gigabytes per minute of video for each of those times. So you can see how this is hardly optimal, right? And the bottom pipeline is much nicer in a way, because the CPU only sends the encoded input video to the GPU, then the different components of the GPU kind of exchange the results inside of the GPU, and then the CPU grabs the encoded video at the end. So there's only one synchronization point between the CPU and the GPU, and also there's not much of this travel of huge decoded images through the PCIe bus. So the bottom pipelines is basically what we want to have when we process videos on the GPU, right? And this was possible to do without Vulkan Video, but it was very finicky. And basically, if you made a solution for this, then it would only work on one platform and for one GPU vendor. So a solution that works on Linux for AMD wouldn't work on Windows for AMD, or a solution that works for AMD wouldn't work for NVIDIA, most likely. And in Vulkan Video, this is all part of the same API that all hardware vendors support. So it's a very interesting promise, and that's why we were attracted to trying Vulkan Video, even though it's very new, to achieve the possibility of making those bottom optimized pipelines. So now let's talk about the API, because it's kind of interesting. So the API for decoding in most libraries, most APIs are simple. And basically, you just put the encoded video byte stream in, and you receive raw frames out. I'm talking about the other libraries like NVDEC or NVEng. And Vulkan Video is not like that at all. It turns out that the whole idea behind it is that Vulkan Video only handles the parts of decoding that are computationally difficult. And for example, parsing the byte stream is not very computationally difficult, so you have to do that yourself. And that wouldn't be the end of the world in its own, because there are ready-made parsers that you can use, and it's manageable. But you also have to figure out a lot of stuff from the byte stream. For example, which previous frames are necessary to decode the next frame, because often codecs would kind of tell the decoder that, hey, grab this portion of the previous frame, put it in this new place in the new frame, and this way you only have to store this part of the video once, and that makes it nice to compress. But figuring out and telling the GPU driver manually that actually when you decode this frame, store it in a special place because it might be necessary later, and then later figuring out that, hey, this is no longer needed definitely and we can free up this slot. You would think that this would be easy to figure out, since this is one of the main responsibilities of the video codec. It is surprisingly difficult to figure this stuff out. For those of you who know the specifications or standards for AVC or H.264, you basically have to implement the majority of the 8.2 subsection of the standard, which is very involved, complicated, strangely complex. Now let's talk about encoding. Encoding is fundamentally simpler than encoding, and when we're talking about designing an encoder, because when you have a decoder, you kind of expect it to be able to decode any video you throw at it, right? No matter what produced it, you hope that it will decode anything. And with the encoder, you can kind of pick a feature set and say that we only support this, because in the end, for the encoder, you only care about two things. First of all, that it compresses the video well, and second, that it produces standard compliant byte streams that can be decoded by any decoder. So we can kind of limit the scope of the encoder by, for example, not including legacy features like byte streams that support very old CRT TVs, which are built into a lot of major codecs. It's still a lot to implement by hand. So we decided to make a library that the idea was that it would kind of expose this interface of the nice interface of just putting the byte stream in and getting raw frames out, but also allow you to make those GPU-only video processing pipelines that are very optimized. And the library is called VK Video. It's open source. H.264 decoding fully works, and we're right now ironing out the last kinks in the H.264 encoder. And I expect probably later in the year we'll be working on adding support for newer products like H.265 or AV1. So now, what were the pain points when I was designing and writing this library? First of all, it's a lot of reading of standards. I think 1/3 of development time was just me sitting and reading a huge book about H.264, which is complicated and boring and yeah, not very interesting, honestly. And the other third of development time was spending finding bugs in GPU drivers because the specification is very new. The drivers haven't had the time to mature yet, so they're quite buggy, especially in the case of one company specifically. But maybe you can figure out which one it is on your own. And the bugs in drivers, some of them are quite easy to find. For example, I had the driver just segfault on me. And think about it, like you try to decode the video and your GPU driver segfaults. That's an amazing experience, really recommend it. It turned out that I was passing the driver a C-style array, so a pointer and a length. And I wanted to pass an empty array, so I gave it a null pointer and the length of 0, and the driver just dereferenced that pointer. I don't know for what reason. I don't know what it does with the data. It knows there's nothing there. But some of the bugs can be a lot more difficult to track because they can manifest as just artifacts on the produced video. So you end up spending 8 hours looking at a close-up of Big Buck Bunny's arm, which kind of jiggles as it moves, and it shouldn't be doing that. And then from that, you have to figure out whether this was my not understanding the spec correctly, or me understanding the spec correctly but having a bug in my implementation, or whether this is a bug in a GPU driver, which then sometimes you have to reverse engineer, but don't tell NVIDIA that I do that. And yeah, then even when you find the root cause, it can be really difficult to fix it, because sometimes I had a problem where I was passing, again, a list of something to the driver, and excuse me, the specification didn't specify the order the list should be in, so you understand that the list can be in any order, and on AMD the list indeed can be in any order, but the NVIDIA driver expects the list to be in a very, very specific order, which isn't documented anywhere, and I don't know how anybody is supposed to find which order this is. I just guessed 20 times, and one of the guesses turned out to be correct. So was it worth it? Yeah, I guess it was. This is a result of a benchmark. The benchmark was that we take 4 input videos, arrange them in a grid, and make basically one video with the 4 inputs in a grid. The output was always 1080p 30 FPS. On the x-axis, you can see the resolutions of the input videos, and on the y-axis is how many simultaneous live compositions I can run on my desktop computer with a beefy GPU. And the green bar is FFmpeg with just full software decoding and encoding. The orange bar is using Vulkan video, but doing the 4 times copy through the CPU. And the blue one is having the optimized pipeline. So you can see there is about 1.5 to 2x improvement in throughput, which is quite nice. So what are the conclusions? First of all, Vulkan video is a cool technology. I think it's worth to pay attention to it, and maybe the results will even improve in the future once the drivers have the time to mature. Maybe it will not be such a pain to use. And also, I hope more vendors start supporting it, so maybe we can have one standardized interface for all hardware encoding and decoding, which currently we don't really have. The other thing is try VK video. It's free, it's open source. You can look it up at crates.io, which is the Rust package repository. And third, try Smelter. You can do that at smelter.dev. It's a really nice high-level sort of abstractions on top of those highly optimized GPU pipelines. And yeah, I guess that's it for the talk. Wow. When I was benchmarking this presentation and rehearsing it, I never got below 20 minutes, and now I see that I did it in 16. So we have a lot of time for questions, I guess.
In between encoding and decoding, are there nice Vulkan APIs for like doing the blend of the video streams? Is that easy to use or is it difficult?
I'd say it's rather easy to use. We started using a GPU rendering. One of the main reasons, even before we did Vulkan video, was that the abstractions for processing images on GPUs are very nice. Because you can write things that are called shaders, which are basically like tiny programs that are run on your GPU. And the abstraction is very nice because basically, conceptually, you're treated as you're writing a function that calculates the color of a single pixel. It's a very natural way to transform and process images because you basically write the code that works on each pixel in the image in order to process it, and it's really quite enjoyable, if I may say so myself.
And does that work well across platforms, or do you see the same kind of differences between the GPUs?
Once you have the bugs in the drivers figured out, it works everywhere I've tested.
Thank you.
Yeah, I had a question about the performance metrics. Number one, you said that you were comparing against the CPU. So how many? What was the power of your machine in terms of CPU when you were testing it? And on top of that, I was curious about the latency, like how long it took to encode and decode. Yeah.
Sure. I went back to the benchmarks, but my presentation is no longer on the screen. Yeah, so the parameters of the machine that the benchmark was done on is that it has the GPU is the 7900 XTX from AMD, and the CPU is the Ryzen 5800X, I think. So it's quite, the GPU is quite more beefy than the CPU, but it's rather top of the line from like 2 generations ago or so.
How many cores was that process?
16.
16, okay.
Yeah. And what was the other part of the question? Because I forgot.
Just the latency, if you noticed.
The latency.
Did you measure that at all?
Yeah. I did measure the latency, and it turns out to be, this was quite surprising, but it turned out to be almost exactly the same no matter what you do, which of these 3 processes you do.
Okay, thank you.
First of all, thanks for your presentation. Very, very interesting stuff. I wanted to ask you more about the process of going through and familiarizing yourself with Vulkan video, because I've sort of followed in similar footsteps. And pretty much the only resources that I had access to at the time was Tony Zlatinsky's VK video samples repo from NVIDIA, and the Vulkan and the video coding API documentation. And that's pretty much all that I saw exist at the time. And at every single step of the journey of actually getting video to encode, there were problems and things that are difficult to find answers to. So do you have any other secret resources that you had access to when you were going through this?
No. And Tony Zlatinsky's Vulkan video samples is not very helpful because it's written in an arcane form of C++, which I unfortunately do not understand. I just did it from spec. I just read the specification and nothing else. I mean, I knew how to like render stuff using Vulkan beforehand.
Good stuff. Good work.
Thank you.
Any other questions? If not, let's finish up with the big round of applause for Jerzy. And next up we have Christoph Guttandin. Usually when we speak about the multimedia, we are thinking about servers and all of that stuff, and Christoph is going to bring a browser perspective to the picture. He told me yesterday that by 8 p.m. last night, the presentation wasn't finished, but I guess it's finished right now, so the floor is yours.
You will find out. So yeah, I'm going to talk about web codecs by not talking about web codecs. I will talk about the thing around web codecs, which you mostly have to deal with when you work with it, and it's about media containers. And if you want to click on the links in the slide, you can just go there, but you don't have to right now. You will get the link later on as well. So yeah, as you already know, my name is Christoph. I'm working on multimedia applications in the browser, so I cannot say anything about doing things outside. I'm just doing stuff inside. And I do this long enough, so I eventually became an invited expert at the audio working group of the W3C. And I also do a couple of open source projects which somehow always deal with media and standards. And yeah, I will put in a little shameless plug in my presentation. So as I said, when working on media projects in the web right now, you deal with a lot of APIs, but web codecs is one which I used quite often, fairly recently. And yeah, if you are not lucky to work with media over QUIC, you mostly deal with, let's say, legacy files which you have on your file system that do not only contain the media, they also have a container around it, and naturally you have to pass that container to get to the media. And yeah, so it's a very common problem, and so the natural thing to ask for is, can we just have an API for it? If we have web codecs now, why is there no web container? And actually, people asked for it. It's issue number 24, so it was asked quite early, and it was a very popular issue. But it was eventually closed as a won't fix, and I was not involved in the decision, so but I can somehow imagine why it was made, and I hope you also come to the same conclusion in a few minutes. But before that, let's quickly answer that basic question: what actually is a media file? And if you think about it long enough, like if you spend 8 hours on a train, for example, you kind of realize that this is a philosophical question in the end. Like anything is a media file, but from the web codecs perspective, it's only audio and video and also images. But images are dealt with in a special way. They get their containers passed because the containers of an image are mostly very, very, very tightly coupled to the codec, so that's handled differently. But yeah, from the perspective of web codecs, it's only audio and video, and I also realized that this is a conference for audio and video devs, so it actually fits quite nicely. And yeah, this is the codecs that should be supported by web codecs, and they are not actually in the spec. They are in a separate thing called a registry, which is to allow further codecs to be added later on when the web codec spec is finalized. Well, most probably it will never be, but if it's in a stable state, then adding new codecs will be fairly easy. Like when AV2 comes along, and in some years down the line, then it can be added. And actually, I have a little project which kind of replaces the web codecs API. It's a drop-in replacement. If the API is there, you can use it. If not, it will provide the same API, like you can use it on Node.js. But if the list of codecs was there was no codec that you like, you can use that to extend it and to override existing codecs. So that was my shameless plug. But now back to the topic of parsing containers. And these are just a few popular containers I came up with when thinking about that, the problem. And the reason why I put them on the screen is that if you multiply that with the codecs that you just saw, then you can kind of get an idea on the complexity of the problem. Like an MP4 can contain almost all of the codecs, and WebM as well. And then the others are more specialized, but also they can have multiple codecs inside, which you might not necessarily expect. And another problem is that a codec and the container, I talked about it so far as if it would be two separate things, but in theory they are, but in practice they aren't. As I already said, for images, they are very tightly coupled, like a JPEG always has this certain file format, even though it's actually a codec, like the file format is specified as well, and the same is true for PNG, but MP3 is quite similar. Opus has a kind of a file format for standalone, and so it's very hard to draw a line what actually is a codec and what is the container. And the problem already surfaced when there was an attempt to figure out what to do with priming samples. These are the samples when you have audio in a lossy codec, then you usually need a few samples to prime the decoder to ramp up, basically. And when you do that, you have to discard those samples later on. And sometimes that information is fixed, like for old AAC files, that's, I forgot the number, it's around 1,000 samples. And for old MP3 files, you just don't know. And for a bit newer MP3 files with encoded with lame, there's a special thing in which looks like a regular audio frame, but if you actually parse it, you realize it's metadata. And yeah, it's very complex. It might be, so it's debatable if that's a problem that web codecs should deal with, or if it should be dealt with outside, because no one actually knows if it belongs to the codec or to the container. And then the containers are actually nestable, like that's not a bug, it's a feature. And that's a contrived example, but you could actually build an MP4 which contains an MP3, then has an ID3 tag in it, and then that has a cover image as a JPEG that has an EXIF metadata. And then if you took that picture, for example, with a new Pixel phone, that will be actually a motion photo, and that EXIF will point to an MP4, and then you can go all the way back again. So if you would come up with a specification for all that, you kind of have to account for the fact that this is actually recursive. And then I think the biggest problem actually is that you don't really know what you actually want. Like some people pass the media files just to get the media, which seems reasonable. Some others just want to get the metadata, and maybe you want both. And maybe you don't even know what it is. Like if you want to know the priming samples, for example, then what should it be? And on the very end of the spectrum, you could argue that something in the browser which passes media files should be spec conformant, and if the file is not conformant to the specification, then it should just throw an error. But that's not so easy, because over the years there have been many bugs and de facto standards which were the result of those bugs. Like, for example, WAV files are very old, and at the time there was a hard limit around 2 GB, and you cannot produce any bigger files, and that's kind of used as a hack when you save a WAV file as a stream and you don't know how long it is. You just set it to the maximum file size, and mostly all software interprets that as unknown file size. But actually it's not valid, because it would mean that it should be the maximum file size, and if the file is smaller, it's invalid. Yeah. And so it's actually very hard to say if that's a bug or it's a feature. And yeah, I guess you already know where this was leading to. Like, this is so complex and there are so many nuances that I think no one will ever specify it, because it's so much. Maybe an AI will generate a specification for us in a few years, but I guess until that happens, we have to do it ourselves. And yeah, the usual answer, which most of you will probably also know, is like, can we just use what everyone else is using? Like FFmpeg is used everywhere, and we probably use it right now for the live stream, and it's used inside the browser that I'm using, so why can't we just use it for that too? And the answer is we can. Like the thing inside of FFmpeg which does that is called libav format, and it does exactly what I described. It parses media files and gets out the media data, and you can compile that to WebAssembly. And at first, when you think about it, that's actually what WebAssembly was made for. Like it's a native code base. It's very big. No one wants to rewrite it, and you can compile it with WebAssembly and then run it in the browser. But the downside is that you will end up with a very large FFmpeg build, several megabytes, something around 2 or 3 megabytes right now. And in the end, it might be even slower because FFmpeg is if you need the performance of WebAssembly, then WebAssembly is certainly a good fit. But you have to, if you want to do something with WebAssembly, you have to load the bundle before, and then it has to be parsed and executed, and all the data has to be piped into the WebAssembly realm. And doing that for decoding, for example, might not be a big issue because the decoding takes so much time that the other overhead doesn't really matter. But for parsing just the container, that actually matters because container parsing is not actually compute intensive. Like it's mainly going through a file, and it's more I/O bound than anything else because it just reads a few bytes here and there and passes most of the data through as is. So yeah, it might actually be overkill. And I came up with a few examples to convince you that this is actually the case. Like, as I said, you can use an FFmpeg build for any of this, and it will just work. It will work fine, but I think there's definitely room for improvement. And if you think of a typical streaming service, something that you all know, or a video platform, and they have the luxury that they actually know what they are playing. Like they know the exact file format, they know probably the bitrate and everything else, so they don't really need the full FFmpeg version. And for that, there are options, of course, to compile a certain FFmpeg version which just has the code for a certain container. But yeah, I think you could do this even more flexible by having a standalone library for that. And yeah, the library that I have in mind, or that I would like to have, would be flexible enough to do that as well. That it can be compiled and just results in the code necessary for parsing one container. And if you think this through, then you could actually do this on the server. Like if you if you have server-side rendering for the page, and you have a page which shows the video, you could server render this. And during the server rendering, you could actually already parse the file and then just include little information on where to get the data and how to configure the web codecs API. And that's all it. And then you would not even need any code to parse the file in the browser. And yeah, another example would be like a music player, something like WebAmp, or yeah, anything similar which just plays music. And for that, you would like to have something which plays all the files. And that sounds like a use case for FFmpeg, right? Because you need all the files. And yeah, so why not? But again, I would say if the library is flexible enough, you could use a different library before, like a very small one, like file type, for example, which whenever you see a new file, the user selects a new file, then you quickly parse it with file type just to know what it is, and then you load the tiny piece of code to get to parse that specific container on demand, and yeah, that way you will probably get a much better user experience because the site is interactive right away, and and you don't have to parse the full code. And you could even do this even a bit more elaborate by using something like the idle until urgent strategy. Like if the user doesn't do anything, you start loading a few popular libraries, a code for a few popular containers, and then when the user actually selects a file, then you prioritize the one that is needed. And yeah, then the last example is transcoding or recording app, which also sounds like a use case for the full FFmpeg thing, because if you want to record, then you probably want to have all the options available to record as many files as possible, as many different file formats. But again, you could have a default file format which is pre-selected, and then you load that code. And whenever the user selects a different format, then you just load it on demand. Yeah, so this is the wish list for a library that I have in mind. Like I wanted to have to be tree shakeable. That's the fancy term of saying that if some code is not needed, it should disappear and not end up in the browser. It should be lazy loadable, like when you don't load it at first, like you wait until you need it and then you load it on demand. It should be extendable because I showed you all the different codecs and containers, and no matter how large the library will be, there will always be a container which it doesn't handle, so there should be an option to extend it or to replace logic if needed. And it should be configurable, like you should be able to specify, for example, the size of an awk container or something. Like it should be very specifically configurable and customizable as well. Like if you don't want to pass the metadata passing should not be in the final bundle. And all that should be streamable. Like it should not be necessary to read the full file to get the first information, and it should be possible to skip through the file as well. And yeah, luckily, someone actually did this before I got a chance to give this a try. Like I have a bit of code ready, but I never got around to actually publish it. And yeah, but someone else did. And the library is called Media Bunny, and it's a JavaScript implementation of many popular containers. And yeah, it works very well, and it does almost all of the things that I just said. Like it's tree shakeable and lazy loadable, and I think it could be a bit smaller in the final bundle, but it's actually really good already. It's not really extendable and replaceable yet. You can do it if in a hacky way, but I'm not sure if it's meant to be, but it could be, and it's not really configurable to a very specific way, but it allows you to configure something. Like you can, for example, say that the bit rate should be high or low, but you cannot really say what bit rate it should be. And yeah, but it's streamable and skippable, so it's actually really nice. And while I was on the train on my way here, I hacked together a little proof of concept just to show you an example. That was passing an Opus file and just running through as fast as possible. And with libavjs, which is a WebAssembly compiled FFmpeg version, that took around 130 milliseconds, and the bundle was almost over a megabyte big. And with Media Bunny, that were only 50K, and the time it took was about 1/5 of the one which the FFmpeg version needed. And my ugly code that I put together was a bit smaller, or at least 10 times smaller, but yeah, and the performance was all comparable. But I'm not sure if it's worth spending more time on it now that Media Bunny exists, and also if it's worth getting the numbers even lower, because yeah, the bundle size of Media Bunny is already quite good. Yeah, and that's it. Thank you very much for your attention. And yeah, if you want to get the slides, you can find it here. And if you want to get more information about me, you can get that on that link. Thank you.
Question time. Does anyone have anything on their mind? So I haven't been following the world of multimedia in the browser, but is it right that Media Bunny is just popped up like several months ago? Like, I don't know. I mean,
it must have been in the works for several months. Yeah, I don't know exactly, but I heard about it few weeks ago, and yeah, then I realized at least that at least one more person had the same idea and actually did it.
Because your solution is order of magnitude lighter than Mediabunny, did you compare how they did things comparing to your solution, or?
Yeah, it has. That's what I meant by it's not really customizable. Like you can select a format. For example, I did this demo with an Opus file, and I had just the code to parse an Opus file, but it still parsed a lot of information which I did not need for the use case, and you cannot throw it away. Like it only is tree shakeable on the level of a certain container, but not inside of the container.
Okay.
That's probably the reason.
Thank you for the explanation. All right, unless there are any other questions, let's give a hand to Christoph. I was urged to remind about the QR codes, so I'm doing so. And I guess that we will gonna have kind of a nice segue, because our next speaker, he's there? Yeah. Our next speaker is Michał Sęk. He is a software engineer at Software Mention. I guess with his talk we will go a level deeper in a way, because Michał will be talking about the library that he's been working for the past several months when he's not climbing Fuji mountain or driving through Cambodia on the motorbike. And it will be about bringing audio API to mobile world. This is the first law of conference, that each segment needs to have technical difficulties. So whoever is on the next one, beware. All right. Let's kick it off with a round of applause.
Okay, so hello everyone. As Maciek mentioned, I am Michał Sęk, and I am working as software engineer at Software Mention, and I would like to talk about WebAudio API, which is yet another browser-based audio processing library or media processing library. So for the context, for the more than last year, I have been working on a library called React Native Audio API, which aims to port WebAudio API to React Native ecosystem. And that gave me a glimpse how it works internally and how it sometimes doesn't work. So I would like to share that today. But let's start with the basics. So what actually is WebAudio API? And it is a powerful audio processing engine, which is built around the idea on our audio graph, where we can connect different nodes to create an audio processing pipeline. And at the base, there is interface called audio context. Thanks to it, we can create various nodes, connect them together, and the simplest use case of web audio is probably source node connected through some effects to destination. So for example, we have something reading from a file, going through gain node for volume control, and finally it flows to the device speakers. But of course, we are not limited to single processing lines. We can play multiple sounds at the same time, chain multiple effects, or in some cases, we can even loop the signal. So in web audio, there are three types of nodes that we can use. First one is our source nodes, which act as an input to the system. As example, we can use oscillator, which is able to compute simple tones. audio buffer source node that can play short audio files, and media element source node that can read data from existing on somewhere on the page audio or video tags. Then we have processing nodes, which provides a way to modify the sounds or have an information about what is currently playing. And as example, we can use BQuad filter node, which provides equalizer-like filters, delay nodes, which acts as works like an echo, or dynamic compressor node, which can scale up or scale down the signal going through the graph in order to avoid, for example, clipping or some distorted sounds. Finally, there is an last node that is destination, and usually it is connected directly with the hardware of the system. Another important aspect of Web Audio API is timekeeping and scheduling. It is able to provide us an sample accurate scheduling. So in comparison to audio tag, when we have to tell the audio to play now, or we are hoping for the best that it aligns up with everything else that is happening in the application. Here we can schedule the playback start or stop exactly to fractions of a second. So with keeping that in mind, let's check on the basic example. As I have explained at the beginning, we have to start with creating an audio context first. And for this case of the example, we have to obtain the audio data somehow. Here we can simply fetch it. Then finally, using the decode audio data method of an audio context, we have to decode that, and this will make it available for the entire audio system. Then we can finally create our first source node, which in this case is audio buffer source node, and attach the buffer to it. Finally, we can connect it to the destination and start playing. Where I have the cursor, here it is. And it sounds like something like this. Okay, so in comparison to using just audio tag with single source property, it is a bit more of code to write. So let's see what we can do with it. Okay, so imagine we want to modify the sound to sound like played in some large production hall. And to achieve that, we can use our first processing node, which in this case will be convolver node. As name suggests, it computes linear convolution between two signals. The one is the song that is flowing through the graph. The second one we have to provide as an impulse parameter, and it is just another audio buffer. Here, for simplicity, we can assume we are filling it, for example, with random values. Then, in order to really modify the song, we have to connect this convolver node in between the source and the destination tag. And the effect sounds like this. Okay, that's almost perfect, but let's see what we can do more about that. So in such case, we probably wouldn't hear also as much as of the higher pitch sounds. So let's get rid of them. And we can do that with another processing node, which is called BQuad filter, already mentioned. We'll use that type of low-pass filter to cut off all frequencies above certain threshold. And like previously, we connect it between the previous node and the destination. The effect sounds like that. Okay, so the sound is a bit too quiet for one to hear it probably. So let's fix that in the final step of the example, and we will use an another simple processing node, which in this case is already mentioned gain node. And we will just use it to bump the volume of the entire signal. So the final results sound like this. Okay, but from the beginning of this example, there was one line of code that not necessarily is optimal in real life, and it is not only there because I had to fit everything on the single screen. And it is that every time we want to call onPlay function, we have to create a new audio buffer source node, attach the buffer to it, and finally start it. If you would try to start it for the second time, we'll just get an exception telling us that we don't want to. And this is weird, like having the node stored somewhere that we can reuse every time we want to fire the same exact sound. Wouldn't be like more optimal and performant? And to answer that, I have to explain how Web Audio API works under the hood. But before that, and let's start that the core part of underlying audio engine is an audio thread, which will constantly process the sound. Most important parameter for it, which probably here everyone is familiar with, is on sample rate, which tells how many frames or values for each channel of the sound are within 1 second of the sound. So in the modern devices, the most common value is 44.1K, which means we have to produce 44,100 values for each channel in each second. And of course, going through entire audio graph that user created for each frame would be super slow. So usually the modern audio engines works in batches. In case of Web Audio API, we are talking about batches of 128 frames each. This means that to provide real-time audio experience, we have to traverse entire graph 375 times each second, or provide one batch of the frames in under 3 milliseconds. And this creates some limitations or what we can do on the audio thread itself. And so the first one, probably most important one, is that we can't really allocate any new data there. Everything must be prepared somewhere else and provided to the audio thread beforehand. Second one is that any kind of locking or synchronization method are also forbidden. If the audio thread would have to wait for something, the underlying device system would cut off the thread, making the sound glitch. And the third one, probably obvious at this point, is that tasks not related to the audio processing should be avoided there. So keeping that in mind, let's take a look at some simple, naive approach. So let's say we first would require the user to allocate every resource he wants to use in the audio plane, then create a plan that what should happen with the entire audio from start to the end. And finally, the user will be able to hit some kind of play method or just play button. This way, we meet all of the criteria. Everything is created on the JavaScript thread, so we don't really have to make any new allocations on the audio one. So this one is met. We also have everything pre-planned, so we don't really need to synchronize between the threads. So we also don't need to use any locking mechanism. And lastly, we are just following the plan, so we don't really need to notify anyone or just do any additional data. But with such approach, there's one major issue. and it is not real-time API anymore. So, but here we could argue if the real-time aspect to planning the sound and shaping how it would work is really necessary, such API, and as probably you can guess, yes. Let's imagine a music learning application where first we have to react to anything that user presses on the screen. Secondly, there is some backing track playing along with it. So each time user hits some note, we would, with the naive approach, we would have to stop the sound, create the new pipeline, including the sound that we want, the note we want to play for him, and finally start again. And maybe with some hacks, someone could be able to make it seamless for the user. But let's get one step further and imagine some bullet hell kind of game. Here, we wouldn't be able to provide responsive enough audio. So now let's take a look how it is done in modern browsers, as well as React Native Audio API. So first, we have to get back to the idea of budget frames. Here we can, for simplicity, call it render blocks. And then, just like in the naive approach, we require the user, or actually the API itself enforces that every resource is created on the JavaScript thread. Since from the perspective of the JavaScript thread, allocations is a really quick and simple operation, so we don't have to worry about that. Then when user tries to connect some nodes or start playing at some time, we treat those commands as timeline events. And it gives us two advantages. One of which is that we can, thanks to that, we can keep the order of the commands exactly as user called them. Second one, we can easily enforce or use the time requested by the user in some of the commands, for example, like start. And then those commands will be moved to the audio thread in between the render blocks. Thanks to that, we won't be modifying the audio graph when it is processing the sound, which would again create some glitches. And in the next step, let's check how the graph is modified in between the render blocks. So here we have some already active playing graph. There are two source nodes. One is connected through some effect node and both goes to main volume control and finally to destination. Then user allocates some new resources, which for us from the audio thread perspective at this point doesn't mean anything because we don't have any connections or start calls. But in the same time, one of the already existing nodes stopped playing. So we are marking it as safe for the allocation, which being done on yet another thread, just to avoid also the allocation itself on the audio thread. Okay, then user will finally send us some comments about connections, and those will be executed one by one, modifying the graph. And finally, since the last operation was a disconnect, there is one already existing node that can be safely marked for the allocation, moved to the construction thread, and removed. Okay, and that's it. Sums up the overall overview how the base audio graph processing algorithm works. But let's take also a look at another aspect in the Web Audio API I find a bit weird. So audio context has a property called current time, and it is expected from the users that they will be using that for tracking anything that happens with the audio, as well as scheduling the events. But in contradiction to its name, and everything I could find on the internet, it is not really a time. So the audio context itself tracks how many frames it has processed since the beginning of its creation. And the current time property just returns that value divided by sample rate. So if we would compare this value with, for example, something from performance now or even date now, they would probably misalign but at the same time, the audio context current time is more useful in terms of scheduling, because we can, thanks to that, we can calculate the exact frame we want to start the sound, which in many cases is a must, for example, music applications. And I find it super weird that it is not stated anywhere, because I've seen a lot of people misusing that property or starting or scheduling nodes with just the time obtained from date now or performance now. And to sum up, the Web Audio API is powerful and flexible audio engine which provides ability to create simple playback, create some complex effects, or creates full interactive audio applications. But it does with some share or its own quirks. Some parts of the interface are a bit weird, especially if you don't know the internal implementation. But everything is dictated by either having to work on real-time audio or just by simplicity of the interface. Since nowhere in the example we really had to know what the DSP is. And this makes the Web Audio API really work. The design is performance-driven, and it remains accessible for almost every developer, no matter his audio engineering expertise or not. So it might be a bit strange, but is engine that really makes the web sing. Thank you.
Thank you, Michał. Are there any questions about the presentation? I don't see any hands, so there is a question on my mind. It wasn't touched on necessarily on the presentation, but I do know that you've been working on porting this API to React Native mobile world, and I'm just wondering if the constraint of the mobile world just exacerbate all of the issues that are already there, or quirks, or it's like a smooth sailing, more or less? Or is there anything that surprise you or blow your mind?
Actually, on the mobile, because in the web browser we don't really deal with the device itself. We just have the browser. In the mobile world, another important aspect of the audio are, for example, lock screens integrating with other applications, and so on. And this is another kind of weird world when nothing is really documented well, and you have to guess everything for yourself.
Okay, all right. So good luck with that journey. You will probably need it. Let's thank Michał with another round of applause. Oh, there was a question. I'm sorry.
I had a question. Is it on? Yeah. I was wondering how you implement things like the autoplay policy, like this, the curse in the browser that you cannot really play anything on the audio context unless you initialize it with a user click. Did you do that, or did you just ignore that for now?
We have ignored that part, although we provided a property not existing in the Web Audio API, which can tell the engine to not start on the creation, because we don't have that constraint on the mobile world.
Thank you.
My eyes are terrible, so if I did miss another one.
How do you, hello? How do you achieve proper multi-threaded processing? If you're building a large mixer with many nodes, how to do it properly?
It is a tough one. So most of the nodes reside only on the audio thread. There are some nodes, for example, like the one I have mentioned, which is Convolver node, which inside them, they kind of use multi-threading, but most of the simpler ones are just using the audio thread. And in terms of Convolver node, we haven't really finished its implementation, so I can don't have yet an insight how it works.
Thanks.
Okay, I think that I'm not doing this service to anyone wanting to ask a question anymore. So another round of applause. And yes, please do scan the QR code. And we reached the point where we're gonna start the last of the coffee break for the day. I think that we are a little bit ahead of the schedule, so the next talk is going to start at 4 p.m., I believe. And meanwhile, whoever would like to sit and watch on this screen, there will be interviews conducted by Aaron Syme from WebRTC Ventures. And yeah, we'll be back in 50 minutes. Thank you.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.
Tunable latency. Can you briefly explain that and kind of the value of that? That's one of the things that Mock offers. If there's a use case you're particularly excited about, and any, again, may not get to all of these, but any browser or device limitations currently we should be aware of.
Plenty.
As time permits.
Yeah, it's like, hey, it changes. There'll be changes coming up as well.
Exactly.
We have a lot of changes in the spec that haven't been implemented by the browsers yet. So.
Exactly. So you can just kind of briefly touch on that. And then I'll just kind of end with everybody just kind of asking where people can learn more about, it could be about your work or about the working group, or, feel free to quickly plug a URL or anything that you want to.
Yeah, there's three. The W3C API is one, the IETF mock group is another, and then Open Mock, which is the software group I'm starting. So,
perfect. Yeah.
Those three, I think, would be the problem.
Fantastic. And then when we're done, so that'll be the last question. So when we're done with that, I'll just say thank you. I'll hopefully remember to say to the camera that we'll be right back with another guest in a moment, and then you're.
And you want me to talk to you or to the camera?
I always, when there's a camera, I always try to do, I'm not great at sitting back, but I try to kind of sit back a little bit. I'm going to ask, we're already sitting in a good position where you can talk to me.
Yeah, it's much more natural for me to talk to you than to talk to the camera. So
exactly. So I will talk to the camera a little bit, but it's, we're in a position where the camera's going to see us fine if you talk to me.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.
Welcome to a special episode of WebRTC Live. I'm Aaron Syme, CEO and founder of WebRTC Ventures, and coming to you live today in studio at Software Mansion in Krakow, Poland from the Rtc.On conference. So second year for me attending this conference and doing WebRTC Live from here. And if you have a chance, definitely come check out this conference in person, filled with excellent speakers. Krakow is a really interesting city. But if you're not able to be here, make sure that you do check out their recordings of all of the talks, because we're almost halfway through the conference now, and every talk has been fantastic, and I know there's going to be a lot more. So if you work in the WebRTC space, in streaming media, video, audio engineer of any time, make sure that you check out the Rtc.On conference. And what we're going to do in this special episode of WebRTC Live is I'm going to just have a short conversation with a few different speakers from today. Just give you a little bit of a taste of what they're talking about at the conference, and then you'll be able to go and check out their full talks online afterwards as well. So I'm going to start with Will Law. Thanks for joining me today, Will.
Hey, Aaron. Thanks for having me.
So Will is a chief architect at Akamai and also chairs a working group on the WebTransport API. And you spoke this morning about your title of the talk, a quick update on mock and WebTransport. So let's start with what is the timeline for standardization of mock and WebTransport?
So they're separate groups. I work on the W3C side of WebTransport. So this is the API that enables you to access the WebTransport protocol. That's defined by the IETF. So there's two different timelines there. The majority of the work done in the IETF is done for WebTransport, and I expect it very soon to go to recommendation status. So I put that time box as hopefully the first half of 2026.
Okay.
And at the same time, we want to land the plane on the JavaScript API side, right? We don't want to land it before the actual transport specs specified. So we're trying to coordinate the landing. But I would definitely say, as in the spec world, a year is a decent window, right? Because stuff comes up. But let's say target is the first half of between now and first half of next year.
Okay, great.
On both sides of WebTransport. Mock spec may be similar timeline. That's another group in IETF, the MOQ working group. And the chairs just put out some feelers for when we think we might be able to get the spec towards final resolution. And it's always a point at which you have to put a line in the sand, because there's always new ideas, and there's the temptation to just keep extending it forever. You know, WebRTC famously 8 years, I think.
Yeah, I was going to say, 8, 10 years.
So we don't want that. We want to put a line in the sand, get it out the door, get some implementation experience, and then perhaps go back and revise it in the future. But I would put a similar goal, 2026. Exactly when? Can't say. It's certainly not ready now. We've got 136 open issues. There's a lot of debate going on. There's new features coming in. But all in all, it's improvement. And the oscillations between wireline format and the bits and the structure and the objects, the changes are getting smaller. So they'll go down to a point eventually we can say, okay, let's go with this. And new features will defer to a future version.
Fantastic. So for those not familiar, MOQ is MOQ, stands for Media Over QUIC. But one thing you talked about today is you'd prefer we don't use it as an acronym anymore. I stopped saying Media Over QUIC. We just call it MOQ since it's not just about media.
Yeah, I mean, in a media audience, Media Over QUIC is fine. Many people know it as that. And I think if you're coming from an WebRTC world, it's a very interesting adjacent technology. And I'm not here by any means to say drop WebRTC and move to MOQ. I'm saying MOQ brings you a lot of tools and features that you will find very interesting. And if you come from a WebRTC background, you will appreciate them far faster than some people who have no idea what I'm talking about there. So yeah, it's Media Over QUIC limits it to media, but it doesn't have to be media. It's payload agnostic. So it's moving arbitrary binary payloads in a pub-sub network very efficiently and smoothly. And video is an excellent candidate for payload, but it can be database updates. It can be GPS coordinates of race cars around a track. It can be security system updates. There's a lot of linear timeline information that I want to move between different nodes. And I think that's the market application of MOQ extends beyond audio and video.
Yeah, interesting. So it's similar to what we're used to saying in the WebRTC space then about WebRTC about being about video, audio, but also the often neglected data channels, and you could use it for a lot more.
And a lot of stuff moves over data channel that is not audio and video. You know? And in fact, audio and video moves over data channel even when there's explicit channels for them. So it's a very useful construct. And in MOQ, you sort of see similar architecture.
Now, there's a lot of interesting aspects about MOQ. One of them that particularly interesting for video and audio is the ability to have tunable latency. So can you kind of briefly explain that?
By tunable, we mean that MOQ, you're not bound to a latency first delivery solution. So WebRTC is very good at keeping low latency, and it will lower quality under congestion in order to do that. And that's great if that's what you want to do. But sometimes you might want to make the decision to be higher up the latency tree. In other words, consume video a second after it's produced, because I want a higher quality in my original encoding. Or as a client, I'm willing to wait for objects to be retransmitted on their delivery to me. So Mock gives you the ability to choose where you want to consume the media. It can be at the very live playhead, or it can be anywhere after it. And on the same stream, I might have subscribers who are listening to a real-time conversation, and they can tell the relay, don't send me anything that's more than 200 milliseconds late, because I don't want that. I just want real-time, right? But someone else can say, I'm willing to tolerate 1,000 milliseconds of retransmission, because I want to receive the complete data. And an archival system will say, I'll wait 10 seconds, no problem, retransmit all you like. Because I'm on a bad network, or I'm the other side of the world. So all three can have three different playback experiences from the same bit stream that's coming out of the original publisher. And that, I think, is interesting.
So three different viewers can have a different experience based on that, based on their individual
all can set different prioritization between what they're requesting. So the relay is handling every single last mile delivery independently of the others, and accommodating priority and latency requests that are particular for that end user.
No, that's really interesting, because in WebRTC, when we've thought about trying to do, like, say, a very interactive conference stream to a large number of viewers, but also still be able to take questions from the audience. You know, in the past you kind of talk about, well, maybe we have to segment the audience and have some people connected via WebRTC for real-time interaction, for asking questions remotely, as well as that larger streamed audience. And basically with a mock-based architecture, you don't need to segment that way.
Yeah. And the other factor that's a differentiator between WebRTC and Mock is you can cache Mock. As it's moving through this distribution network, you can optionally cache it at every node. And this is useful for going back in time. So we have a demo of a web conference where we're talking, and normally if you go back, you've got to switch formats. You go to something that converts it to HLS or Dash, and then you have a different player. Maybe it's the same player on the outside, but underneath it's switching formats completely, and it's playing these clips. But with Mock, you can go back, simply subscribe to content from the past, watch that, and then reactivate your subscription to be subscribing from the front edge again, or however close you want to consume it. And that's a very nice feature. As we get into live sports and all of the non-real-time use cases, it's very useful to be able to go back.
Yeah, that's very interesting. Yeah, so, working with WebRTC, I would say, and I'd be curious if you agree, it's still very useful for a lot of the more simpler sort of web conferencing applications and small calls, maybe a little simpler to work with, but much more flexibility for a wider range of use cases.
WebRTC is a fantastically robust ecosystem. It doesn't feel like it when you're working in the innards of it, right? But the reality is, I go to any browser, we take for granted that I can just chat with my parents on the other side of the world.
Right.
And they're not technically advanced, so the system is robust enough and simple enough that we can have video conferences with anyone, anywhere. And I think that's full credit to WebRTC. So it's for as we start to push the boundaries, and we want to decouple the transport from the codecs from the signaling, right? And tease those apart and optimize them in different ways. That's where Mock allows you to do that, and that's where it starts getting interesting.
So then the big question is, what are the limitations of using it now? So we're talking about the first half of next year, but...
Yeah, the spec is not complete, so if you implement it today, the spec might be different next month. This is acknowledged, right? We deal with it. We have draft releases. It's draft 14 as of the start of this month. It'll be draft 15 soon. So if you have a private network where you control the original publisher, all the relays, and the client, you can pick whatever draft you want. It's essentially your private protocol. But if you want interop, a global interop with other vendors across the ecosystem, we really need to get to a final version. So everyone working on it now, most people acknowledge that. So that's WebRTC, you can go use it, it's great. Mock is going to still take more time, hopefully next year. The other issue is it's based on QUIC. There's still some networks in the world that blindly block QUIC, because in the past, any UDP-based traffic has been attack traffic or malicious, and it's not TCP, and these networks are stuck in that world. So as you start seeing more and more HTTP3 traffic, which leverages QUIC, and those networks are blocking it, they'll be pushed back, and they will unblock it. So WebTransport today has an H2 failover mode. If it can't establish QUIC, it'll use H2. You get curiously reliable datagrams as a result. It is a fall down, but that's another factor that you need to bake into if I want to deploy anything with WebTransport or raw QUIC today as network support.
Yeah, and we'll continue to follow the progress of Mach. There's a lot of interesting work going on there. But unfortunately, we need to get to other speakers here, but definitely check out Will's full talk for more. Very quickly, anywhere that you would point users, viewers of this to learn more?
Yeah, so the IETF Mach Working Group, very open. People can go there, sign up. You can look at all the issues that are happening. You can look at the PRs that are being submitted. You can add your own information there. Check that out. We have a software consortium we just started last week to create open source software for Mach at a very sort of high performance level for commercial deployment. It's called OpenMach, so go to openmach.org for info about that.
Fantastic. Thank you very much, Will. Thank you for joining us. Hang on we'll be back in just a moment with our next speaker here in the Experts Lounge from the Rtc.On conference. Thank you, Will.
Oh, you're most welcome. Thank you.
people coming to us and asking for high quality streams. And they always mention they definitely want 4K and 60 FPS is ideal, it seems. And the use cases are very different. It's a live music. It's conferences, events. It's paid content, different type of paid content that people need to pay to provide. There are people that running auctions through the live conferences, and they want to provide best video quality possible.
Fantastic. Yeah, so a lot of use cases beyond the standard sort of meeting tool where maybe it doesn't matter exactly what resolution we're seeing each other in, but like auction's an interesting one I hadn't thought of, to really be able to see the details on that product, see a better image of it can be really important. So I know you cover a number of different challenges around live streaming and high quality at that in your presentation. Which would you say was the hardest challenge to overcome, and why?
There are lots of challenges in terms of 4K. First of all, many of devices, especially the devices that you want to watch on it, are not ready for the 4K. But this is something that we have to deal with it. We need to provide them, additional way to watch it.
Mm-hmm.
But I think this is the most common issue that people they want to watch 4K, but they are not able to. Bandwidth is another issue. It has to be solved. To provide good quality video, you need a lot of bandwidth. From the production side, there are issues from the production side to generate video at high quality and stream it to us so we can redistribute it. It's quite complex. Also scale. So if we're talking about live streaming and you want the stream to be watchable by thousands of customers without any interruption, that's another challenge.
Yeah. So I imagine you're still working with like a very like SFU-based architecture so that you can serve multiple levels of quality to different users based on the device that they're on.
That's correct. Yes. Because we operate on WebRTC. We have SFU as our backend for providing conferences. But why not to use it for the live streaming purposes? It perfectly does what it should do, and we just tweaked it to make it working well with the live conferencing scenarios.
Fantastic. So for those wrapping up here, we've got a lot of great speakers coming up in the conference, and we'll need to get back out there ourselves too. So for someone who is new to streaming media in real time, what sort of advice would you share with them? And should they be maybe if they're doing it for the first time, or if they're considering, do I need 4K 60 FPS?
They should really think if they really need 4K. I think it's still early.
Mm-hmm.
We've been with 1080p for many years, and it worked well. 4K. You probably remember when the 4K TV started appearing, and it was a novelty. Everyone tried to use it, but it turned out most of the content isn't 4K anyway.
Right, so it didn't matter.
So we still need to think whether the 4K is required.
Right.
If it is, the content producer needs to be ready for it.
Mm-hmm.
Need to have good equipment, good internet connectivity. You need to think about the audience, what the audience is, what they're going to watch it, where is the audience, if it's spread across the world or it's in one country. Yeah, many things to consider.
Fantastic. All right, for those watching us, and if they want to learn more about your work or about Stream, where should they go?
Just go to getstream.io. I think it's there's lots of content to learn. We have articles about the live streaming. We have lots of tutorials, how to get started, how to use our APIs, how to use our SDKs, how to embed it in our customers' own applications. And, yeah.
Fantastic. So getstream.io. Thank you so much, Cesar, for joining me. Really appreciate it.
Thank you very much.
Looking forward to your talk.
Yeah, thank you.
Thank you. Appreciate it.
Thank you.
Okay, welcome back to the Experts Rtc.On conference in Krakow, Poland at the offices of Software Mansion. And we have time for one more short interview with one of our speakers here at the conference. And before we get back to the sessions themselves. So I'm here with Christoph Guttandin. And Christoph spoke today about designing a media container library for the web. He's a developer at Media Coatings and also an invited expert for the audio working group at the W3C. So thanks for joining me, Christoph.
Yeah, thanks.
Appreciate it. So let's start, for those not familiar with it, can you give us a quick description of the Web Codecs API and why a real-time developer might be interested in using that?
Well, it's access to the low-level encoding and decoding capabilities in the browser that always have been there, but somewhere buried in the video element or in the WebRTC stack, and now you can get access to it and pipe raw samples or raw pixels from the canvas into it and get encoded data, or the other way around, like, yeah, a bit like FFmpeg in the browser.
Right. And what is, so we could say, if we were kind of thinking about, like WebRTC abstracts out a lot of these things for developers, which is nice, but then having things like the Web Codecs API lets us get a little lower level when we need to, which is also good, right? What's the state of adoption of the Web Codecs API?
Well, let me think. I think quite recently Safari unflagged the support, so it should be in every browser right now, if I'm not mistaken. But
so if it's we were at least very close to it being in Safari, if not.
Yeah.
So yeah, that's usually the question: is it in Safari yet?
It also depends a bit on, like, the Web Codecs API only defines the shell around it, and then the separate thing is the codec support.
Mm-hmm.
Like, and I think that's not near the amount of codec that the spec provides. Like Vorbis, for example, is only in Firefox, but it's broken, and the other browsers don't even have it. And PCM is, I think, only in Firefox, but I might be wrong. But the individual codec support is a different story. Like the API is there, but it might not work for your use case.
For every codec, yeah, that makes sense. So the Web Codecs API is provides basically an API around those codecs, and that's helpful. But then Web Codecs API itself, you're working with things in a media container outside of that, right? So what's the advantage of the media container? Why do people generally like to work with that? Maybe and I know it's also kind of it's a little confusing, and you talked in your presentation, it's a little blurry, the lines between what's a container and what's a codec. So I don't know how deep you want to go into that.
Well, I think containers are definitely necessary if you do want to do anything with the file outside of the browser or outside of the closed environment that you're working with. Like if you want to give your users the option to save a video to disk and you just save the H.264 data, then they cannot do anything with it. But if you package it in an MP4, then they can probably load it in QuickTime and watch it. But yeah, that's probably the necessity. And the other way around, most of the media that we already have is packaged in some form of container. So if you want to access it, then you have to deal with it somehow.
Right. Yeah. So there's layers upon layers in here. What are some of the like current options for wrapping the Web Codecs API? And you had kind of a wish list of things you wanted to see change. You talked about a project you found that's doing at least some of those. Give us a little taste of that.
Yeah, in the very beginning, there was like the natural thing to do, just to compile FFmpeg and in the browser. That was even before Web Codecs was a thing. Then you could just compile the full FFmpeg thing and then use it as a black box, as you would do it on disk normally, like when you work with it outside of the browser. But now the APIs are getting better and better, and we can kind of remove parts from that black box to make it smaller and smaller to get more access to the lower level things. And when WebCodecs came along, you could reduce the FFmpeg build to just handle the parsing of the media containers and do the actual processing with WebCodecs. And that has been done as well, but still I think that it's not flexible enough for the use cases that I had in mind, at least. And that's why I thought it should be much better to provide a dedicated, or to build a dedicated API library for it, which does all that in JavaScript and nicely works with today's bundler and front-end frameworks and all that. That was kind of my wish list.
Fantastic. Well, finally, for anyone watching this who wants to learn more about your work individually or with media codings or the Web Codecs API, where would you send them? Where can they learn more?
Oh, it depends. Like I'm not responsible for the Web Codecs API by any means. So that's right. If you have issues with it, then that's not my problem. But it's a GitHub issue tracker on the W3C, where you can file issues and make comments. And information about myself. Like I have my homepage called mediacodings.com, and that's it. Like I publish articles. Not very often, but sometimes I do, and that's where you can find also my email address if you want to send me a message.
Fantastic. Excellent. Well, Christoph, thank you for joining me. I appreciate it. And for all of you who joined us here in the Expert Lounge at the Rtc.On conference, thank you for joining us here. And we're going to get back in just a moment to the live stream of the Rtc.On conference itself. And if you're watching this through WebRTC Live, then make sure you check out the YouTube channel for Software Mansion and the Rtc.On conference to see all the talks from this excellent conference. And we'll be back in October for WebRTC Live on the 22nd with our next episode of WebRTC Live put on by WebRTC Ventures. And so you can learn more about us at WebRTC.Ventures and the RTC conference at Rtc.On.live. So thanks again for joining us. And thank you, Christoph.
Thanks.
Appreciate it.
Bye.
Okay.
All right, everyone. The final coffee break is approaching its end. We're gonna start in 3 minutes with the last segment for the day. Okay, I think that we are ready to kick it off, the final part of the day. Already on stage, Dan Jenkins. I don't know if Dan needs any introduction, but Sam says that he's the busiest person on earth, the CEO of Nimble, CEO of Evercast. He also recently became editor of Web Spec. And as you can see, he's also getting his hands dirty with hardware. So without further ado, Dan Jenkins.
Thank you. Hello, everyone. Right, so running WebRTC on low-powered and cheap devices. I counted up my slides earlier. I have 91. That may seem like a lot, but if you've been to a talk that I've given, you know it's not. But I have about 6 slides per minute to then be able to do a demo. So it should all work out absolutely fine. So, who am I? I'm Dan Jenkins. Yeah, I'm the founder of Nimble, a consulting company in the UK. I am the organizer of ComCon, and then I'm also the founder of Evercast Labs. And then recently, 2 months ago or so, I became the editor of the Web Spec in the IETF. Everyone else, this wasn't in my slides. Everyone else keeps talking about being part of the IETF, and I was like, I have to get my name in there. So that's what I did. So yeah, Nimble, we're a real-time media consultancy company based in the UK. We work with companies big and small on anything real-time related. ComCon is a conference around real-time communications. It was established back in 2018, and hopefully we have plans to be back next year. We took this year off just because, yeah, life. But we are 99% going to be back next year, and it will probably be in mainland Europe around June, July time. And if you're interested in supporting such a conference, we will be looking for sponsorship soon. So Evercast Labs, we are the creators of Broadcast Bridge, IcePerf, and Dotty boards. Broadcast Bridge is a service to be able to bring remote people into production media workflows in a live sense. IcePerf, we test stun and turn networks. And Dotty boards, I will show you a little bit later. And then we also make the AV connector t-shirt that I'm currently wearing. You can go to evercastlabs.uk and buy one. So yeah, quick note on WEP. We've got a meeting, interim meeting next week So if you've got any gripes / pain points, come talk to me, because we are very close to the end. I'm just here to kind of help push it to the end. So why am I here? Because $5, £5 chips can surprise you, because hacking on hardware is fun, and running WebRTC on low-powered devices is now very much possible. So first things first, what do I mean by low-powered? Do I mean in terms of the amount of energy they consume? No, I mean compute resource. Compute resource means everything when it comes to, say, WebRTC, because WebRTC does encryption and everything else, and so it needs enough compute to be able to do that, to encode video, everything, and it can't just run on a super tiny device. Well, until now. So WebRTC, what is it? Peer-to-peer magic. So you get audio, video, and data. It's open source, browser native, and it runs well on everything now. Browsers, mobile apps, native desktop apps, etc. How does it work? I'm not going to bore you with this. The flow. Everyone knows this flow, hopefully, when it comes to WebRTC. So we create an offer, we send that offer to the other device via a signaling server. That signaling server, that device creates an answer, sends it to the signaling server, sends it back to us. We exchange some ICE candidates via the signaling server, so my diagram is wrong, and then the DTLS handshake and everything happens between the devices. The SSView flow is a bit more complicated, and you end up having to deal with a lot more. But we're back onto low devices. This talk isn't really meant to be about educating you. It's about having some fun. It's meant to be semi-educational. Hopefully you'll come to the end of it and go, all right, that's good. Hopefully it might be inspiring. I think the last time I gave a talk in one of these, someone went and bought what was it? It was a Stream Deck, wasn't it? And he went and built something cool with it and then blogged about it. So hopefully you might do the same. So let's talk about cheap, low-powered devices. Let's talk about the easy ones. Linux boards, SBCs, comfort zone. Since the Raspberry Pi 3, 2 I think was possible, but it didn't really work very well. The 3 until the 5, but let's take a look at the Raspberry Pi 5. So it's a 2.4 gigahertz quad-core 64-bit ARM processor, and it has up to 16 gigabytes of RAM, which is a massive amount of RAM. And generally, it lands between 48 and 115 pounds. You'll notice throughout the talk, I switch between dollars, pounds. It was whatever it was given to me in. I'm not very good at conversions. So that's probably about $60, I think, $65 as a starting price for a Pi 5. Why is it easy? Well, it's Linux. And so you can use all the tools that are available in Linux, right? So video streams really nicely. It has hardware encoders and decoders, and it just kind of works, right? Tim's right there, and he's probably going, it's not really the case. But he's going to talk to you about that after me. But for me, it just works, right? You write some code, and a peer connection gets made. And it's not too difficult to get that going. The Raspberry Pi Zero, I haven't actually got one up here with me. So yeah, Raspberry Pi, right? So it is small. It is actually quite low powered in terms of energy, but it's actually got quite a lot of power. The Raspberry Pi Zero through to the 2W, it kind of compares to the Pi 3, roughly, in terms of specs. It's a quad-core at 1 gigahertz, and it's got 512 meg of RAM. And these start at £15, so a much better way of kind of getting into building stuff. But ultimately, it runs Linux. And then we can insert loads of other SBCs in here as well. So I've got an Orange Pi Mini, I think this is, Cadus Vim 4, insert loads of others, and you can run Linux on them and, do WebRTC on them. But to me, Linux equals easy WebRTC. Again, I feel a glare from Tim over here. But we want the pain, right? We want to learn something. So now to the other extreme. And this, really, I'm going to get a glare from Tim. So now to the other extreme. Back in 2015, this is probably one of my favorite conference videos ever. Tim did a Cranky Geek event in, I think, San Francisco. And he put a Lego EV3 brick thing on the floor, and it looked like a dog. If you don't know what an EV3 is, it was a programmable thing. You plugged loads of sensors into it, and you got Lego to move and stuff like that. So the Lego EV3, it was an ARM9 processor at 300 megahertz. So not dual core or anything, just 300 megahertz. It had 64 meg of RAM, and it had some custom firmware on it to get a Linux prompt on it. Yeah, Tim Panton from 10 years ago. So I just want to play. Hopefully this is going to start at the right time.
I went out and bought myself a toy.
So this is an EV3.
I bought myself a Lego EV3. Now the EV3 is exactly that spec. It's a 300 megahertz ARM9 running Linux, and some clown has, it's open source, right? So some clown rebuilt the OS so that it took all the Lego stuff out, and you run a plain Linux, and then some other clown, and I just admire the open source community for this, went and put a Java API on it.
Right, so we can move forward a bit. So he goes and puts it on the floor, and then it takes about 3 minutes.
Right, so now.
It takes about 3 minutes from Tim getting back to.
That's a distraction.
Tim getting back to his laptop.
Right, so.
And pressing go.
Right. So I need to kill. Kill. No, I need to kill the current menuing system that's running on there.
Right, we can skip forward a little bit.
Starting Java on a 300 megahertz ARM and pulling in the DTLS crypto library. So
3 minutes later, we finally get to a good point. It's actually really good. You should go watch it.
There we go. Got it.
But
right. So.
And then Tim literally starts driving.
Packets are going. We now have a data channel running.
We have a data channel running. And then Tim starts driving it around this conference in San Francisco. That doesn't sound that exciting, right? But for me, back in 2015...
have I gone too far?
Let's go forward. There we go.
Turn.
Oh, no. There we go. Let's refresh. Let's go back to full screen. For me, back in 2015, that was like the epitome of awesome, right? Being able to get something that's doing crypto and everything else running on a device that was never even meant to run this stuff in the first place, and Tim just, waltzes and puts it down on the floor and drives it around. To me, that was really cool. And when I first started playing around with hardware, that's what kind of came to my mind. So yeah, Lego Barks WebRTC. For me, that was hacking hardware and to do it really, really well. So what else? What other low-powered devices do we have? So loads of surveillance cameras now run WebRTC within them. Your Ring doorbell, for example, / any other doorbell. That's all WebRTC. In the very early days, it wasn't WebRTC. It was like SIP and RTP and without any encryption to a degree. But times have moved on. And so you buy a surveillance camera that is Wi-Fi, and it's probably running WebRTC. Baby monitor cameras, etc. And so these are running on, quad-core, 1.2 gigahertz, like super high power in the grand scheme of things into this little device. A blast from the past. Stadia Chromecast Ultra and the Stadia controller. Did you all know that was actually WebRTC? So the Chromecast Ultra had a hardware decoder in it. It was Wi-Fi connected, and it dealt with up to 60 frames per second, 4K video and audio. And that was all delivered over WebRTC. That's kind of cool, right? For me, it was the controller that was the more interesting thing. The controller had a microcontroller in it and did connected up to the media server that was running the game over the data channel, and you controlled the game directly. So Wi-Fi gamepad, WebRTC data channel, and it was a direct connection to the cloud. Damn, this is all very interesting, but like, how is this actually interesting at all? So let's take a look at the here and now, right, instead of looking at history. So for me, playing with hardware is fun now. 10 years ago, I looked on at Tim and went, I could never do that. That's ridiculous. But now you can go and buy devices that look like this, and they're self-contained, and you can, plug things in, but you can start hacking on WebRTC on a device that's super tiny and not that expensive at all. So let's take a look at now. Raspberry Pi microcontrollers. So this one here is an Interstate 75 board from a company called Pi Moroni in the UK. But on it is a RP2350 chip from Raspberry Pi. So that's a microcontroller. And you can run data channel on that chip. So they're extremely cheap, but very problematic. So they've only got a 150 megahertz system clock, so even less than the EV3, but it's a dual core, not, so let's say it's about the same, yeah? And it's got 520 kilobytes of RAM on it. There you go. I think I missed something on the bottom. So there's no connectivity on it. It's just a chip. It's just a microcontroller. And they cost about 90p each. So that's pretty cool, right? You can buy a chip. Sure, you have to make your PCB and everything, but the actual chip that does all the hard work is 90p. You then have to buy an RM2 module or a Wi-Fi module or whatever, and then that will give you connectivity. That chip is about £4. So let's say £5, right? That's buying it and putting it on a PCB yourself, et cetera, et cetera. But that's, no one wants to do that. So you can go and buy yourself, I can't really hold this up. Let's do that. There you go. So this is a Pico. It's actually the Pi Moroni's version of a Pico, but you can go buy that, and that is about £7, £9, something like that. I can't remember off the top of my head. But yes, you can go and do stuff with it. I haven't tried with media yet, but you can definitely start up a data channel. And there's a project called libpeer, and you're going to hear about libpeer quite a bit. So that's quite interesting, and actually quite cheap. But onto ESP32S3. So the ESP32S3 is what is in this, it's what's in this, it's what's in this, it's what's on this. So you can go and buy loads and loads of devices that are based off of an ESP32S3. So the specs for an ESP32S3, you can get different variations and things, but for the easy part, it's a dual core 250 megahertz processor, and it's got 512 kilobits of RAM, but you can add more to it. Why ESP32S3? So they are cheap, and they handle real-time media, and it's one chip that you can go and, it's not like the RP2350 where you have to combine stuff. It's one chip. You can buy that one chip and go get started on it. So it does support audio, and it does support video, and it does support the data channel. And the libpeer project has support for it. But the company behind ESP32s, Espressif, have their own version now that is better supported. Public service announcement. If you're just getting started into hardware, you might hear people talking about ESP32s. Well, an ESP32 doesn't equal an ESP32S3. They're actually, very different. And there are there's a P4, there's an S2. Anyway, the one that you want to be looking for, the one that's really well supported within the ecosystem is the S3. So yeah, super important. You can't just go buy any random ESP32 and expect it to work. Yeah, so lots and lots of devices, like I say, that you can go and buy, ready-made, and play with it, which makes it really, really accessible. So the things that I held up here, these are all from a company or a project called the M5 Stack. And so this is a cardputer, and this is $40. This is a Atom S3R. This is not the camera version, but there is a camera version that's $24. This version is $21. You can literally go and plug and play. So this is the M5 burner application, and literally you go and download an application such as the OpenAI voice assistant for the Atom S3R. But I'm actually going to use this one. And you can just, plug it in and, shove a program on it, and then it's on there. So it's plug and play. Let's see whether or not I can... there we go. So I've put the ChatGPT OpenAI app, and hello, OpenAI.
Hi there.
How are you today?
I'm doing great. Thanks for asking.
The Wi-Fi's not great, but you get the idea. I literally went and downloaded M5 Burner, plugged it in, pressed burn, gave it an API key, boom. This little device here is talking to OpenAI's real-time API. That's pretty cool, right? So plug and play, blah, 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 right. Yeah, M5 Stack and OpenAI. So yes, you can go and build with the ESP32 with the OpenAI real-time API. PipeCat is another project that kind of helps deal with LLMs and things with WebRTC, and the PipeCat project also have a load of images already made for the M5 Stack. So you can go and build a $25 chatbot. So demo maybe. I should have removed the maybe. I've just done the demo. So that's really quite cool. But what else? Earlier I mentioned Dotty boards. Dotty boards are a product that we sell, and they are an LED matrix, this one here. The ones we sell aren't broken. I take my broken one with me when I'm traveling. But this here creates a Dotty board, and we currently use a Raspberry Pi 2350, but we're actually in the middle of migrating to an ESP32 ecosystem. So it shows data related to a hobby. So this is our first version, and anyone from the UK knows who the RNLI is, but they are our lifeboats, and they're a charity all over the UK, including Ireland. And this board kind of lights up and tells you stats and things like that. When this picture was taken, the RNLI had gone out 6,890 times this year. It's more like 8,000 now, I think. And this is hopefully a video. I need to hurry up. 4 minutes left. There you go. So we push down events, but that all happens over WebSockets. And we're in the process of moving to an ESP32 ecosystem. And like I said, I'm not used to this new app for slides. So like I said, we're starting on the ESP32 journey. I hate that word, journey, but I'm going to use it anyway. So we're in the process of making our own PCB that we own everything to, and it's been a mega journey. I've used the word journey again. I apologize. It's been a huge challenge for a non-hardware person like myself. So yeah, I got interested in running WebRTC on ESP32s because I could, and like this is what I do for a job. And so I stupidly put a talk into a conference about running WebRTC on low-powered devices before I'd actually got WebRTC running on a low-powered device. It's a great way of like incentivizing you to go and learn something new. So I was talking to Tim Panton about this, and he said, I want to see your Dotty boards running WebRTC, using WebRTC to deliver. It's completely over the top, completely unnecessary, We don't need real-time integration into Dotty boards at all, but it sounded like a fun challenge. So that's what we did. So this is, well, I say that's what we did. I kind of got halfway there. So this here is an ESP32S3 dev kit. And so you can see I'm plugged into the board. And if I plug it in to the power, so let's plug the power to the display, and then I should have another USB-C cable here for this. This might go terribly wrong. I will warn you. So hopefully that board's just lit up with a yellow line. Yeah, great. So let's trying to do this without being able to see what is going on is challenging. So let's close that. M5 burner, we don't need that. And then here we go. Right. So I'm gonna monitor this device, this ESP32, and I'm also going to go back to this website that doesn't look at all like AI generated it for me. So if I connect to the signaling server that you can see is running in the background there, and then it's connected via a data channel to this board. So hopefully, if I fill it with red, yeah, right? So the setting up that session happened over a signaling server because it has to, right? WebRTC isn't magic. We still need that thing that passes those messages. But I can turn off that signaling server and I can still, control this board. So it should be blue now. It should be green. And then if I, let's clear the canvas and let's clear the screen, and then we can draw on my canvas up here, and hopefully if I press send to LEDs, it's gonna magically appear, right? So we're mapping all of those pixels on this canvas, this HTML canvas, and we're saying, oh, that's 0, 0, that's 0, 1, right? And then we're sending those to the board. Shush, shush. Is it fixed? Anyway, should be like that, shouldn't it? Anyway, so that's all happening over WebRTC from my laptop to this board right here, and up until earlier this week, none of this existed, and that's how good the ecosystem around this is now, and that's pretty damn impressive. So if I go back to my talk, right, done the demo, and it went semi-well. So data channels go over to the live pixels, and the WebRTC is powering a private real-time interaction with the Dotty board. It's not quite as finished as I'd hoped. I really wanted to get, the country outline and alert, but I ran out of time. Bad Dan for not starting earlier, but it is what it is. But yeah, what a journey. I'm sorry again. How is this helpful? I'm now over time. How is this helpful? I told you. I was going for fun, but what is the future? The future is AI. The future is WebRTC in edge devices or media MOQ, mock, not media over QUIC. We've been told it's not media over QUIC anymore. It's mock. It's this all at the edge. So cheaper chips, better SDKs, 5G everywhere, so you can, you don't have to be connected to Wi-Fi, and you can contribute and consume anywhere using WIP and Web when it comes to WebRTC. The takeaways: hack, share, inspire people. Thank you very much. The shout out, Tim Panton, Expressive, Sean Dubois, because he really encouraged me, and the PipeCat team for everything that they put out open source. And then you can reach me on X, Mastodon, Blue Sky, LinkedIn, everywhere. And that's my email address for anyone that still uses email. That's it. Thank you very much. I was only 2 minutes over. I'm pretty happy.
Yeah, it was worth it, I would say. Okay, we obviously do have time for some questions. Anyone?
So can I connect a camera to this ESP32
Yes.
and stream via WebRTC?
Yes, so this one here, this M5 stack, I can't remember the exact name of it, but it's like, I think it's called a Core S3. This has a camera built into it. So you can literally go and play with this today and get video and audio streaming out, and you can play. It might not be the best video, you can play video back on the screen as well. So yes, absolutely, you can go and you just build stuff today. Finding the docs and things is a bit challenging. I'm going to write up a blog post after this of the challenges that I faced in the week that I've been doing this. I hope that answered the question.
Thank you.
Any other questions?
Who's going to go buy a device and tinker? I have one hand. I've won with the one hand, so that's great. 2 hands. 3. Do we have 5? Anyway, yes, great. Okay, thank you very much.
All right, let's wrap it up with a round of applause. So, given what Dan was talking about, it will be very unwise not to have Tim Panton as a next speaker on the stage. Tim is a co-founder and CTO of Pipe, and probably you might have seen some of his talks before, even on the previous talk. And yeah, if I were to say what it's going to be about, I think that you're gonna learn all of the weird things that can happen if you put a pedal to the metal in the race car.
I need the
and it's
audio
not
lead.
something that you would think it is. I told you, there is this law of conference. Each section needs to have some technical problems. So here it goes. All right, we are ready. Let's start with a round of applause.
Thanks to Dan for the intro, and thanks for all of you for coming and inviting me and whatever. So yeah, this is actually much more pragmatic than you might expect from me. This is very kind of detailed stuff of like, how do you get the glass-to-glass latency of a video stream as low as you can? And it turns out that it's just a series of trimming at each layer. So I'm Tim Panton, I'm the CTO at Pipe. I wrote 10 years ago, it turns out, a WebRTC stack for small devices, and it's sort of still doing things. It's still in baby monitors, but it's also going around racetracks at 250 kph, which is kind of fun. I write open source. There's a bunch of protocol implementations, and also something else. I'm not quite sure what you call it, but an interface for v4L2, all in pure Java, because, well, memory safety, basically. So this is a race car camera. So this camera sits over the driver's shoulder, and it sends live video and audio to the pit crew in high quality, at low latency, over a long range. I say long range, but like 5 kilometers typically are these tracks in diameter. And at high speeds, not only like reasonable bit rates, but also the cars are moving quite fast. And we use public 5G networks for this. And it's not broadcast, right? The end consumer of this is the pit crew and the team sponsors. It's not the wider audience. So it's not broadcast. And this is what it looks like and sounds like. V8s are astonishingly noisy if you take the silencers off. But yeah, it's kind of gets you going a bit. The other thing we're doing is, with the same technology, we're putting these cameras, we're investigating putting these cameras into autonomous vehicles. With some funding from the EU, we're doing this investigation. Initially, we've done some technical tests to see whether it makes sense, whether it works, and now we're looking at the regulatory aspects of like whether there's a legislative and a practical requirement for this. And basically the idea is it allows a remote human to supervise and see what the autonomous vehicle is doing. And one time in 1,000, maybe intervene and tell it that, yes, it is allowed to go around that tree that's fallen in the road or, you know, whatever. And probably as a hint, rather than actually driving it, the remote operator is not going to have probably not going to have a steering wheel in their hand. They're probably going to just like okay a menu of options that the autonomous vehicle provides them with. And our camera works pretty well for this. This is a test we did at the former Tegel airport, where you can run autonomous vehicles without like much difficulty. There's no safety, well, there's safety issues, but they're much constrained. So what protocol could we use for doing that? I mean, it's just slightly cheating asking this question, but I'll ask it anyway. So I asked ChatGPT, actually, and ChatGPT produced this list, which you're all probably pretty familiar with. They're all protocols. It was interesting to see that RTSP is still on that list, which I think is probably the oldest one there. But anyway, so it gave me this list, and basically what that means is you have to make a decision about what latency is acceptable. So what does latency mean in the context of a race car? And the answer is that 10 seconds, which is a kind of median of those protocols, is a heck of a long way on a racetrack, right? And you start talking about the corner you're approaching, and he's actually there. It doesn't make any sense anymore. So it matters. The 10-second thing isn't going to work in this context. So what is the goal? Like, how do you know what number is enough? So there are a couple of metrics, and one of them is that actually you can hear the gear changer on a V8 from at least 100 meters away. So we reckon that in order for that to be kind of roughly right, you want the speed of sound. You've got the time of the speed of sound of it actually arriving and it arriving over your laptop, and you want them roughly in sync. And so that gives you 290 milliseconds based on the speed of sound in warm air. So that's like, gives you one metric. The other one for the autonomous vehicles is that it turns out that the American drink drive limit for blood alcohol is roughly equivalent to 200 milliseconds of cognitive impairment. So that gives you a measure for like how long you can wait before you make your mind up. So we reckon that aiming for under 200 milliseconds was a safe bet. That is the low end of what WebRTC can do, and as far as ChatGPT is concerned, sorry Ali, I know this is disagreed with, but ChatGPT tells me that no other protocol will do that, including mock. So yeah, I'm sure I'll be told I'm wrong about that, but anyway. So, or ChatGPT's wrong, it's not me. And I do love having an AI to blame for my mistakes and for justifying my decisions. It's really nice. So this is a typical pipe device. It's a Linux box. I don't do these little devices yet. Dan is braver than me in that context. Sits there, it runs as an agent. And typically we have an H.264 feed and maybe a microphone and some data and whatever. And we run it over a peer-to-peer connection with data channel. And over the data channel, we can carry things like LiDAR and PTZ commands and setting the hue, saturation, and brightness and stuff like that. So there's more data that goes over the data channel. It's useful to have that data channel around, which some of the other protocols don't support, like RTSP doesn't support a side channel for data. So how do I measure latency, right? Well, the easy way, which is basically very easy to do, you go to a website, and this is clock.zone, and you put this clock on the screen, and then you point the video camera at the screen, and then you put the video output displayed next to it, and you do a screenshot. And you inspect them and you do the subtraction in your head and you come out with, in this case, 350 milliseconds. The problem is that it's not truly glass to glass. It's not from that lens to this screen because it's never left this screen. Like the screen cap is before it's left the glass. And what's worse, that screen cap could be in some way synchronized to the rendering engine because it's on the same hardware and it's probably done in the same, GPU or whatever. So you've got some correlation risks there. And it's a pain in the neck to do each time. You have to kind of do it manually. So we ended up building this thing, which is essentially it's doing the same thing. You point your camera at a light source in this case, and what we're really simulating is like the brake lights of the car in front, right? The brake light comes on, and how long does it take from that light coming on to the remote supervisor seeing that on their screen? That's the measure you're looking at. And so basically what happens is that we flash the light in front of the camera, and then we render that camera onto a screen over the appropriate video link, and then we put a light sensor on it. And the light sensor and the flash are connected on the same, in this case, BeagleBone, small processor, and it can measure the time difference between the two. And that actually, and there's an open source thing on GitHub with the software for that and a description of the hardware for it. But it can give you a reasonably accurate measurement down to certainly 5 to 10 millisecond accuracy for what the latency of a call is. So, yeah, so having got a way of measuring it, I've now got to get down from 350 to sub 200. And that's basically a matter of working through each of the layers and taking stuff out. So the big one, the big saving, was 40 milliseconds in getting rid of GStreamer. Now, I love GStreamer. It's a great thing to use, and like it's the first starting point in all of the projects to put a GStreamer pipeline together and do something. Problem is, it's a pipeline. So intrinsically, it has several frames in the pipeline. And the thing with pipelines is nothing comes out until you've filled it. And so you end up with a couple of frames worth of latency in a typical GStreamer pipeline. And however hard you do it, you still end up with some latency. So what we ended up doing is talking direct to the encoder and talking directly to the camera. And in this particular hardware, that's not too difficult. I put it off for a very long time because I didn't want to do it in JNI, but I still wanted to use Java. And Java 24 has this really sweet, well, 23 technically, has this really sweet thing which is foreign functions and memory, which is a replacement for JNI. They deny it. They say it's nothing to do with JNI, but it's effectively a replacement for JNI, which allows you to do memory-safe access to foreign DLLs or foreign.SOs, which is actually really sweet. So basically, we can mmap video buffers into Java's memory, tell Java that that's what it is, and Java will treat it safely. And we can get callbacks from v4l2, which says when they've been updated, and we can treat them, which I like, not as much as I liked reading from dev video. Like, I'm a Plan 9 guy, really, at heart, and reading from dev video was a much cleaner way of doing it, but nobody supports that anymore. So that was 40 milliseconds, which is nice. Weirdly, moving to IPv6 from IPv4 will give you around 10 millisecond saving, if you can, because it gets rid of NAT. Gets rid of NAT in the camera, because we've got a 5G modem in the camera, right? And that's doing its own NAT if it gets a v4 address. And then the carrier gateway is doing another set of NAT, and then the local router and local Wi-Fi are doing another set of NAT, and each of those is running queues. So it looks like getting rid of those queues and getting rid of that NAT processing saves you around 10 milliseconds, which is worth having. And then the same sort of saving is available if you get rid of turn candidates. If you don't do turn, if you can get a direct, genuinely peer-to-peer, address-to-address session, then it takes a leg out of the trip. Now, that doesn't always work. There are cases where routing via a turn server from someone like Cloudflare, for example, will actually be quicker, but it's typically only quicker if you change jurisdictions. Like, our users are typically less than 5 kilometers away from the source. And so they're always in the same country, right? So if we can get, and the turn servers almost never are. So like if we can stay in country, that's a win. So yeah, host candidates are a good win, often, but not always. This was the surprise, one of the surprising ones. And some of them were, these things are relatively obvious. But this one I just hadn't seen coming at all, which is if you disable lip sync. Now, you can't see the driver, right? There's no lips to sync with in any of our videos, right? So we don't care about whether the audio is synchronized accurately with the video. And it turns out that doing that costs you 20 milliseconds. And it's essentially, as far as I can work out, is because there's no sensible common factor between the 20 millisecond audio frames and the 33 millisecond video frames. So to get them to line up, you have to like go to multiples of 60, and that's even that's not accurate. So it turns out that the whole thing delays by pretty much a whole audio frame in order to sync the video. So there's a 20 millisecond saving there if you lose lip sync, which I was quite pleased with. Cheap, well, it's not actually cheap, but easy win is to go out and buy a faster monitor, right? You just go out and buy a gamer's monitor and you've saved yourself 10 milliseconds. More expensive, go out and buy a faster internet connection. Get fiber to the premises and not fiber to the curb, and get rid of your DSL line, right? Those will win you certainly 10 milliseconds, probably more. I mean, somebody was telling me they have 2 millisecond ping to Google from their fiber at home, and that would save me another, that would be like 18 then. Weirdly, this was one that, again, surprised me. I thought it wouldn't make any difference. I thought moving from Wi-Fi to Ethernet on a non-busy Wi-Fi really wouldn't make any difference. But it turns out that's not true. There's more jitter on Wi-Fi. Even relatively empty Wi-Fi has more jitter on it than an Ethernet. So if you get rid of in the step between the fiber and your viewing station, you get rid of the Wi-Fi and you start doing that over fiber, you can trim the jitter buffer by another 5 milliseconds. It's not a huge saving, but it's worth having. And I point out that at this juncture, we're getting close to 200 milliseconds, which is nice. Now, this was another total shock, right? I actually didn't believe this when I did it, and I suspect that it won't last long, particularly not after this presentation. Somebody in the Chrome team will fix it. But last time I measured it, Safari is on H.264 is 20 milliseconds faster at rendering than Chrome. And it looks like the reason is really funny, which is that Chrome doesn't believe that you've finished getting the packets for a frame until it sees the marker bit on the subsequent RTP packet for the next frame, on the first RTP packet for the next frame. And then it says, oh, okay, I must have had the last frame, and starts rendering it. Whereas Safari is depacketizing each of the packets in that frame and interpreting at least at the null level. So it knows that the last packet is the last packet, and it kicks it off to the renderer there. Now, if you're completely filling the pipeline, that doesn't make any difference. But if you're, which we often are with 5G, if you've got excess uplink, then you may have like half a frame time between, or more, between when your last packet turns up and the first packet of the next one, or the next frame. So we can get up to 20 milliseconds saving by switching to Safari from Chrome. Now, like I say, I'm absolutely sure that won't last. But it will mean that Chrome is faster when they do it. And it also may not be true for VP8. Yeah, local ASIM, this is sort of one of those more obvious things, which is that not all SIMs, not all 5G connectivity in the camera is the same. Like, you're constrained somewhat by the economics and the availability, but if you can get a SIM from the local provider, like if I could go down and if I'd gone out and got an eSIM from Plus or whoever here and loaded it in there, as opposed to what I'm doing at the moment, which is roaming from a European provider, that would save me 15 milliseconds, because all of the roaming providers have to wrap up the local traffic into a VPN, send it back to their home country, and then send it back here. And that costs a varying amount, but of the order of 15 milliseconds. Now, again, it's not disastrous. Like, none of these things on their own are disastrously bad, but if you can trim each of them out, you can get closer and closer to the 200 millisecond target. So, yeah, surprisingly, 4G, good 4G, is better than bad 5G, in the sense that it has less jitter. It's not necessarily to do with the actual bit rate, it's to do with the fact that if you get a delayed packet or two, Chrome, or a lost packet or two, Chrome will grow the jitter, Chrome or LibWebRTC strictly, will grow the jitter buffer, and so you'll end up being delayed a bit. Whereas if you can get a solid 4G connection that's consistent, then you won't have that problem. So there's another 10 milliseconds there. This is the big win. Actually, this was the first big win that we had, which is essentially it's also about managing the jitter buffer at both ends, of using bandwidth estimation to be super aggressive about not letting queues arrive anywhere in the path. And when you do lose a packet, if it's an old packet, you don't RTX it. Because if you RTX it, then what happens is that, like, everything gets delayed until it turns up, and then you end up with a bigger jitter buffer. So we keep a much shorter cache than I'd expected for RTXs, and you never ever, or rather we never ever resend, never ever RTX anything that's older than the last full frame, because there's no point. It'll never get physically rendered onto the screen, and it will grow the jitter buffer for you, whether you want it or not. So the big kind of takeaway message of that is we back off super fast the moment we see anything that looks like a queue forming, and then we ramp up slowly afterwards. This isn't available under many circumstances, but in a few tracks and in a few races it is, where there's a private 5G network. So you're not on public 5G, you're on private 5G. And it's the same protocol, so in theory you'd think it wouldn't make much difference, but there are two factors that mean that you can save 10 or more milliseconds. And one of them is that private 5G, the core, you can be running the core on a little rack next to you, and you can basically plug your Ethernet into where the core is breaking out your call. And so you have no transit time between the core and the screen. So that's a noticeable win. And then the other win is, this isn't exclusively for private 5G. There are APIs that in theory will allow in the future one to do this on public networks, but you can somewhat tune the network as how many uplink slots it gives you and when. And that can tune, it doesn't save a huge amount, but it can save a few milliseconds of getting an uplink slot sooner for each outbound packet, uplink packet. So, and if it's a private 5G, you can mess with it. I mean, the thing about this camera, right, is that it's an uplink device. Like, in contrast to almost all normal 5G usage, which is essentially downlink, this is uplink. So if you can tweak the parameters such that it's more uplink friendly, there's a win there. So after all that, ta-da, we got 170 milliseconds, which is nice. But you can't ever get all of it. You can get close, but not all of it. So I have some caveats. Like I said, you can't get all of these all of the time, but you can get some of them some of the time, to sort of paraphrase. You can't always get what you want. But all of them depend on you being in control of more of the stack. Like, the more of the stack you control, the more you control which eSIMs are in there, the more you control how much the buffering is, and all of that, the more you can trim, the more you can manage this stuff. And basically, the huge takeaway message is that small wins, all the yak shaving that I've ended up doing, they all add up to actually about half Like, we've gone from 350 to 170. So like, it's a significant win in a series of quite small steps. So yeah, that's pretty much all I'm going to say, except I'm going to see whether I can actually show you the camera in action. Maybe. Let's see whether we connect. And the answer is no. Well, we are connected, actually. That's weird. There we go. Yeah. So, yes, this is me, and I'm waving at it, and it's pretty much in sync. I mean, I'm guessing that, because this is roaming, I'm guessing we're at 250 milliseconds, something like that. And then you can do stuff like just to show you, you can like change the, we can make me black and white. Or grey and grey, actually, or turn the contrast up and all of that stuff. And that's all over the data channel. Yeah, anyway, so let's see if I can get us out of full screen mode and get us back to the presentation. Yeah, so yeah, contact me, find me afterwards, obviously, on the boat or elsewhere. I'm Tim at Pipe, pi.pe. Steely Glint on Chaos Social and the Fediverse. Do consulting on open source, WebRTC, obviously Pipe, but other random things, as Dan will kind of has proven. I'm up for stupid challenges sometimes, if they seem amusing. I'm also, on the stupid challenge front, a member of the WebRTC working group. Not all of the decisions are my fault. So anyway, so yeah, questions. I'm a little bit deaf, so shout.
Actually, I think that we have a question from chat. So let me... Yeah, we have a live stream at stream.rtc.on .live, and there is a chat over there. So, question from Mate. If minimal latency is the goal, what would even motivate the use of WebRTC over traditional 5G mobile radio, which offers 10 to 100 milliseconds?
So, I don't know what your, like, I don't have the license to make phones. Like, it's a, like, we need a radio signal, okay, so we're using 5G, but if we want to use 5G, we have to use something that's licensed. And then on top of that, we've got to do something with the data. We've got to render it. It's got to be in some sort of format. And so we've chosen to use, I suppose the choice we ended up making was the fact that we wanted the renderer in the browser. So we wanted something that was browser compatible. Because what we don't want is the teams to have to lug around another device. Like, it's fine to sell them this to bolt into the car. They're okay with that. But what I don't want to do is like having to have a screen that they take round with them that has our custom software in it. What they actually do is fire up Chrome or Safari and they view the stream on that. So that's kind of, I think the answer, that's a very long answer which should be summarized as we want it to be web compatible.
Okay. Yeah, so quick question about the codec you used for this test. Was it H.264, and did you use hardware encoding on the device to get the encoding as fast as possible?
Yes and yes. I've looked at other codecs. I've looked seriously at H.265, and the hardware appears to support it, but I can't get any browser to render the H.265 it generates. I've not put enough time in to find out why, so it's on my to-do list. But for the moment, we're on H.264 with a hardware encoder. And I mean, we can, so the trick is the hardware encoder is fast enough that it will generate a frame, it will encode a frame before the next one's ready from the camera. So we can do that all in a loop.
Right, and then related to this, if you played with frame rate, we found that using much faster frame rates actually reduces the latency, which is...
Yeah, it also ups the bit rate. So the short answer is no. I mean, I've thought about it. I played with it very briefly, but the problem is that like we're on a bitrate budget as well. I mean, these things get through a couple of gigabytes an hour, which on roaming rates can get expensive. I mean, not race car expensive, but expensive. So we're kind of disinclined to push it too far up. But it's something we will test, and maybe for the autonomous vehicles, maybe the finances are different. So yeah, it's something we will try.
Very cool. Thank you.
At least 2 more questions. One over there and 3 more questions.
Can I ask?
If you have whoever has a mic can ask questions.
All right. So you came up with like 13 or so ways to shave off a few milliseconds. How did you come up with this list? And can you come up with more even? How are you going to do that?
Is there more to come out? Well, I mean, we've just heard one, and that is on my to-do list. And I think there are a few places. There's a flag in Chrome which ought to do something and doesn't. There's a play out delay hint something. And in theory, it should be the jitter buffer target depth. And I changed it, and the graph changed, but the timing didn't. And I'm like, I have no idea what happened there. So and that was only last week. So at some point, I'm going to go and bug somebody on the Chrome team and ask them to explain what I've done wrong. So I think because it was saying the jitter buffer was like 60 milliseconds, and I could turn it down in theory to turn it down to 30 and not care, or 40 maybe. So I don't know. Yeah, there are a few places still to try, but in the end, 200 is, if we can hit 200, that's probably enough.
Actually, it's a little bit related, because most of the savings I saw, it's related to jitter buffer, like the jitter, the bandwidth estimations, the RTX, not waiting, so forth. So can you just suggest to the Chromium team, because it's a pretty big market, for example, the autonomous vehicle, that let's give full control over how to set it up, so how to set up the playout buffer, because it turns out that it saves a lot, tremendously a lot.
Yes, that's something I was hoping. Well, so there's a trade-off, because as I said in answer to one of the earlier questions, we're really keen that people can just use a stock browser. So I don't want, like, in theory, I could go out and build a client app, but I don't want to do that. So I will need to use the controls that Chrome or Safari, Chrome and Safari offer me.
Yeah, because I saw that at least I think 40, 60 milliseconds you saved because you just tuned the playout buffer. If you have the full control of the code, you can write your own playout buffer, but you want it to be compatible with the browser. So it seems that we need to have more control on the playout buffer in order to reduce the delay for pretty much. And, yeah.
Yes, and there are gaming companies who'd say exactly the same thing.
Yeah,
and so, which is one of the reasons why being a member of the W3C, WebRTC working group is useful. But it doesn't, I don't make a browser, so I can't actually make things happen. I can just hint that it would be nice if they did. And then maybe they do and maybe they don't. But yes, your point's right.
Thanks.
Do you think the choice of language like Java affects the performance, or compared to something more performant like Rust or Go, Python in particular?
So it turns out that for WebRTC, there's almost no performance difference. Like, there's a startup cost in Java, which is Dan's joke about my 3-minute wait while it loaded. But that was from a 2015 SD card. So part of it was just memory read. But yeah, so it's not a performance issue, because in any sensible device, you're using a hardware encoder and you're using hardware encryption. Like, if you're not, then you've lost on a small device. The energy budget's too high. So it actually doesn't make a huge performance difference. And if I was doing it again, starting again now, I'd probably be just using it in Golang and using Panton. But I started this before Sean started Panton, and it's nice. The other thing is that it's like, it is a bit egotistical of me, but it's really nice to be able to be in complete control of the whole damn stack. Like any change I want to make, it's my problem. I mean, okay, I can't break it for other customers, but if I want to add a feature that does something for this particular use case, not a problem. I don't have to negotiate with anyone. I can just go do it.
Yeah, so you mentioned that you were able to bring down the latency to 170 millisecond, but what is the baseline? So do you know that what is the actual like theoretical minimum, let's say a ping round trip time if you were able to do some direct routing?
I don't think that, I don't think that's necessarily dominant, right? I think we've got to the point, and if you're on the 5G private network on the same core, then I don't think the ping time's dominant. I think you're now at the point of how many frames do you have to hold in this buffer, how many frames does Chrome hold in the playout? And to some extent, is there a network buffer in the kernel that I haven't managed to tune out? So I think once I've got down past the obvious network steps, I think it's at the edges and not in the middle. Now, on this one, like this is roaming, and there's probably 100 milliseconds of latency between here and there in the network. But for the rest of it, if it's a private network, that's not going to be the case. So, yeah. I don't know what the theoretical minimum is. I mean, I guess technically it's twice the frame interval. Like it's probably 60 milliseconds, 66.
So, thanks, Tim. A couple of comments here. The delay chart that you had from ChatGPT about the HESP stuff, high efficiency streaming protocol. It doesn't really use QUIC. I think that was another mistake on ChatGPT's part.
Yay! Okay.
So I mean, it just uses HTTP. So there's a separate track or representation for low delay extension. So joining another representation from the current representation becomes much faster. So that's HESP and the low delay, low latency extensions for Dash support that. So I just wanted to say that. And secondly, JP, the FFmpeg guy, has shown that with QUIC from one computer to the next over a local area network, he can transmit frames in about 16 milliseconds, which is one frame duration at 60 frames per second.
Okay.
So
the theoretical minimum is about one frame interval.
Yeah.
Okay.
And then at 60 frames per second is 16 milliseconds.
Mm-hmm.
But there's no packet loss, nothing. It's just a direct connection between two computers. And,
so I've got a factor of 10 to go.
Yeah, exactly. Tomorrow we are going to show that over the internet we can get to about a 3-frame latency, around 100 milliseconds with our current mock implementation. So yeah, I mean there is no, I guess, bare minimum, but the frame interval would be the ideal number in that case. Yeah. Thank you.
All right. Thank you for the wonderful teaser, Ali, for tomorrow's talk. Any other questions? If not, there is one more, the final one for this talk.
Okay, I have question or two questions. Have you tried different network adapters, the Ethernet adapters, like some gamer ones or maybe for server ones? It may be faster. And related question, have you tried running your application on different operating systems as the kernel may have different optimization in this network stack?
I have tried, the short answer is not really. We're not really in control over the receiving end. So typically the race engineers will turn up with a ruggedized Livono laptop, and I can't really do much with that. So I'm not, and typically runs Windows, so I'm not in control of that end of it. This end, I could in theory change the hardware, but so for example, and this is one of the things that Dan will tell you as well, that hardware, changing it is expensive. So this has a set of fins on the back which go onto the 5G modem to cool it. Okay, so the whole of the back plate is a heatsink. Now, if I change the 5G modem, we have to redesign the case. So I'm disinclined to change the hardware adapter, to change the hardware at all. It's a big cost. So I'd have to be really convinced that it was worth it. What I have done, and what's really bizarre about this modem, is there are, I think, 4 different ways of getting IP connectivity out of it. The worst possible case, which is funny but useless, is you can actually run PPP over it. It will emulate a serial port, and you can run AT, whatever it was. It wasn't E, it was C or something. But it was an AT command which just fired up PPP. And you can do that. Oh, it's dial, that's right. You could dial it. It was dial plus something. You can do that, and it will fire up a PPP connection, and it'll run it over a serial port. But you're limited to, that's disastrously slow. And then the next one up is it will emulate a USB Ethernet device. But it turns out that's not as quick as you'd hope. And then the one that we're actually using is it's emulating a PCIe Ethernet. And that's actually pretty quick, because you're on the PCIe bus. So yes, we have played with different interfaces, but actually with the same hardware. But none of those saved more than a couple of milliseconds.
All right, let's wrap it up with the round of applause for team. I'm reminding you about the QR code. And we are approaching the final talk for the day. It's going to be interesting because there is going to be 2 people presenting from Evercast, Damian Stolosz, the CEO, and David Diaz, the lead engineer. Damian is a returning speaker at Rtc.On. Last year he showed us, he already lived in future, so he's living in future, so it looks like today he will be showing us how the XR reality collaboration could look like. So let's start with a round of applause, and the floor is yours.
And, okay, good. You guys can hear me, and let's make sure this has audio out.
Oh, it's on your AirPods.
Let's have him say hi. Tell him to say hi.
He's muted.
All right, so let's switch over to this. All right, so welcome everybody. Thank you for having us again. Evercast is a company that creates software that's used for video post-production. One of our lead engineers, David, is with me here today. The thing that we're really excited about is we're one of those niche players in WebRTC, so we worked really hard for many years. The company's now 10 years old. We did our first movie about 8 years ago, which was the movie Godzilla, and it was the first time that this editor had been allowed to work for the 3 or 4 or 5 months where they're editing the movie, but being able to do it remotely. And normally you have to be on set and you go away from your family for a long time, and so this software was developed to allow a better work-life balance for high-end creative professionals who work for months and months and months on these movies, or years in some case. So we're excited about showing a couple more features that we've done to make things easier for people. We run on all these platforms, proprietary, but also works on the web. And if any of you know the post-production, pre-production, production, post-production, there's a bunch of steps in it, and we've been used successfully in many of these parts of the making of movies and making of TV shows. As of a couple months ago, I think we exceeded 700 feature films that we've been being used on, and countless TV shows as well. So with that, we're going to do a little bit of a demonstration. I'll hand it off to David.
Right. All right, so we should probably get you hooked up at this point.
Yeah.
Vision Pro. You can join us. We're going to do a little demo with him as a director.
All right, you do your part. I'll get connected, David.
Okay, great. I think we have David Zimmerman on the other end here in the room. See if we can get him. Okay, so we're going to have to control his screen. Zimmerman, are you there?
All right, so what we're demonstrating is... Oh, I don't want to be there.
You? There you go.
So what we're demonstrating here... Oh, there he is.
There he is.
Hello, our friend.
Say hi, Mr. Zimmerman.
Hello.
Great. So David Zimmerman is in Phoenix, Arizona right now, and we're in Poland. So David, why don't you show... Diaz, why don't you show how this works?
Okay, so he's running on his end an instance of Avid Media Composer, acting as, say, an editor, and I'm going to take control of his screen. First, I'm going to request. He's going to get a request over there that he's got a grant. I'm going to show us that. Good, okay, now I've got permission. Now I'll take control.
Whoa. Yep.
I'm taking control from you already, so I'll let you move that out of the way.
Let me just pull this over to the side.
Okay, good. So now I can jump around in Avid. You know, I can make some changes. And when he gets annoyed with me, he can kick me out. Go ahead and show us that.
So Damien, I know that we were talking about this little scene right here.
Yeah, he's gonna.
We can cut it out.
Yeah,
we're gonna do that separately. Once, just show us the kick feature, and then he's gonna demo from.
Go ahead and
Vision
kick
Pro.
David out. Yeah.
Oh, you want me to kick him out?
Yep.
Yeah.
All right. Real quickly, you just go right here, take back control.
So now I don't have control anymore. Nothing's working. Now we want to see your view, Damien. Do you
If it'll show up.
Yeah, let's make sure that shows up.
Vision Pro can be a little fun. Now switch it over to the other screen, David, because right now you're not showing up. Can you do the remote software so I can pop onto your computer? See if that shows up. So mirror my view. So right now I'm using the Vision Pro, and you guys can see that I'm also in the same room that he's in, and it's using this persona, so our software, is capturing all me on the Vision Pro. Directors use this when they want, what I'm seeing is like this huge screen, and so I'm seeing what they're seeing, but it's sort of like the size of the audience. And if I can mirror it out to you guys, that'd be great. But in the meantime, I can show you guys my mouse control. So what I'm going to do is I'm going to grab control of the mouse, and I have a little control here. So let's see where I've got. There we go. All right. So if you guys see the mouse moving around, that's following my hands.
Oh.
So, all right,
Oh,
David.
boy.
What were you trying to show me?
Yeah, so in this scene right here, I wanted to take this out because it slows down the pacing. So I wanted to show you. So I just cut it out, and I wanted to show you what it looks like.
No, David,
without-
I don't want to talk about that. I think I want to leave that in. Let's go over here. This is the scene that I was worried about. There's this really long linger on this one guy, and I don't think it's.
Whoa.
I think it's.
What,
Wait.
so you're on
I'm not very good
controls,
with
yeah?
Avid. Hold on.
Yeah.
Okay.
Yeah, I can see that.
Right there. Okay. No, that's not it. It's the other scene. Hold on. There we go.
Yeah.
That's the one. All right.
Want to just
There we go. So after
Yeah.
this, right?
Yep.
Okay.
What would you like done?
Okay. So that one needs to be shorter because it's killing the pace. But this is the, Spider-Man's editor is here, totally in different character, right? And so, right there, you see what I'm saying? So I don't think we should have that long a close-up on the guy.
Oh, okay. All right. So you want me to take it out? Oh, wait. Oh,
Just tighten it up.
Yep. Okay.
All right.
All right. How about this? You leave me to cut and you just direct.
Okay, fair enough, fair enough. All right, and then I'm going to try and show you guys what I'm looking at. Sometimes the Vision Pro doesn't feel like showing it, but let's see, mirror my view. Yeah, so the cool thing was, for some reason I can't show it onto that one, but in the Vision Pro, I'm able to see that, and I can read like the tiny graphic, like every little bit of the graphics is visible to me down to like the small fonts. We had a director, the guy who's doing Wicked, tweeted about this. So he was using it, and you basically get like almost P3 color space, and you get like a 100-inch screen. And so even though this seems like a really rarefied toy for a lot of people, we found like the 6 people on Earth who want to use this, and and they're using it quite successfully. So but when we were doing this, WebRTC, they were like, basically our clients were like, this gadget's going to come out, but we want a secure workflow immediately. And so we had to get it all certified and pen tested and all the scary things to make sure that you can do pre-production on it. What David recently added was a feature that we'd had a number of people request, which was essentially, okay, you've got 2 people collaborating, but it gets clumsy sometimes where you're like, oh, just give me the mouse, I'll show you what I mean. But we don't, and some people do it in a complete remote where they're using Parsec or other applications. We can skip all that and just like jump right in. So how does this work, David?
All right, so this is under a feature that we call in general App Share. That's part of our Evercast Suite offering. And basically, the basic feature is to control the mouse and keyboard input to a remote screen. This is not a particularly unusual use case, but I think we've done some interesting stuff with it. Sort of like remote desktop, but directly via your video conferencing software, which can be useful. We've got 2 variants of this. One is what you just saw, where you're controlling another participant's local system, take control, send the mouse and keyboard inputs, and with the permission of the other person, of course. And then we've got another variant, which is a sort of a remote version where we can run a virtual machine somewhere in the cloud and take control of it from any of the participants. We use data channels for low latency, more or less real-time updates for all the mouse and keyboard events. And we have some additional services along with the virtual machine itself to manage the machine, to control permissions, things like that. This is a picture of what it looks like when you're doing the local version. So you've got 3 clients over here that can take control of the screen on the other end. And essentially the messages are going from each of the clients via the Janus SFU to the receiving client. And there are some return messages for permission requests and that sort of thing. This is all via data channel completely. This is the remote version. Our back end, in addition to the Janus SFU, has a sidecar manager that we use to fire up the sidecars that run the remote VMs. They've got a little WebSocket service that allows them to manage permissions and a few other things. And then, of course, the screen share itself, it's running a headless version of the Evercast native client. All right, so what can this do? Basically, this is one application of our client, our native client, which we use on the desktop, but we also have a headless version that runs on Linux and other platforms that we can use for this purpose, no GUI. We set up a display server on a VM somewhere, EC2, or even in a container, running on Linux and X server. We use XVFB for containerized use, or we use a full X server if we need a GPU. And you can also run this on Mac OS or Windows if you want to use applications that don't run on Linux. Some example of applications is we can run pretty much any web app under Chromium. We just put it in kiosk mode. We run it in a container or directly on the bare metal. Something like SyncSketch, which is for remote content review. Frame.io, which is a digital asset manager. We can also run something like a nonlinear editor, which, as you saw before, that was Avid. That was an example of that. We also we were just at IBC, and there was a great demo at the AWS booth of running an Avid in the cloud into an Evercast room, along with another Avid running locally, and it was very complicated, but worked very well. Another example is Autodesk Flame, which itself runs on Linux, and you can run that in the cloud on an EC2 instance with a GPU. One of our interesting features is that we support deep color, 10-bit color at this time, and HDR in streams. And one thing you might want to do is a screen share along with a stream from the NLE. So you're running your NLE, and you want to see the NLE itself, but you also want to see the preview stream of what it's producing. So then you have two streams into the room from the same machine. You can take control of the screen share, and then you can just watch the actual content in higher fidelity.
And isn't some of the metadata for those, you use the data channels to send over the HDR and that? How do you get that data across in our color workflow?
Currently, yeah. I mean, we're transitioning to RTP header extension, but yes, we use the data channel for the color information. All right, so one question here is security. The messages that are used for control are inherently encrypted by SCTP. And basically, our security model is that once you're in an Evercast room, we trust you because our authentication is pretty rigorous. And if you get into a room, then we know who you are and that you are allowed to be in that room and allowed to control the screen if it's a supported feature in that room. One of the shortcomings here is that the permission is enforced by the client itself, the sending client, which obviously is not, in an untrusted environment, that would not be great.
So for instance, I was able to take over his screen. The Vision Pro is kind of God mode. And so I was able to just grab the mouse. There was no pop-up. So the stuff that he showed wasn't enforced.
Exactly. Yeah, that's right. And then in addition to that, Janus doesn't support data channel messages sent to specific participants. So any data channel message you send out is broadcast and it goes to everyone, which is useful in the case where you want to show everybody's mouse at the same time. So we can have a cursor for everybody controlling the screen like you have in Miro or Figma, et cetera. But at the same time, that means that every message is going everywhere so that if you type in a password, you could see that. You could intercept that in theory, of course. So some of the mitigations that we've considered, one is obviously implementing selective data channel destinations so that it's not broadcast to prevent the message from being intercepted. We could do some sort of key negotiation between individual participants and encrypt the messages themselves. And we could enforce remote control permission on the receiving end, which is obviously we do that partially in some cases, like for example, in the case you saw where you're controlling the other person's machine, they have the option of kicking you out. But we could do that for all control messages. And we could use some sort of client identity verification using a signed token of some sort.
This becomes interesting. We're releasing a feature early next year. So if you guys have all used Figma and some of these modern apps that have a sort of follow the leader mode or a a mode where everybody can disconnect and kind of play with the content independently, but then they can reconnect and say, I actually want to follow what that guy's doing. We're implementing that and using a similar architecture. You'll get that experience of if there's 10 people in the room, you got 10 mouses. You know, the mice are everywhere. But if you want to go, okay, I'm taking control, you all have to follow me, or you go, you know what, and so one of the features I'm super excited about is like, you know, if we were all looking at a PDF and you guys are like, I read a lot faster than this guy talks, you guys could just go next, 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 and then you can go back to checking your feed or whatever. And then, but the, guy can plod along, and if you're like, no, I want to follow, or, oh, I'm too far ahead and he's talking, now I want to snap back to where he is. So these are some of these features that we're using. There's a lot more collaborative, synchronization, and it's much more like a multiplayer game, and we're using WebRTC, obviously, because of the fact that, it punches UDP into a web browser.
Correct. All right, and just a little aside here. So we've been talking about uses of the Evercast client. That's one of the primary use cases is app share. But we also use the Evercast client for recording. We fire it up in graphical mode on a server, and we connect to the room, and we record what's in it. We also have, this helps with, because we don't just support WebRTC, we also support streaming files directly from remote assets on a DAM, a digital asset manager. So if you were to just record WebRTC streams, then you wouldn't get that information, but we support that using our client, which inherently supports those types of streams.
Last year there was a talk where they were talking about using GStreamer and like kind of analyze the different ways that you could do a recording, but because we already use basically non-WebRTC media, and then we're increasing our use of that in order to get that perfect playback of like, well, what did everyone see? We have to do, we basically took our client and did a Linux, embedded version sidecar.
Right. Thank you. I was hoping that you could get to see the Vision Pro on the screen,
I think
which
I
was
know what
unfortunate.
it might be. It might be that it defaulted to Ethernet. That's my guess as why it's not showing up. But I'm going to see. A network. This is my one try, and then otherwise we'll let you go. So where's network? Network. Wi-Fi connected. No, it's Wi-Fi first. There's no Ethernet.
Yeah.
Right? Give me one more. It's punched
You
in
wanna
there.
try,
and then
native?
and what's that app?
Reflector.
Reflector. Oh yeah, it's right there. Give me one more chance. Demo gods, I pray to you. Okay.
We're essentially airplaying to the MacBook Pro, so that can be a little
Mirror
bit
my
finicky.
view. There we go.
There it is.
All right.
So
Boom,
I think
boom.
Zimmerman is probably not in the room anymore. But
Okay, we'll see if you can pop him back in if you want to chat with him. So this is what I see, and then if I go back, hold this down, here's my really huge Evercast. So it's cool, I see that in front of you guys. All right, I'm back in the room.
we can get him.
Mute me. Boom. All right. Yeah, now you know, guys. And then, let's see. No, it's so intimate. One thing you'll realize when using these Vision Pros is it's just, yeah. Oh, there we go.
There he is.
Hi there.
Can we see your Avid?
We want to go back.
We want to go back.
You're muted.
You're muted.
Or you're not. See if-
Yeah, give me 2 seconds.
Okay, pop
Okay,
in.
pop in.
And it kind of
It kind of remembers where you are. Like if I walk over
here
here and I go,
Oh, there it is.
oh, there it is.
Okay.
Okay.
Are you resharing,
David?
In a second, my Avid crashed on me.
Oh, okay.
Demo
guys.
Demo guys.
Well, they let us get one
part of it done.
Yeah.
Unfortunately, that's not my experience.
And I'll use this to say, so one of the features of our company is we have 24/7 support, which is kind of needed in our industry. And we spend a good deal of our time supporting other people's software. As one could imagine. It's just sort of like good bedside manner.
All right, it's coming in right now.
There we go.
There we go.
Okay, good.
Okay,
and you
good.
Can see
and
there's
you can see there's my God mode controller. Boom.
So what I'm doing is I'm dragging this little thing around. And wherever I drag it, that's where I go. So if I want to play this, I pop it there.
You can imagine this is pretty big, but in his view, it's taken up most of the room, right?
Yeah, it goes to like here to there. It's hard to explain, but I mean, you guys can kind of see me. Oh, that's cool. But I can read all the text down to America, Phoenix, Los Angeles, New York, London. Oh, you got the time zones. It's an editor thing to need. Oh wow. I didn't know I could control his whole computer. Oh,
Yes,
that's
you
great.
can.
Oh, that's messed up. All right.
We trust you utterly.
Yeah. All right, that's the demo, guys.
Thank you very much, Damian and David. Are there any questions from anyone? Gentleman over there.
Hello. Just looking at your setup, it's very much a traditional VNC setup at the gist of it. And looking at your stack, being quite familiar with it myself, I'm noticing that there should be quite a bit of noticeable latency when using it. And latency is something that's very, very non-tolerant in applications that are interactive, like VNC. What are some steps that you've taken, and what are some steps that you think you might be able to take in the future to minimize this latency in the stack that you've chosen?
Okay. I'm not sure if you wanted to say anything because I can't see your eyes.
You go ahead. Yeah.
Well,
I'm gonna go in a snowstorm.
one of the points of Evercast is that we require a low latency, high bandwidth connection in the first place. So just by the nature of the connection, it isn't much of a problem. One of the things we do is we use AWS features that allow you to connect globally from wherever you are and get routed directly to the instance where we're running our SFU, which reduces latency quite a bit. So you're running on the AWS network as much as possible. We try to keep the server itself as close as possible to the user, which is mostly the West Coast of the US, since we're talking about Hollywood largely. Although we have a lot of customers in the UK and Europe as well, so we put servers in the various regions to keep them close, reduce latency. And in terms of AppShare itself, we run the VM right next to the Janus instance. So the latency between the Janus instance and the VM itself is pretty much negligible. The whole latency is from the end user to the Janus instance, approximately. So that keeps things
I want to throw in,
tight.
so one of the things we implemented as well to reduce that latency is a concept of app share, where we ran a sidecar next to the Janus instance, so another EC2 right there, and then we ran some web apps on it. It was really interesting because it obviously cuts your round trip time, and this was the one he was talking about where we had a request from a client, can you please run, was it Nuke in the cloud? Or what was the app that we were being asked to run in?
Flame, Autodesk
Flame. So Autodesk Flame in the cloud, and then everyone had half the latency because it's running cloud and we're going straight to it. What you will notice, like you said, it's an ordinary VNC, and I kind of started to stress about that because we use VP9 as our universal, but it's sort of like everybody's dialed in and expects that, and so we're not doing anything clever about like, well, that's actually a user interface. We're doing none of that. It's pure VP9, so it's assuming natural images. But that's okay because the money You know, the thing people care about is the talking heads and the video. And so if it's kind of a little blurry on the text, it doesn't matter. And then if I go back to like one of these controls here, like grabbing this, you know, your mouse is always going to lag, but this is, you know, up to, where would the server be? Would this be Oregon?
This one, yeah, I think we're running in, yeah, West
So this
Coast.
would be AWS West Coast. So the packets are going straight there, and then they're going to Phoenix, and then so forth. Zimmerman, what's your ISP? Do you know who your ISP is? Maybe he'll text us. But you know, bottom line is that's what we know about that.
So this is about the highest latency you're going to get, because we're going halfway around the world to move the...
Awesome. Thanks for your answer. And just for inspiration, I feel like this is a use case where it's very similar to cloud gaming. So if you're ever looking at this problem in the future, papers published and talks given by people who work on cloud gaming would be very, very useful, I think. So, thanks.
Any other questions from anyone? If not, let's give a final round of applause for today.
Thank you. Thank Mr. Zimmerman as well.
We reached the end of the day one of the third edition of the Rtc.On conference. 3 maybe 4 even housekeeping updates. The first one, the QR code. The second one today is the party day. So there is a boat party. It starts 7 p.m. There will be some refreshments served. It's like 20 minutes walking distance from the office. As far as tomorrow goes, we're gonna start a little bit later than today because of the party. Why not? So 10 a.m. we will start with a breakfast and whatnot. The first talk is going to be 10:30. And don't forget to bring your badges. That's it for today. Thank you very much.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.